dignitaries, participants. I hope you all are rested well and all set for the day 2. Welcome once again. Welcome back to the day 2 of the Indo-Global Irrigation Summit 2025. Ladies and gentlemen, after a very thought-provoking day of high-level dialogue and Platinum Jubilee celebration yesterday, we now turn our focus to the field where ideas meet innovation and research meets real-world application. Today's technical sessions will spotlight path-breaking work from across India and the world in advancing irrigation systems, geospatial technologies, and inclusive water management. We begin with a deep dive into cutting-edge innovations transforming the irrigation landscape. Our first technical session today explores the technological and scientific breakthroughs that are redefining the irrigation sector, from smarter water delivery systems to AI-powered solutions and precision farming tools. As climate variability grows and water becomes increasingly scarce, innovation will be our strongest ally. We are pleased to welcome eminent speakers and industry leaders who will share transformative solutions and field-tested technologies shaping the future of efficient, resilient, and sustainable irrigation. Let's begin our first technical session on the topic, technological developments and scientific innovations in irrigation sector. Please join me in welcoming on the dais our Honorable Session Chair, Shri Vivek Kapuria, Ex-Secretary, Water Resources Department, Government of Gujarat. Thank you, sir, for joining us, and thank you for your time. Now, for rest of the session, I hand it over to our session chair, Shri Vivek Kapuria, with his opening remarks. Thank you.
Thank you for kind words. As we have 90 minutes for this session, and As we have 90 minutes for this session and 8 speakers are there, I know all the 8 speakers are technology spearheaders and they have a lot of stuff to share with the intelligentsia present over here. But looking to the constraint of the clock, we have decided to share 10 minutes to each of the speakers. So first I'm inviting Mr. Anil Kapuria from Rungta. He will be making a presentation on modernization of irrigation systems, improvements in conveyance efficiency. Welcome to Mr. Amit Kapuria, please. I request all the speakers to kindly honor the call of the clock. Exactly at 9 minutes, I shall give you a sound. So you will please wind up in another 1 minute. So 10 minutes are sharply to be followed. Thank you.
I'll try to finish within 10 minutes.
Thank you,
sir. Good morning to all. Myself is Amit Kapuria from Rungta Mines. I think you all know about Rungta Mines for TMT and everything, but now we have started manufacturing DI pipes. So basically, our presentation we have tried to give in 2 parts. First, in briefly about Rungta Mines, and then obviously on the subject how we can make a more effective transmission in the irrigation water pipeline. So I'll just go on the slide first. Rungta Mines is one of the fastest growing company of the steel industry involved in the manufacturing of steel power and value-added steel product since 1962. The company initially began with mining, has now evolved as a prominent player in the steel sector, operating under the brand name of Rungta Steel. The company has diversified its product portfolio to include a wide range of steel products. As an integrated steel product, Rungta Mines Limited has state-of-the-art manufacturing facilities located across Jharkhand and Odisha. In fact, our DI pipes are manufactured in our Jharkhand unit only. This is basically our manufacturing unit. Our head office is in Chaibasa. We are based in Chaibasa. And then Chaliama Steel Plant in Jharkhand, then Karakhendra Steel Plant in Barbil, then Jharvand in Odisha, Barbil, Odisha, and district Sundargarh in Kamada Steel Plant. This is basically our initial products. I have not mentioned ductile iron pipe on this. Our initial was TMT bar, wire rod, HB wire, MS binding wire, nails, and MS stirrups. Then DRI, MS billets, fly ash bricks, pellet, cement we have recently started, and power. So this is, I'm just briefly mentioning about the Rungta's DI pipe manufacturing capacity, so that while I'll go into the presentation technical part, you can easily correlate it. We have 5 lakhs MTPA for diameters ranging from 80 mm to 1200 mm. Our product is having BIS license. In fact, without BIS license in India, nobody can sell a DI pipes. The salient features is, obviously, I think everybody knows our product is backed up by one of the among largest integrated steel manufacturing country, having its integrated steel manufacturing facilities with large reserve of iron ore. Iron ore is our own product. Rungta Mines has vast technical expertise in mining and mining operations. Annealing furnace is the latest technology. Annealing furnace, as we all know, it basically requires to distress the pipe. Centrifugally cast cement mortar lining, which offers C value is equal to 140. That means more water with less power. And the quality assurance laboratory is NABL accredited. These are the ISO 9001, 14001, 45000. These are all standard, but we have already received all these things in a very short time. This is the Government of India trademark. This is the Rungta DI pipe is our trademark. And this is the list, which is very important. Within a very short time, I think 8 months or 9 months in our production, these are the empanelment we have already done all across the India. We have in all around India. In MJP, we are already approved, Pune Municipal, then Madhya Pradesh, Rajasthan, West Bengal, then Kerala, everywhere in stock. So now I'm coming straight to the subject. Sir, jaise bataya ki we will hardly take, he'll allot only 10 minutes. The improvements in conveyance efficiency, as we all know, 2 types of conveyance are generally covered. One is the canal open system, another is the pipe system. And why I have mentioned ductile iron pipes, that is basically the DI pipes are now widely used for the conveyance of water in the irrigation project. In fact, Kapuria sab ke project mein hum logon ne kafi DI pipe also we have used. So the conveyance system, as we all know, assures the transport of water from the main intake structure or main pumping station up to the field ditches. The distribution system assures the transport of water through field ditches to the irrigated fields. Conveyance efficiency is the ratio, as we all know, water reaching the field and the water conveyed from the source. Improving conveyance efficiency in irrigation system involves optimizing the delivery of water from the source to the fields, minimizing losses like seepage and evaporation, which has happened in canal-based system, and maximizing the amount of water that actually reaches the crops. This can be achieved through various techniques, including lining canals, adopting micro-irrigation system, and implementing water management strategies. This is basically, I have highlighted the methods for improving the conveyance efficiency. One is the canal lining. I think most of the states has already adopted the closed conduit system, that is through pipes, but there are a few states which is now still adopting the canal-based irrigation system like UP. So these canal lining canals, especially in areas where sandy soil significantly reduces seepage losses, improving the conveyance efficiency. Closed conduits, as I told, using pipelines or closed channels instead of open canals, minimize water loss and leakage. In fact, in one of the projects where we are comparing open canal system versus closed conduit in my earlier organization, we have seen that at least 70%, 80% efficiency, even 85% efficiency can be achieved through a closed conduit system, but which is very difficult to achieve in a canal system. I think canal system may more than 50% is a very tough target to achieve. Then regular repair and maintenance, regular maintenance of canals, including clearing vegetations and repairing damages, is crucial for ensuring smooth water flow and preventing water losses. In fact, in one of the project in Rajasthan where Indira Gandhi Canal, I was personally visited there, I have seen that people are taking water from the canal itself illegally. So water efficient irrigation methods, this is adopting micro irrigation techniques in, I think, In Gujarat also there is a guidelines has come that micro irrigation has to be there, like drip and sprinkler irrigations, which deliver water directly to plant roots, minimizes water loss and improves efficiency compared to traditional flood irrigations. Water management strategies, implementing effective water management practices, including optimizing irrigation scheduling, reducing water pollution, and reusing or recycling of water will contribute to improved conveyance efficiency. Rehabilitation and modernization, rebuilding and updating older irrigation networks will improve their performance. Precision agriculture technologies, utilizing precision agriculture techniques such as data analytics, GPS technology, and remote sensing nowadays has come up, will help monitor and manage water delivery more effectively. Erosion control, as we all know, canal-based system erosion is a big problem. Implementing erosion control structures like drop and shoot spillways will help prevent soil erosion in canals. Designs, regularly evaluating and addressing design flaws. I tried to identify the issues, and then minimizing the runoff. Proper land leveling and contouring can prevent runoff and ensure that water reaches the crop effectively. So the benefits of improved conveyance efficiency. Water savings, as we know, water is now a precious item. Reduced water losses translates into significant water savings. Increased crop yields, more efficient water delivery can lead to increased crop yields and productivity. Reduced environmental impact, water conservation through improved conveyance minimizes the negative impacts of excessive water withdrawals on the environment. And lower energy consumption, reduced water consumption can lead to lower energy requirement for pumping and water distribution. So now, why I am tried to relate this with the ductile iron pipes. As we all know, unaccounted for water through pipeline leakage is a big issue where if we give a 100 mld input into the pipeline, maybe in output we'll be getting say around 80, 70 mld due to water losses in the transportation and leakage and everything. So the advantages of ductile iron pipe or transportation of water is laying and jointing is a very easy and fast assembly without needing any skilled labor or special equipment, and capable of being jointed in all weathers. Leakage, strong material properties and flexibility of joints contribute to prevent the leakage incident on buried ductile iron pipes. This is one of the most important points, that leakage can, practically leakage in ductile iron pipes is almost nil. Durability, a service life of around 100 years as per the American Water Works, is commonly recognized for ductile iron pipes buried in usual conditions. However, the service line can be reduced depending on the soil conditions. And the conveyance capacity for a given nominal diameter, because centrifugal lining is there, so pipes becomes very smooth. So ductile iron pipes are only designed with a large internal diameter in order to reduce the head loss on energy pumping because of high C value. Recyclability, excavated iron pipes can be used. Today we are talking about sustainability, so this is a very important, that excavated iron pipes can be reused as a raw material to manufacture ductile iron pipes. No material can be wasted. And obviously the life cycle cost analysis, if we go for the life cycle cost analysis with the other competitive pipe materials, so this DI pipes gives a lot of advantages. And that's all from my side. Thank you.
Thank you so much. You have completed.
I think
in
10 minutes
time.
I have.
Yeah.
Yes.
That's why I'm congratulating you very effectively. Yeah. I shall invite, the next speaker now from L&T. He is Mr. Devanand S., who will be making a presentation on presence and capabilities of their company L&T in the irrigation sector. Welcome, Mr. Devanand. Yeah.
Very good morning to all. Good morning, Chairman, and all the delegates. L&T, known for its 88 years or 89 years, we are crossing in all sectors in India. So in that, basically, I'm going to talk much about on our presence in water, more focus on our presence in India for the irrigation facilities. We divide our business into three segments. we are doing water and wastewater, where we more commonly use for municipal, for the government of India and states municipal water treatment plant and providing water supply. Again, we are dividing into rural water and urban water based on the population. And wastewater, we were there clearing the wastewater, even the conveying wastewater and treating the wastewater and recycling water. In that business also we are doing it. We called it irrigation business as a large water because we are handling the much more volume of water. That's why we are normally calling it irrigation. It's a large water system. Then in large water system, we are also having the treatment plants, industrial related treatment plants, purification, reuse of water, all other things we are doing it. We were there in smart infra also, where developing industrial estates, making the ducts and making all the utilities in one place where the industrial development will happen. And our presence in their international market also. We are already doing water jobs in other international jobs. Our presence in, now I am talking only on, as a L&T, our presence is everywhere. But in water, we were there at Qatar, Oman, UAE and Saudi Arabia and Tanzania and Sri Lanka. Already we are doing the water projects. And now we are also focusing on irrigation. Wherever the opportunity is there, we want to do the business in international, where irrigation facility we can able to contribute. Now I am coming our, we as a L&T, so far we are able to do it 11,000 MLD treatment plants for India. Pipeline network, 4 lakh kilometers of pipe laying network has been did, and the sludge treatment plant 496 MLD. So far we were able to do it. Even we were there in desalination and irrigation 1.4 million hectares. So far we brought the water to the farmers. I can say up to that level. And we have treatment plants, and we are able to generate power through the treatment plant. Now green energy we are making it with 815 MLD. What wastewater treatment plant, we did it 2800 MLD, and we served more than the 150 million people on that. Industrial water effluent we are treated in 215 MLD. Now you see, this is we were there in barrages. We are constructed barrages, and we were there in the canal. Not only this canal, I can able to tell, I want to appreciate the way the governments and supporting it's happening. Normally canal, land acquisition, completion of the project, it will take much time. But I can say this Upper Indravati canal, which having a combination of not only gravity canal, we are lifting the water by gravity, we are transporting the canal, but all the distribution and sub-distribution networks are piped network by gravity, using this gravity force, and we are providing the water through piped network. And even irrigation, there is a real challenge. Hardly we will have 5 months in a year we will get the working time. One is the project pipelines are going, or canal is going in the agriculture field. We need to wait for the crop season. Then there is a monsoon. All the facilities, effectively any job we are doing it, that is this 58 kilometers of canal and around 500 kilometers of pipeline, we are able to do it within 5 years. That is one of the project in Orissa, fastest irrigation project completed on that. What I am telling, government also more interested and supporting, people are also coming forward, and it is very easy for like L&T company, we can able to complete the projects in time. In Bansujara, we did the same canal network. We constructed the balancing reservoir. Through balancing reservoir, again piped network, it is reaching up to 1 hectare chuck. This is in Madhya Pradesh. And we did it Kundalia irrigation projects. The entire thing, it's a piped network. That is also pressured distribution network. Even we are bringing the water with 1 hectare. And those water also we can have a control system. It is operated purely on SCADA system. So where, based on the demands, we know very well how it is, when the water is needed. When the calendar, we can put the farmer when they will get the water on that part, and we can able to do it. And it is successfully running at 130,000 hectares. We are able to do it both the Kundalia left and right projects, which is already people are started getting benefit last 3 years. So what I want to tell is the transformation is already happening in India, and we are going up to that, and we are able to complete the projects in time, and people are started getting benefit out of it. Our capability, we have our own, the biggest strength for us is we are having our own engineering design team, and we have any design we can able to provide, and any solution we can able to do it on that part. And the projects are now able to complete in time. Basically irrigation, it's matters of levels and how it is reachability. We were using it, came from conventional survey. We started using LiDAR survey, which is time saving. 3-4 months we can able to do it, even 5 lakh hectares of survey, and we will have sufficient data to have a better alignment, better efficiency. So it is helping. We started using LiDAR in all the years. Integrated project management, we have, being in L&T, we have our own technology, and we were there in information technology also. We have all our internal systems are well governed, and we using digital tools, IoTs, for the efficiency and transparency, and we are bringing it. And we are started doing all the irrigation projects, even all the water projects. It's combined with operation and maintenance. We developed our capability, and we are doing it. Even I can say, if anybody knows Tirupati water supply project, the entire Tirumala Tirupati, this last 20 years, providing more than 25 years, we are only maintaining the entire water system. That is the way we developed. And we have research and development. We started on water. We have constructed with whole capability. We have kept more scientists on that. We kept water technology center at Kanjipuram, which we are focusing both the ways. Now more focus on irrigation, how we can able to serve people in a better way, effectively and efficiently. Our presence, that is what the breakup I given, 1.3 million hectares. Our presence in Madhya Pradesh, 8.5, almost 8.5 lakh hectares we have completed. Orissa, we were there, our presence is there, and we have there. Gujarat, almost 10 years, more than 10 years we are in Gujarat. We are doing continue irrigation projects. We able to do it 1,39,000 hectares. And Jharkhand, our presence is there. 2 projects. One is already, all the 2 projects is going to get giving the benefit very shortly. Maharashtra, we were there. We started irrigation, the initial stage in Maharashtra only. Now we are also, our presence is available. Tamil Nadu, yes, we did it, one Atikadavu Avinasi project. It is 60 years dream project to bring the water to the ponds, and by improving the groundwater table, it is more successful, and it is running very smoothly. This is what our presence in state-wise. There are other things which I explained in my previous slide also. Even the barrages, we constructed the Mukambu barrage and Upper Indravati, Banjujara, which are all told. Here only the pump houses, which nowadays it is coming in Madhya Pradesh initiative, government initiative. VFD, we are making it where the variance frequency, wherever the, based on the water levels and the consumption of power supply, we can able to reduce it. So only demand period, we need more pumps. Where the high level water is there at the time, we need run the pumps in a slow RPM, where we can able to control the discharge. Same way the power saving, we can able to do it. That we are doing in VFDs. So that level also improvement is happening. This is one typical project.
Now 1 minute, please. Yeah.
Yeah, I'll close it. This is the typical projects which we come across with the, always the water dams will be there near forest area, and it is the LiDARs are really helping us to make the best alignment and best solutions, which we are using it. It is one of the typical project in Madhya Pradesh. And this is including, nowadays it is coming the turnkey project, including power supply. It is responsibility of contractor. which we need to have a capability of doing transmission line and substations, this is the way the projects are coming. That is why completion it is possible. This is some of the typical other projects where we have to lift the water in Kundalia left bank, where the higher capacity, I think this is Asia's third highest reservoir we constructed, elevated. From there we are giving the pressure distribution system. And this is one typical where we brought SCADA control room and outlet management in where we are doing it. This is the way the transformation it is taking place. Canal, now we brought the water up to 20 hectares check, then people are accepting it. We gone to 4 hectare, now it is 1 hectare. The future is going to be there. We need to use the IoT device for soil, moisture, environment. So that way we can able to do it. And this is the challenges which we are normally having. This high irrigation, major irrigation projects having high energy demand, less recovery cost, which we are focusing on that, how we can able to make it happen. And the real challenges in India is there, 18% of GDP is from irrigation, 40% of the people depend on irrigation, but per ton, it is only, we are getting it per hectare, we are getting only 3 tons. It is very, very less, 3 times lesser than other countries, developed countries on the irrigation, where it is more important for scientific and mechanized and development. In that time, almost water user associations, and this is what the typical, how we were there in solar plants, floating solar plants also we are there, which are all the solutions is going to help future irrigation with lesser cost. So this is what the slide which I told, say where the graph it says, and where the technology is not available in irrigation, which need more technology has to come, more digital has to come for improvement and efficiency. And here the farm sizes of 1.1 hectares only for farmers, we are using it. Where other countries there, it is very challenging to making the cooperative farming and doing it. And so I'll be concluding my this. We started our outlet management and integrating for soil, other parameters. These are all the real smiles from the farmer after getting the benefit out of it. All our project photos, and after the people benefit, this is what. Thank you for patient listening, and thank you for this great opportunity. Thank you very much.
Thank you so much, Mr. Devanand, for making a large print of your company L&T. Now I'm inviting Mr. S.P Jadhav from Jain Irrigation Systems, who will be speaking on cropping pattern based value creation of few major irrigation projects in India. Mr. Jadhav, please. Yeah, welcome.
Good morning, one and all. Mr. Jadhav could not make himself available for this presentation, so I will be presenting on behalf of him. My name is Abhijit Joshi, and I am looking after technical services at Jain Irrigation Systems Ltd. Well, one of the basic objective for any irrigation scheme is having a prosperity of the farmers. One of the objectives is like you need to increase the farmer's income, add more value to his crops. So this paper is an effort to look into that what are those factors which will probably add the value to the farmer's income. Well, my earlier speaker, Mr. Kapuria, already talked about different irrigation methods, but I'll just have a look into it. There are 3 ways through which we can convey the water to the farm. The first one is very conventional one, which is the canal irrigation systems, and the overall water use efficiency in a canal irrigated project is around 34%, and Government of India is envisaging to improve this water use efficiency up to 55%. So in order to improve the water use efficiency, government has now added PDN, and Kapuria sir is rather helping us to do those PDNs in Gujarat. In PDN, as our earlier speaker were talking about, we are bringing the water to the closed conduit networks till the farms. But still, we are reaching to the farms and not to the roots. So what are those factors probably which can add more value to the crop is having better water use efficiency, irrigating more or improving the crop water use efficiency by adding less water and getting more yields. So for that we need to probably add one of the major component, which is addition of micro irrigation systems to it. So PDN along with micro irrigation, integration of PDN with the micro irrigation system is probably the key. But is it still enough to have a PDN and a micro irrigation system to improve the farmer's prosperity or increase his income? Probably not, and that's what we are trying to present through this paper. What are those factors which probably add, or what are those parameters which probably add to the value creation at the farmer's end is selection of the crop. You know, having a PDN, having a micro irrigation system and irrigating to the old conventional cropping systems is not enough, probably may not add some income to the farmers, add some more yields to him, but probably not add much value to the project. So one of the major factors is selection of the cropping pattern, which if you provide a dependable water supply, definitely farmer can go and adopt for it. Water management practices is one of the important factors, which I was talking about, the addition of micro irrigation systems along with the project. Fertigation and nutrition management, that this is an important factor. You know, just adding a water is not enough. You need to add fertilizers. A proper nutrition management shall be the factor, one of the major factor which shall be a component of any PDN project, any PDN along with the micro irrigation project. We have taken 3 states as an example, as a study, and let me clear you that the data which we have fetched is through the websites. Unfortunately, the detailed cropping pattern data was not available, so we have considered the most popular crop in the command area, and we have considered that crop as a basis for the study. In Maharashtra, if you look into this, there are 5 projects which we have considered: Ujni, Jayakwadi, Upper Varda, Pench, and Hatnur, which is in Jalgaon district, my district. So if you look in the cropping pattern, the most popular cropping pattern in the command area for this 5 project is, for Ujni it is sugarcane, for Jayakwadi in Upper Varda, which is in Marathwada and Vidarbha area, cotton, Pench, soybean, and banana, which is in Hatnur or Jalgaon districts. So if you look at the last column, what is the value created? Yesterday we were talking about the water productivity. Mr. Veem was stressed more on the water productivity and how much, we are getting an yield per meter cube of water. So the value addition per meter cube of water is for sugarcane, it is 41. And if you look at the Hatnur, which is banana growing area, which is 117. And what's the reason? We are not getting more value for the crop like cotton and soybean, but we are getting very high value for crop like banana in the same command area and for sugarcane, because over the period, although these projects are very old projects and conventionally canal irrigated projects, but over the period, farmers have adopted micro irrigation system as an important component for these projects. They themselves adopted, or Government of India, Government of Maharashtra supported them to adopt. And that's why probably the value has been added to these projects, which we can look into. If you look at another state, which is, I'm sorry, there's a typo mistake, but it is Madhya Pradesh. And in Madhya Pradesh, majority crop is wheat. And if you look into all these projects, Tawa, Gandhi Sagar, Barna, Upper Ganga, they are all growing majority wheat. And wherever there is a small component of, micro irrigation is added, you can see the major value addition there. Like if you look at Harsi, it is around 15 rupees per meter cube of water. So that's an important thing, because Madhya Pradesh, in Maharashtra, the adoption of micro irrigation is on a higher side, whereas still Madhya Pradesh is working on it. Although in all these projects, Madhya Pradesh has an approach of resource to farm and not to the roots. So they are providing, the government is providing water to the farm. Now it is up to they are advising the farmers to utilize the advanced irrigation system, micro irrigation system or sprinkler irrigation system, but it is still not mandatory. And farmers are still using or going with the same flood irrigated methods. And that's why probably they are still not, although the water is reaching to the farm, although they are saving much water's efficiency is improving around 58 to 59%, but still there is a lot of scope to add into it, and we can go up to around 80 to 89%, 85% of the water is efficiency if you adopt the micro irrigation systems. And look into the Gujarat, Kapuria sir is here, and we can look into Sardar Sarovar. The major crop is cotton, and the value addition is 17 rupees. And again for Ukai, which is around which is dam near Surat, the similar crop, the crop is still cotton, but the value addition is not much. Why? Because of the wastage of water in Ukai area. It's like around 1/3 of the area is waterlogged. Farmers are putting much water to their crops. Whereas in Sardar Sarovar, which is a future-ready kind of a project, and it has a component of PDN added to it, and farmers are adopting micro irrigation along with it. So you can see for the same crop in Gujarat for cotton, the value addition is much more as you compare with the Kukai. So as I mentioned, the assumptions which we have made is the data is fetched from the websites in all the states. So why we need to think about changing the cropping pattern, addition of the new components like fertigation, nutrition, along with the PDN network plus micro irrigation is because you need to add more value for crash crops. The changing the cropping pattern is most difficult thing in a command area. Farmers are conventionally doing some crop and they don't want to switch over to another crop. The major reason is they are not believe on you. They don't believe on you. They don't believe in the government that they will give some dependable, reliable source of water whenever it is required. Because most of the systems are still supply-based systems and they are not demand-based systems. So this is one of the major factors that if you want to change the cropping pattern in a command area, probably we need to think about how the systems can be demand-based and how the water will reach to the root, from resource to root directly. And what are the limitations when we think about is reliability, as I mentioned. The water supply probably shall be on demand. High investments in cash crops, like if you want all the farmers to grow banana or sugarcane, probably the investment costs are very high. Farmers are not ready to invest in that. So they want to go with typically conventional crops like soybean or cotton or something like that. And what is the way forward? As I mentioned, identify the potential sites wherever it is possible to change the cropping pattern. Carry out the socio-economical, because most of the time we are considered or limited ourselves to the technical survey, and some up to some extent some economic surveys are also part of the any irrigation project. But we need to think about what is the existing cropping pattern in that area, what are the different crops can be adopted considering the climatological factors in that area, and how the farmers are ready to adopt those kind of crops. We need to design a system future ready, because we are all talking about having different IoT components, having some drones and some satellite imageries to help the farmers to make the decision support systems. But is the hydraulic of the system is ready to adopt those kind of changes if it is required? So that is also one of the important factor. So our systems, while we design our large irrigation schemes, shall be future ready. And that's why we are saying that we shall limit the project area around 5,000 to maximum around 10,000 hectares, because those kind of or those sizes of the areas are easily manageable. If you look into like lakhs of hectares of area, it is very difficult to get in or manage those areas in a remote sites. So that's what probably I would like to say, and thank you very much for this opportunity. And I'm borrowing this 2-3 minutes in my next presentation, sir. Thank you.
Thank you. Thank you for giving me 2-3 minutes extra. I'm Abhinay Patel. We basically are pump manufacturers with latest technology as our queue. Our plant is based in Ahmedabad. I think there is a slight lag in this thing. So this is our plant. Our plant is in urban city of Ahmedabad. Our installations, we are a new technology pump manufacturer. Our USP is least gestation period, economic, capital cost, lowest life cycle cost, and the ability to mitigate climate change problems. You will be able to tackle water from wherever water is there. To that extent, let me show you some of the projects which we have done. These are our test benches. These are our variable speed drives. We have variable speed drives up to 3 megawatt within our plant itself. We have been awarded as the best quality pump manufacturer from Bharat Heavy Electricals Limited for our contribution to silt-resistant pumps for drainage and dewatering of Indian hydropower stations, wherein up to 5,000 ppm silt is encountered in the Himalayan basin. These are our certifications. I'll show you some of the installations which we have done. This is India's oldest hydropower station, 150 megawatt Tata Bhira hydropower station. They run out of water after the monsoon and have to depend on coal fire power station to generate energy and give it to Bombay. So they wanted to transfer surplus water of Konkan region to the dam so that they can generate energy. But the benefit cost ratio of this project was low. So they wanted to have a least life cycle cost pumping station. That's where we could help them. This, you see, is a very fast flowing river. We just have asked them to make a barrage where our pumps are installed. Nothing more, nothing less. It is extremely low on the civil cost component. It's a very fast flowing river. We have not asked for any extensive civil structures. We have been able to cut down 90% of the capital cost of the entire project. These pumps run since last 20 years and transfer in excess of 5.5 cubic water for hydropower generation for Tata Power Corporation. These are our pumps in MP, pressurized distribution network, Hirwar. This is the intake well. Our structures can be extremely light because our pumps impose very low light loads. These are 1400 HP pumps. This is a project where Mr. Kapuria has been my client also to an extent. We have been able to link two canals, the Mahi canal at the bottom and the Narmada canal on the top. This greenfield pumping station of 600 cubic has been executed by Aqua in 65 days flat from the word go. From the word go, we have been able to Navneet play nahi ho raha yaar. How do I do that? Unfortunately, all right. This project is really what Navneet, play Karan bhai. ठीक है. Basically, our technology has helped commission this greenfield pumping station in 65 days, 600 cubics. He is my client over there. This is the Gujarat water supply grid where our variable speed driven pumps operate from 16 meter to 69 meter head variation since 11 years now. This is a project which we have done. This is India's largest integrated energy park, 1680 megawatt reversible pump turbines. And since these are artificial lakes, the client had to bring in 1.4 TMC of water from a distant reservoir. Where we could help the client is, we cut down the capital cost of the entire plant drastically. It is a 18,000 meter cube per hour pumping station, 140 meter head, Kurnool, Andhra Pradesh. These are our 2000 HP pumps used for your Son Kanhar. Hopefully you will commission it as soon as possible. For Hyderabad city, our pumps salvage water, dead water of Krishna river every year after the monsoon. Water level dips by 92 feet and the conventional pumps don't get the suction. So our pumps sit at the bottom of the reservoir and lift water by 8 meters to maintain a constant flow into the approach barrage. the pumping station capacity is technically 900 cusecs. You can see the approach channel. And whenever it floods, the entire pumping station goes 92 feet below water. It's submerged. On the left, you can see small pumps. On the right, you can see the large pumps. These are small pumps, 300 cusecs each. On the right, you will see each pump of 120 cusecs. This is what global climate change is doing to India. We can launch n number of ambitious projects, but you also need to lift the last drop of water from the reservoir. That's where we come. We say whether you give us a civil structure or not, no issues, unconditional guarantees and warranties for the entire projects. So 9 months a year, Hyderabad city gets water because of such low lifting stations. These pumps were developed and commissioned by us in the period of 1 month for HMWSSB. This is a project where Mr. Kapuria has been my client. It is Gujarat's highest head, 123 or 129 meter head. And as my previous gentleman was saying, it is using ductile iron pipes. This is a canal-based pumping station which was set up in the canal because the local farmers were not ready to give land for construction of pumping station outside the canal. So the client decided to make the pumping station within the canal. Because of that, the client could save in totality 88% on capex and 90% on time. The pumping station could be built within the canal. Pumps are lowered at the bottom of the canal. Auto coupling system aids pump being pulled up, pushed down. No super extensive heavy civil structures are required. And because our pumps are raw water pumps, they will tolerate any amount of silt. This is a project with L&T, Narmada River, Nand intake. To the best of my knowledge, 34 meter is the setting depth of these pumps. Right? And that's where you are using our pumps since I think 11 years now. Project pumps for Krishna Bhagya Jal Nigam, pumps for North Karanpura Super Thermal Power Station. And this is our crowning glory, India's most silt-laden hydropower station, Satluj Jal Vidyut Nigam Limited, where silt level remains above 5,000 ppm for 4 months every year. And where, except for Xylem and Aqua, no other make of pump in the world is able to last because of extremely high silt. Our pumps are running in this hydropower station. This is a sample of Satluj River water at the hydropower station. And our pumps are running over there since almost 2008 now. Right? Pressurized distribution network, our pumps will beautifully fit into it. Just make a small diggy, install the pump directly into the diggy. You don't require a dry pump room to mount the pumps. Minimum land acquisition from the customer. 1 minute, sure, fine. So these are our pumps. Our pumps carry 60 months unconditional warranty. Where we can be helpful to you is our pumps will reduce the footprint of your pumping station by at least 33%, capital cost of your pumping station by at least 50%. And because the pumps are bottom rested in most cases, the superstructures are very low, right? To the extent that this can be a simple lifting station directly onto the barrage, right? This is our pump in Kerala. The pump has been installed on boats. There is no approach road, no firm basin for construction of the pumping stations. The same pump pumps water for irrigation and seawater drainage also. Our USP is our pump's bearings are mounted deep inside the pump motor, and because of that, any amount of silt that you give to our pump is not going to cause erosion. Our efficiencies are similar to conventional pumps, but because of reduction of secondary losses, our pumping station power consumption can be 1 to 3% lower than what you can encounter with conventional pumps. Our USP in the nutshell, I can tell you, is if there is water, we can do it with minimum capex, surely the least life cycle cost, and assured water despite meandering of water courses. That's our USP. My session is unfortunately too long, so I'll just skip the rest of the session. Basically, the older generation pumps were built in bits and pieces and parts and assembled by you at the pumping station. Our pump is built up as a single unit pump motor set and tested unconditional guarantees. Right, sir? Okay, thank you very much.
Thank you, sir. Good morning again. Can I get the presentation on? Yes, thank you. Thank you. Well, we were talking about resource to root kind of a concept, wherein, in a conventional canal-based irrigation systems, integrated with the conventional flood irrigation systems, we are getting around 34% of the water use efficiency, wherein if it is a completely closed conduit systems right from reservoir till the root of the plant, you are getting an water use efficiency around 85 to 89%. And that's why probably we need to look into the pressurized distribution network integrated with the micro irrigation systems. But if you are doing a closed conduit distribution networks throughout the command area, controlling and monitoring becomes a difficult task. And because there is a huge land to control. We are talking about thousands of hectares of area, and we are thinking about putting walls for each and every farmer. So controlling those walls in operation is a difficult task. Effective water management, because most of these schemes are running 24/7. So you need to have a proper water scheduling so that each and every farmer shall get a judicial quantity of water, optimal quantity of water shall reach to his field. And the system shall have capability that if the farmer has harvested his crop, his wall shall be closed down and shall not be opened up as per the schedule. Then, of course, these are mostly the government-owned projects. So government expect reports to be generated, and the system shall have capability to monitor each and everything and shall be able to generate the reports as per the requirements from the government departments. And instant fault finding and reporting systems shall be an important part for this kind of pressurized water distribution networks, because there may be a case of water pipeline breakages, some vandalism may happen, sometimes farmer may keep the wall open, sometimes he don't open up the walls, and all those things can happen in a large command areas. So you need to have something, some IoT-based systems, IoT-based systems, which shall be able to remotely control the entire command area, and at the same time shall be able to monitor all the events happening in the area. And what are the challenges in doing so is, you cannot lay the wires across the thousands of hectares of area. Electricity is not available in the fields. Line of sight, if you are thinking about having a radio communicated device, line of sight is difficult because it's an agriculture area. There may be some nalas, some rivers, some big trees within the command area. So that's a challenge. That's a big challenge. You cannot go, even though the declaration for the line of sight is 10 kilometers. We could not go more than a kilometer or 2 kilometers more than that because of the green fields and many of the other obstructions available there. All these systems are centralized to be centralized systems. There is a centralized feeder which feeds the pumping station, which operates the centralized pumping stations, and then water is distributed across the entire command area. So these are the challenges again, because it comes with the hydraulic challenges. As my earlier speaker was talking about, the pumping requirement and the electricity required in order to operate those pumps is an important factor in any kind of projects. And remote monitoring and control systems is an important challenge in these kind of projects. So Jain Irrigation has come up with a ag-based IoT kind of a system, remote control and monitoring systems. What are the advantage of having an IoT-based irrigation systems in a large command area? Is all these systems are internet enabled, so you can control and monitor these systems by sitting anywhere in your control rooms. You can place several sensors, like you need to monitor the hydraulic gradients across the distribution network. So you need to monitor the pressure fluctuations across the system. You need to monitor the flows across the system. Sometimes some areas they demand for soil moisture and some other things which probably is possible to integrate along with the sensors in this kind of systems. Provide the flexibility to monitor the systems, because as it is an internet enabled systems, you can monitor the systems. And the most important part is offer the flexible access to multiple users in the systems. When we are talking about this kind of systems, there are multiple stakeholders for this kind of systems within the command area. Farmer himself is a major and important stakeholder of the systems. He wanted to know when he is going to get the water. As I mentioned, these systems are 24/7 operated systems, most of these systems. So sometimes he will get water at the 12 o'clock in the night. Sometimes he gets water at 12 o'clock in the noon. So he need to understand or know when he is going to get the water beforehand. So in these systems, the system which we have developed, and the trade name is Jain Logic, he gets an SMS. We chose SMS rather than a smartphone application because most of the farmers has at least got a feature phone. So he gets an SMS beforehand, before the starting of his wall, an hour before it, that your wall is going to start at this and this price. He get a weekly schedule so that he will be aware for his intercultivation operation that when he is going to get the water. Then government himself is a stakeholder, because they are the owner of the project. So they wanted to know in a nutshell that what is happening in the command area, how much water is getting utilized, how much energy is getting utilized. So that kind of information they also expected to get. Agronomy is an important stakeholder, because when you are connecting to the farmers, we can provide agronomical services to the farmers, and we are providing it through the feature phone, as I mentioned. We can group the area as per the crop, like group the area where the crop is cotton and the growth stage is around like maximum 30 days are available. Then our expert agronomists can give them some advisories, like okay, you need to apply nitrogen at this and this time. If there are some weather forecastings available, he can distribute or broadcast those weather forecasting to all the stakeholders, to the farmers. Technician is an important stakeholder, because he needs to monitor what is happening, where there is any mishap happening, is there any wall breakage, any pipeline breakage, wall is not operating, some wire has cut down, something happened, so he needs to understand. So he is also one of the stakeholders. Project admin is also one of the important stakeholders, because he has to monitor, he has to make the schedules for the project. So all these stakeholders can participate, and this system make them, we have a facility of roles and responsibilities. So we can define multiple roles in a system, like a role for a water user association. So they can they can see in their water users association area what is happening, what is the demand given by the farmers and everything. So there can be different roles, and we can assign them different responsibilities. So if you have given a view authority to someone, he cannot make any changes, any addition in the program schedules. So this is what the Jain Logic Ag IoT based system is. And these are the components which we are using. These are the radio remote terminal units, radio operated, and we are using a free band 865 to 868 megahertz, which is a free license free brand available in India, and which is a LoRa operated. And we have different options in it, like 8 digital outputs, 4 digital outputs, then digital outputs combined with some analog inputs and digital inputs, because you need to connect some pressure sensors or flow sensors to it. So there are different kind of components or hardware components which are the part of it. The structure is, there are RTUs wherein the walls are connected to the RTUs, the walls in the farmer's field. Either few farmers, they use one wall, a group of farmers use one wall, or one wall for individual farmers. That can be designed as per. And then these walls are connected to the RTUs. Several such RTUs are communicating through a radio's communication network to the master station. There can be several master stations in the command area. So there can be, say, 20, 30, 50 master stations in the command area. Master stations ultimately communicate to the server, which we call Irricare Global, communicate to the server, and they continuously, after every minute, the data is transferred. All the events are transferred. Like when the wall is operated, we get an event for on. So immediately you can see that what is happening, which wall is open up, is there any fault? We can get immediately a fault message on the screen. So, this project admin or different stakeholders are connected to the server through the internet. This is how the software looks like. Your user have a very good login. So user, as per his authority is given, can logged into it. There is a map view wherein you can see the command area in a nutshell, as a bird's eye view, and you can drill down to a single wall. You can see the pressure, what is the flow rate going through the system at a specific area. Then this we call it the matrix view, wherein you can select the group of walls, like walls in a zone or wall in a chuck area, and then you can see what is happening in that area. Like the green color says that the irrigation has already done for these walls. Blue color says that irrigation is going on. If there is a red color, that shows that there is some fault, either open circuit or a short circuit for this wall. So technician has to go and attend those. And if the gray color means there is no schedule for this wall today. If the gray color is dark gray color, that means there is a schedule for this wall, but it's not working at this moment. So different color nomenclatures for different walls, and which can immediately gives you the idea that what is happening in the command area. And at the same time, you can put the several meters. We are giving 4 important meters wherein you can see the health of the systems. This is a very good side of this software, which is event logbook. So there are different events happening in the command area: wall opening and closing of the walls. Sensor is sending some data, that is also an event. Some battery, because you are putting RTUs, they are solar operated, some battery operations is also an important factor. Sensor status and all these things. This is a health management system, and thanks to Madhya Pradesh WRD division, and they insisted us rather to have these kind of systems. And this is a very important aspect of it, that health management or monitoring the hydraulic gradient across the distribution network, because that will tell you the health of the systems. If there is a sudden dip in the pressure, that means either there is a leakage in the pipeline. If there is sudden hike in the pressure, that means farmers are, either the main wall is closed down, or farmers has not opened up the walls. So all these things you can immediately know with the health management system. So what are the challenges probably if we are thinking about having an ag IoT system? Oh, thank you, sir. Power is an important requirement for this kind of system, and most of the systems need to be, as I said, there is no electricity available in the field. So the most of these RTUs are to be operated through a solar panel. So maintenance of solar panel is an important thing. We have seen theft and vandalism as a major issue in most of the command areas. Because there is a solar panel, so in order to, you don't, see the solar panel next day, and then that's a major issue which we have seen. So this is one of the major challenge or major issue in adopting this kind of systems. Communication, because most of the systems are communicating through, as I mentioned, 865 to 868 megahertz. So using this free band of RF communication probably is an issue, because green cover, in agriculture area you are dealing with a green cover, and green cover is an enemy for the radio communication because it absorbs the radio waves. So probably this is the time we need to think about having a separate frequency allocated for agricultural application in India, and which can be probably frequency like 433 megahertz or something like that, wherein we can go for longer distance, because you cannot put thousands of RTUs across the fields. It is all uncontrolled area in the remote command areas. So theft, vandalisms, breakages, all these things happens. And then whenever you design such kind of systems, you need to have, because many companies will come up with their own systems. So probably we need to have, as a at the government level, to adopt interoperability standards for this. Because for my walls, I'm saying it as a digital output. Someone will say call it as a
Mr. Joshi,
wall.
please.
So there is an yes.
Yeah, we are overrunning. Yeah.
Yes, thank you. This is the last slide. So this is the important factors probably which we need to think while we are talking about an ag IoT based remote control and monitoring systems. So thank you very much. Thanks for your time and
Thank you,
patience.
Mr. Joshi. Now I shall invite from Rubicon Equipment, Mr. Shashidhar, to make a presentation on solutions for modernizing irrigation canals. Yeah. Welcome, Mr. Shashidhar.
Good morning. Can I get the presentation, please? So, good morning. Thank you very much. First of all, ICID, congratulations for your 75th anniversary and wish you many more. A quick introduction from my end. Myself, Shashi here, Shashidhar, with Meda Rubicon. And we actually do a lot more than in the area of canal automation. So, in this particular session, I'll just kind of briefly rush through into what we do and what we have actually achieved in Karnataka, which is one of our biggest achievements. Meda Rubicon, this is a joint venture facility between two companies, an Indian-based company, which is Meda Servo Drives, and Rubicon Water, which is an Australian pioneer in canal management solutions. Meda Servo Drives, about 7,000 employees, been there in the industry for almost 45 years. Not many people know about us, but I'm sure you would know Vande Bharat Express. And this is one of our feather in our caps, where we are very proud to say we are the ones who have actually delivered the technology of the entire propulsion system, and it's also being manufactured in-house. We are into electric mobility, solar, canal irrigation is one amongst them, and MEDA as well. Oh, sorry, medical as well. Spread across India, I would say like it's one of the Indian MNCs. Rubicon Water, I don't think we need to give a lot more introduction about Rubicon Water. They have been there in the industry from 25 odd years, who have pioneered in the space of providing solutions, components, etc. for open canal water management. And their testimonials are about 35,000 gates that have been actually installed in the field across different geographical environments. And that's where they have actually tested their solutions in collaboration with University of Melbourne. Again, this is the global presence of Rubicon. So I'll quickly jump into what we have been actually talking about, and this is one of the manufacturing facility in Hyderabad. The reason why we have established in India is because most of the conceptions that are there in people's mind is like, Australian-based company, you're providing solutions in India, spares, supply, etc., etc. I have to actually talk to an Australian company, and then you bring it in, too much of customs, duties, and then etc. costs coming into play. We are manufacturing here in India as a part of Make in India initiative. The Karnataka project, where we have actually delivered 4,600 gates or 4,300 gates, 85% of these gates were actually manufactured from Hyderabad, which we are very proud to see. And this is actually what you're seeing is a snapshot of it. I'll very briefly, I think everybody has been talking about the challenges in the gravity-fed irrigation systems, but where we actually see things is a very, very holistic view starting from the reservoir. So we are asking questions like how much water is there in the dam? What do you do with the release management? I mean, you have forums that actually the departments come together and say like, okay, you know what, this is the amount of water that is required, etc. And then they build up a rooster. Folks, keep in mind, these are all theoretical calculations which are actually, combined by data collection from the field from different, section officers, AWEs, etc. And then you build up this particular plan. Keep in mind that this is a plan. There's a vast command area with limited manpower that needs to be addressed. And also, And we are actually talking about the effectiveness of this particular control. You know, Vivek sir was actually mentioning, sir was actually mentioning yesterday, in terms of how do we bring in control into the structures and the tail end serviceability. I mean, these are all good terminologies that to talk about, but keeping one particular person or one particular problem at hand is the farmer's visibility. That is the point that we are trying to address with these particular solutions. Yes, we are talking about efficiencies. You know, there is contributors to efficiencies in terms of unauthorized usage, measurement errors, leakages, seepages. Now, folks, I would ask this particular forum, if we all have to summarize what is the percentage of losses? 15%? 20%? Let's assume 25%, which is on the high end. Now, the question that we need to answer is like 75% water, where is it going? In India, we would be lucky for, I think some of the gentlemen actually mentioned earlier, we are talking about 35% of efficiency in the water distribution. What is happening with the remaining 25%? That is where we are actually looking at. Again, challenges, poor canal efficiency, inequitable distribution, gate operation, very old rusted gates, etc. And that's where we actually bring in the technology interventions. We talk about from the reservoir, we bring in monitoring side of it. From the management side of it, you know, we were talking about the rooster that was prepared. How do you do management of the distribution of water, whether through, you know, this is where we kind of bring in terminologies like total canal control. The quantum of water that is finite, there is a demand which has been established, and how do we do the distribution, whether through the gravity pipeline or whether to farm supply points, etc., etc. Those are all the end mile connectivity. And then we talk about the delivery part of it, where we bring in the entire ecosystem. So from the solution space, we are not looking at an individual or siloed component, but we are looking at it from a complete holistic view. I'm sorry, I'm kind of jumping in very fast, given the aspect of time. Now, people do talk about SCADA, in India. There is a little bit of interpretation gap here. When we talk about SCADA, the way we see it is like there are different levels. We have categorized them into 5 levels, where we're saying like level 1 is remote monitoring, level 2 monitoring and control, level 3 limited autonomous control, level 4 autonomous control, and level 5 fully autonomous control. Yesterday, some of the gentlemen, and in fact the Honorable Minister was also mentioning from Australia about Murray-Darling Basin. This is a testimonial for Rubicon Solutions. They have been working, and their canal efficiency or delivery efficiency is about 85% in some of the areas. They are able to deliver a near on demand within 2 hours of the demand that has been raised. Now, Rubicon Solutions are working in this particular space, fully autonomous. What we have delivered in Karnataka, which we'll just quickly run through in the next couple of slides, that is where we are actually delivering the solutions. I'll just quickly jump in. There's too many technical solutions here. On a fundamental level, we have identified some of the solutions, and these are the different components that actually come into the open canal system. This is the overshot gate, where the traditional undershot gates, we are actually talking about an overshot gate. These are the ones where we talk about slip meters, which are from the distributory offtakes, slip gates again for escapes, flow meters and picometers, which are more from a distributory outlet. Again, based on the different sizes, we are talking about anywhere between 300 mm to 1500 mm outlet sizes. And of course, the blade meter, which is actually for the pipe networks. Now, folks, we have actually seen these particular interfaces or components. All of them are smart. All of them are working on solar. So my power dependency in the field is zilch. And all of them have been built in such a fashion that each of the gate would be able to give you an accuracy of plus or minus 2.5% of flow accuracy. The reason why how they have achieved it is by integrating almost close to 16 to 32 sensors in each of them. So if the gate is not functioning, my command server gets an alarm. If the gate is overtorqued, it gets an alarm. If it's not getting power, it's going to get an alarm. In fact, we are talking about IoT, AI, ML, etc., etc. The gates are so intelligent, you just have to give in a command saying like you deliver so much of water in this particular outlet. The gate starts counting itself and autonomously operate. And then the moment it delivers this particular quantum of water, it shuts off saying like the operation is complete. There are multiple modes. When we go into technology side of it, we can actually get into upstream level mode, the flow mode, set mode, etc., etc., etc. These are all built in, in a fashion that they should be able to work independently. Again, from the manufacturing side, what you get is one fully built unit, which is going to be plug and play in the field. We're talking about Radiocom network line of sight. Sir was actually mentioning. We have proven this particular thing in the entire network of Karnataka, where we have delivered the solution for 4 lakh hectares, where 30 meter monopole towers with both combination of free band and licensed band radio communication network on LoRaWAN has been implemented and has been successful. This is a view of a dashboard of all the Radiocom network. In fact, this is the command area where the Narayanpur left bank canal has been automated, and all the towers you could actually see the status in the system, and the immediate responses can be taken into account. Again, autonomous operation in detail. I'm just quickly going to jump into the Karnataka solution because that would actually become a testimonial of what we have achieved. Earlier slide, this is one of the first implementation or one of the first gates that we have established in Tamil Nadu in 2007 in Parambikula Malaya project, which is still working. The solutions have been endorsed by the government and it's been recognized by that it is actually contributing to the farmers. Telangana, we have done a pilot with the help of Telangana engineers, where we have actually proven that where the water used to take 96 hours before to deliver to a particular tank, we were able to deliver in 24 hours. This is all listed here. Now I'll come to the main part of it where we have, it's a feather in the cap for us in KBJNL. This project we have taken up in 2019 under the Pradhan Mantri Krishi Sinchay Yojana. And the objective here was on a high level, improve the water efficiency from 60 to 80%, near on demand, transparent water supply, and flexible and reliable water supply. Again, these are all good English to actually talk about, but I would want to come to the conclusion that we are doing it. The scope of it was we had to do about 3,685 gates, and about distributory outlets of 518. Existing cross regulators, which are undershot cast iron gates, have been converted, motorized, and operated on solar. I mean, the entire command area of 4 lakh hectares, our power requirement is zero. The entire, all the cross regulators which are there are working on solar. And we have other components which are ancillary to it, along with the command center as well. This is the command area where you can actually see, this is where the reservoir is, and the KBJNL actually embarked on a journey of doing a small pilot in 2014, 2015, and they have actually were able to prove that this particular technology was susceptible to be adopted. And then later upon in 2019, this is where we have taken up as an endeavor, and this entire command area of 4 lakh hectares is governed through one particular control station here. We have used different tools. I'll just quickly give you how it was. This was the farmer outlet where the culvert was above the, I'll note your point, sir. Yeah. And what we have done is we have completely excavated it and installed this new gate with the entire security enclosure. Sir was actually mentioning about vandalism and all those things. Yes, it is there, but now it has tapered down through a series of proactive steps from our end, where we have actually, I'll quickly jump in to what we have. I mean, this is one of the new cross regulators where you actually see all solar powered and they're all working autonomously in the field right now. This is the command area where we do active training sessions. weather stations which have been deployed, and they give active feedback. We are all integrating them into the system right now. And then this is where the crux of the matter is. So we were talking about implementation of technology, solutions, and what we realized is, after discussing with the farmers, with the engineers, is unless and until we don't bring them into ecosystem, it's not going to work. And how we were able to achieve it is like through a series of continuous trainings. We have embarked into a very rigorous activity of going to the field, going to the particular village to village. We have conducted about close to 100+ trainings in different zones, educating them, saying like what is canal automation and why this particular solution is required. Along with the irrigation management software, irrigation department as well, we have created a roster of who does what. I mean, you're talking about behavioral change. We have all been talking about changes in how we should be operating. We are doing it in India, and this is actually paying off. How it is paying off for us is this is one of the beautiful slides where the entire operation cycle earlier, which was supply based, has moved to demand. So the department had actually given us a particular demand roster saying like, this is how much I want as a water distribution. And what we have done in the system is we have actually put into the system, we have done simulations and saying like what levels of water should be maintained. And we were able to prove this particular system by putting into play, and we were able to get the tail end serviceability. I mean, the biggest appreciation that we got was no medal or no certificate, is when a farmer comes in and then he breaks a coconut on the gate saying like, thank you very much, we are able to get water. That was our biggest appreciation, and we are very proud to be associated with this. And there are multiple farmers who have actually endorsed this particular solution. I can go on and on. This particular farmer, he comes in and says like, sir, from the inception of this particular canal network, we have never seen water beyond 21 kilometers. On the 27th kilometer, it has actually overflown. A quick metrics in terms of what we were able to achieve. That was the one. This is reality here. We have been able to achieve this in year 2 of O&M. Out of 4,400 gates, 84% of tail end coverage. Or I would say like around 3,600 outlets we were able to deliver water. Some of the images here in the field visits, and then it has been endorsed by Mr. Prime Minister as well. And I would actually be, we are very honored. ICID did endorse us in 2022 for the WhatsApp Award. And we are very honored for that. Thank you very much.
Thank you so much, Mr. Shashidhar, for
Thank
a
you
very
so
nice
much.
presentation. Now, I shall invite Mr. Lal Bahadur Joshi from Rejuvenation, who will be making a presentation of subsurface drip irrigation with AI-based solutions for precise water management in sugarcane. Welcome, Mr. Joshi.
Good morning, sir. Good morning, everyone. My name is Lal Bahadur Joshi, and I'm representing Rejuvenation Irrigation here. As all of you know, Rejuvenation is one of the largest micro irrigation suppliers in the world. And before I start my session, let me take this opportunity to thank you, ICID, for giving me the chance to present here. Okay. Now, my topic today is the subsurface drip irrigation system with AI-based solution for precise water management in sugarcane. Now, all of us, we know that drip irrigation system is the most efficient irrigation method by way of which, we can save water. In addition to saving in water, there are many more advantages of drip irrigation system. I will not get into that because all of us, we know. But, and particularly the government of India is also very keen in promoting micro irrigation technology for almost 30 years now in India. And even today also under PM-KSY scheme, the government is supporting micro irrigation system, and many farmers, they are getting benefit of this technology. But the real question comes that, for a drip irrigation system, farmer is ultimately the beneficiary, and 80% of the farmers in India, they are not very educated. So the real question comes whether the real benefits of micro irrigation systems are, I mean, the farmers they are getting, particularly in terms of water use efficiency, because even today also, as a hardware, they are using drip irrigation system, but still they don't know how much to irrigate. And this is what actually I want to focus in my presentation today. Drip irrigation system coupled with two technologies. One is subsurface irrigation, wherein the drip lines or the emitting pipes are laid underground. And number two, AI-based solutions, so that farmers will be getting real-time advisory for how much to irrigate. So if they get these benefits, then only the real benefits of micro irrigation systems can be achieved. Okay. Now here I have taken example of sugarcane, because in India sugarcane is one of the major commercial crops grown, and almost if we take average of last 5 years, sugarcane is grown on almost 5.5 million hectares. And again, sugarcane is the most water guzzling crop which requires a lot of water. So I have taken sugarcane as an example. And as far as micro irrigation system for sugarcane is concerned, we always believe that it's a win-win situation. Win-win situation for farmer as a user, and sugar mills, because farmers they get money in terms of the tonnage that they are getting from sugarcane. And with drip irrigation system, they can be able to increase their productivity by 30, 40, 50%, depending upon the agronomical practices they are following. And for sugar factory also, it is observed that with drip irrigation system, we can increase sugar recovery by 0.5 to 1%. Now, even if we can increase sugar recovery by 0.5%, it's a huge saving in production cost for sugar mills. And that is the reason many sugar mills in India, they are these days promoting drip irrigation system in their areas. So here you can see, as far as sugarcane is concerned, UP stands first, both in terms of area under cultivation and the total production of sugarcane. Maharashtra stands second, and Karnataka, it stands third. But as far as productivity is concerned, you can see UP is nowhere in the picture. Tamil Nadu, which is not in the first two things, but still the productivity in Tamil Nadu is high, followed by Karnataka and Maharashtra. Now, as far as average cane water productivity is concerned, it is 2.28 kgs per 1,000 liters of water. Now again, this is some statistics about sugarcane. As I said, UP, it stands first, then followed by Maharashtra and Karnataka, and then Tamil Nadu. Sugarcane is the second highest water consuming crop after paddy, and almost consumes 20 to 30% of total water, which is used in agriculture. 96% of the crop is cultivated in irrigated areas. That means sugarcane is cultivated only in 4% of the rainfed areas. And that is the reason, obviously, as far as water saving is concerned, sugarcane is a crop where there is a maximum potential for water saving. Okay, so considering this 40% application efficiency when you are irrigating sugarcane crop with conventional irrigation, whereas when it comes to drip irrigation system, this efficiency, it goes even up to 90%. Now here I have done some calculations. Now the annual water requirement of sugarcane crop is 1,425 mm per season. That means 14,250 meter cube per hectare. Now if we cover whatever is the total 5.5 million hectare area under sugarcane under micro irrigation system, the water saving that we will be achieving will be equivalent to water storage capacity of 13 Bhakra-Nangal dams. As all of us, we know that Bhakra-Nangal is one of the largest dams in India. So in other way, we can also say that even if we cover 7.5% of the total sugarcane area under micro irrigation system, each year we will be saving the amount of water to the extent of storage of one Bhakra-Nangal dam. Now here, compared to surface irrigation, in subsurface irrigation system, there are many more advantages. Obviously, in subsurface irrigation systems, the drip lines, the actual emitting pipes are buried deep into the ground, exactly into the root zone. And that is the reason whatever water and nutrients we are supplying, most of the water and nutrients are directly available to the plant. This is number one. Number two, we can increase the production, crop health also, maintain. Sugar recovery, as I said, that is also one of the benefit. And most importantly, with subsurface irrigation system, mechanized harvesting is possible, because as far as harvesting of sugarcane is concerned, it's a highly laborious job. And with subsurface irrigation system, we can go for mechanized harvesting, so that speedy harvesting is possible. Now, obviously, when it comes to subsurface irrigation system, there are some obvious limitations as well, because the drip lines are buried deep into the ground, and when it is buried into the ground, soil ingestion and root intrusion, these are two major problems, which are often witnessed in subsurface irrigation system. And that is the reason we have some specialized products by way of which there are certain physical barriers which will prevent from soil ingestion as well as root intrusion into the dripper. So these are some of the specialized products available with us in Rejuvenation irrigation system. Those are suitable for subsurface installations. Okay, so here, I don't know if I can, I have a small video. Yeah, of actual laying of subsurface drip lines. Now, the depth of drip line, it depends on the soil type, but in general, we bury 15 centimeter deep into the ground. Now, here in the last corner, you can see the picture. The sets are almost 5 centimeter above the drip line. So the net depth of pipe is 15 centimeter and the depth of set is 10 centimeters. So this is how the subsurface installation is done using tractor mounted laying machines. Okay. Now the most important is, as I said, farmers, they are using drip irrigation system, but they don't know, how much to irrigate. And actually, root is the mouth of any plant because it requires water and nutrient. So we must know how much the moisture is available at the root zone. So and we don't have any mechanism by way of which we can see what is the amount of water available in the root zone. So here the technology like Mana irrigation system, which is available with us, which is satellite based irrigation intelligence, that comes into picture. So these are some of the limitations of over irrigation as well as under irrigation. So optimal irrigation is very important so that we can improve water use efficiency. Well, for scheduling of irrigation system, now mostly farmers, they go by intuition or some traditional methods, but again these are not accurate. Now we have some ETC tables also available, and on the basis of certain protocols, we can give irrigation scheduling to the customers. But again, these are not location specific, site specific. So that is also another limitation of those protocols. Soil and plant sensors are there, but again, they are very, very localized solutions. But now with Mana irrigation technology, which is available with this company, this is a hardware-free solution and which is completely satellite-based and very, very site-specific. Okay, as I said, this is a software-only solution, no hardware, no maintenance, and irrigation scheduling is done on daily basis and actual based on actual field evapotranspiration. High frequency and high resolution crop health monitoring maps. We are also giving weather forecast for 14 days. And this is very, very user-friendly because farmers or the beneficiaries, they can get daily recommendations on their WhatsApp. And this message is also given not only in English, but also regional languages so that farmers, they can easily understand the same.
1 minute, please.
Yes, sir. Yeah, sure. So these are 4 different satellites we are using for this technology. Of course, the PlanetScope, which is highly accurate, is most important here. And in case of cloud cover, we are also using Sentinel-1 so that it can penetrate through cloud cover as well and get the images of field. Now, another advantage of this MANA technology is if somebody has already installed automation system at their field, now this software recommendations can also be integrated into the automation controller so that that integration is also possible. Okay, and these are actual pictures. Here you can see the positioning of the drip line, which is almost 4 to 6 inches below surface. Now here, nowhere you will see the pipeline on the surface, but you can see a very green, lush crop, okay? And this is only because of subsurface application. So thank you very much once again. Thank you.
Thank you so much, Mr. Joshi. Now I shall invite from Vasar Lab Mr. Nikhilesh Kumar to make a presentation on from reservoir to root transforming irrigation with digital technologies. Welcome, Nikhilesh. Yeah.
Thank you, sir. Good morning, everyone. I am Nikhilesh Kumar, co-founder and CEO of Vasar Labs. So, a brief on Vasar Lab. We are a 10-year-old company, and what we have been doing is building technology, digital products, which we deploy at large scale. We have deployed a lot of solutions at country, state, city scale. And what we are doing is we are taking data and science to the user's hand for making design-related, planning-related, operation-related decisions. So over the last 5 to 6 years, we have done more than 6 country-scale works. We are working with Ministry of Jal Shakti. We are doing with a couple of other countries like Saudi Arabia, Kyrgyzstan, where we are focusing on water and agriculture-related works. Next slide. I'll be focusing on what we are doing with respect to irrigation, and with close to 87% of water consumed in India going all to irrigation. And some of the data says that if we just use half of it, we still will be doing more produce than what we are doing today. So this is a problem of scale, and we're talking about the entire country, and the scale needs an integrated approach where most of the water that goes to the farm actually is harvested in the river basin. The journey starts in the river basin. So what we are doing is, first is storage management, and we are working with, again, state irrigation command areas, lift irrigation projects, basin authority. So we start a journey where we are starting with storage management. What is the inflows that is going to come into the reservoirs, seasonal forecast, short forecast, then how the water needs to be distributed as per the demand across different sectors. And then to the command area monitoring. So we make use of satellite data to know what is the command area extent. We use high resolution satellite data to auto extract the farms boundaries, create localized ICIDs, and then generate demands, crop order demands based on that location specific dynamic information. And then comes the distribution. So how do you distribute, how should you optimize the Varabandi schedule, the rotation schedule, but also not just the whole seasonal schedule, but what to do in the next 2 weeks, given the current soil moisture, given the rain forecast, given the groundwater, and tail end problem or inefficient operational losses, or when the rain is already happening, still releasing. And then comes the health monitoring on the command area to the farms, where what is the crop health, what is the extent of irrigation, which area is stressed, which area is not, and also towards the end of the season creates various KPIs culminating to the water use efficiency. So this is the holistic approach that we have taken, and we have deployed across various projects in India. Aqua Drop is the first, which is focusing on dams, reservoir and river operations. And what it does is it brings holistic holistic integrated approach across the river basins, where what is the overall water that is going to come in the season, bringing seasonal forecast, translating into runoff, water availability at individual reservoir level. We have deployed this solution across 200 plus reservoirs across 10 states and 25 river basins. They have been using this system. In fact, Narmada was one of the first river basin to use this integrated model, where 10 daily planning was done with the mathematical optimization across the entire basin. And then some of the glimpse of the solution, if I just may show you, is, so the journey starts with the inflow forecast, where rainfall data is translated to for the entire river basin, and short range forecast. At the same time, long range forecast on the seasonal with ensemble, with probability, to know what amount of dependable flows will come. And this is a data that is going to be at whole season horizon, 40-day horizon, and also 3-day horizon, so that you can take a planning decision on water allocation and scheduling, but also can take near next 10 days and today's decision. Again, these are some of the visuals that we have implemented across different states. This is one in Tamil Nadu, where demand and the whole basin's demand and forecast of the supplies are brought together. Next. This is a digital twin for a water grid system. So majority of the states in India and river basins, water transfer is a big affair, right from Bihar, which is taking Kosi water, to Telangana, where Godavari water, to AP, where Polavaram, to Gujarat. So we have so much of water which is getting transferred, and being able to manage these transfer network is a pretty complex challenge. So you need to know, because electricity, large amount of electricity is involved, and at the same time, these systems are often connected in a complex and convoluted networks. So how do you take the water from one point to another in a most efficient manner, which is allowing you to make sure the demands are met, but at the same time, you may end up transferring a water and creating a flood situation, or you may end up not transferring and creating a drought situation, or you may end up over using the electricity. So how do you optimize across this while you're transferring these waters? So we create digital twin of the whole at the large scale basin level, and then water is based on the inflow forecast, based on the demand, based on the hydraulic constraint, based on the pumps operation schedules. These optimizations tell what is the whole season's outlook, and how do you operate the pumps so that the lift is done optimally. Next. So this is a visual for Narmada that we are doing, where what you're seeing is various demand blocks as squares, and water drops that you're seeing flow represent different quantity of water, and different reservoirs are there. As you click on each point, these points are representing the either hydrographs or release schedules. Next. Again, this is at the storage management from Narmada irrigation side, Chandan. So the other work that after we have managed the river, basin, dams and reservoirs, comes the distribution onto the canal network, where across, again, 3 different states, we have covered 30 projects, close to 120 million hectares of command area, agriculture command area, where these are put to use into the operation for demand generation, satellite based, to optimizing the Warabandi scheduling, to release management on a weekly basis. And some of the works that I'll just show again from the systems that we have deployed. So the first one is creating a digital twin of the entire canal network, where the data is either coming from IoT, can come from IoT, can come from the operational workflows of irrigation and agriculture department combined. They conduct sessions, they participate using the system. And then at the backdrop, complex deep tech scientific models are running, which is bringing groundwater related volumetric information, crop water at every off-take localized ICID level, again computed based on the real-time dynamic weather informations. And then the scheduling takes place. And then making use of that, the scheduling is optimized, published to each individual canal hierarchy and officers, and they further participate whether they accept or reject or would like to make changes based on the farmers and water user associations inputs. We'll go to the next. And then all the way till individual farm level. So here in the first video that you see is how right from the main canal to the branch canal to the distributaries to the miners, and not just stopping at the miners but also going all the way to individual field level. So field polygons are extracted using high resolution satellite data, because that is one last unit where agriculture activity is happening, and then monitoring those fields using satellite in terms of whether the crop is done or are there any concerns raised by the farmers. And farmers are part of the system, so every farm field, the farm details, the mobile numbers are part in the system, and then remote sensing is used to monitor the health, crop, and also wetness. We have a combined video that we'll just like to play to show how this entire system goes in harmony. Maybe we can play that video, Chandan.
Inefficient irrigation leads to wastage, crop stress, and reduced yields. What if we could transform irrigation with precision? Introducing Aqua Irrigation, smart irrigation decision support system developed to optimize water use efficiency in the canal command areas. The platform creates digital twin of canal network and monitors water flow in canal command areas. It does rainfall analysis based on observed and forecasted data to anticipate water availability. Also provides actionable insights on groundwater levels, soil moisture, and crop water demand. The system does satellite-based surface wetness monitoring that is sites assessments on moisture distribution across the command area. Detects over-irrigation and waterlogging to minimize water wastage. Also, identifies dry patches, allowing for targeted intervention. Aqua Irrigation leverages AI-powered crop detection and classification to identify crop types in real time. Analyzes crop growth patterns and monitors seasonal variations, supporting adaptive water management. With crop water requirement insights, the platform gives analysis on precise water demand based on crop type, growth stage, and weather conditions. Further, cites irrigation schedules and water release insights, given seasonal and forecasted water needs 2 weeks in advance, actual releases, and advisory recommendations. The Performance and Impact Assessment module ensures continuous monitoring of irrigation. Assess canal irrigation and water utilization by tracking water requirements versus releases, seasonal supply, and irrigation efficiency. It also evaluates KPIs such as yield and water use, while empowering field engineers on water use, maintenance, and grievance resolution. With Aqua Irrigation, we are empowering farmers, irrigation managers, and policymakers to make informed, data-driven decisions, ensuring sustainable water use, increased crop productivity, and climate-resilient agriculture.
So that's a short summary, sir, summarizing what we do on the irrigation, but at Wasser, we are building a whole life cycle of water products. We have more than 24 products covering across country level water resource information to water budget to irrigation and distribution, then flood, the disaster side, also the water audit and policies and entitlements, then recharge to the groundwater side. So it's a whole life cycle of work that we have been doing, and close to 400 plus people we are today passionately involved in building these products for both country and also at the global footprint level. So thanks a lot for giving the time, sir.
Thank you so much, Mr. Nikhilesh. Salutations to all the speakers for making pithy yet very effective presentations and sharing their knowledge base with the elite audience. Now I shall hand over this session to the organizers.
Thank you all our eminent speakers of this session. We thank our session chair, Shri Vivek Kapadia ji, for conducting this session. And as a token of gratitude, we would like to present mementos to all our speakers. May I request our session chair to kindly honor the speakers. I request Mr. Amit Kapuria, Senior General Manager, Rungta Steel Limited, to kindly come forward and receive the memento. I request after this Mr. Devanand S. Head Large Water Systems Ltd. Ladies and gentlemen, also please during the break times do visit our exhibition hall. There are 16 exhibitors. So please do and enjoy the exhibition. It's a great lineup for all of you. Thank you. Mr. Devanand S., Head L&T Large Water Systems. I request Mr. S.P Jadhav, Senior Vice President, Jain Irrigation Systems, to kindly come forward post this. Mr. S.P Jadhav, Senior Vice President, Jain Irrigation Systems. I request Mr. Abhinay J. Patel to kindly come forward. Mr. Abhinay J. Patel, Chairman and Managing Director, Aqua Machineries Private Limited. I also request Mr. Abhijit Joshi to kindly line up. Thank you. Mr. Abhijit Joshi, Vice President, Jain Irrigation Systems Private Limited. I request Mr. Shashidhar, Mr. Shashidhar Pasupulati, from Rubicon Equipment India Limited. I request Mr. Lal Bahadur B. Joshi to kindly line up. Thank you. Mr. Lal Bahadur B. Joshi, Assistant General Manager, Rejuvenation Irrigation India Private Limited, and I request Mr. Nikhilesh Kumar, Vasar Labs, to kindly join us, please. Mr. Nikhilesh Kumar from Vasar Labs. Artist congratulations to all our speakers, and I would request President ICID Dr. Marco to kindly felicitate our session chair, Shri Vivek Kapadia, Ex-Secretary, Water Resources Department, Government of Gujarat. Thank you, sir, for giving your time and honoring us by chairing this session. No. Thank you so much, President ICID, Dr. Marco. Thank you once again. Ladies and once again, we thank all our distinguished speakers, our session chair, for the insightful presentations. The ideas shared today will surely inform and inspire action in the irrigation sector. We would now take a short break for tea. May I also request you to kindly do visit our exhibition area. There are 16 exhibitors over there. It's near the registration counter. So please do have a look. We will all gather back at 12 o'clock in 20 minutes from now for our second technical session on inclusive water management for sustainable irrigation development. May I also... Sorry, the topic would be remote sensing and geospatial applications in irrigation sector. May I all request, as we are running behind schedule, I request all of you to kindly be here 5 minutes before 12 so that we can start our session in time. Thank you. Enjoy the break. Let's now quickly get on to our next session. Well, our next session takes us to the intersection of space technology and sustainable agriculture, where satellite sensors and geospatial intelligence are revolutionizing how we monitor, manage, and modernize irrigation system. Our technical session 2 is on the topic remote sensing and geospatial applications in irrigation sector. Please join me in welcoming on the dais our session chair, Shri Arvind Kumar, Joint Vice President and Head, Sales and Marketing, Rungta Mines Limited. We are very, very pleased to have you as our session chair, and thank you for joining us and giving us your time. Shri Arvind Kumar. Now, for the rest of the proceedings, I hand the session over to our session chair, and I also request him for his opening remarks. Thank you.
Good morning, all. This is Arvind Kumar, Joint Vice President and Head Sales and Marketing, Rungta Mines in TMT and Virod. First of all, I would like to congratulate ICID for their Platinum Jubilee ceremony, and we wish you good luck for the future endeavor for making such excellence. Dear colleagues, distinguished speakers, and participants, it is my honor to serve as the chair of this important session on remote sensing and geospatial application in the irrigation sector. Thanks ICID for giving us opportunity to be here. I warmly welcome all of you to this gathering focused on leveraging cutting-edge technologies to enhance water resource management and agriculture productivity. The irrigation sector plays a vital role in ensuring food security and sustainable agriculture worldwide. Effective management of water resource is crucial, especially in the face of increasing climate variability, competing demand, and limited water availability. In recent years, remote sensing and geospatial technologies have emerged as transformative tool enabling us to monitor, analyze, and manage water resources and unprecedented precision and efficiency. This technology includes satellite imagery, UAVs, GIS, GPS, and data analysis, all contributing to smarter irrigation practices. The purpose of this session is to showcase recent research, innovation, and studies, practical application of remote sensing and geospatial technologies in the irrigation sector. We hope to foster meaningful discussion, share knowledge, and identify opportunities for collaboration. During the session, I encourage active participation, insightful questions, constructive discussion, Please keep your questions concise to allow active participation engagement. Thank you all for attention, participation, and valuable contribution. I look forward to engaging in fruitful session. With this, I invite Mr. Gagandeep Singh Gill, who is ACWRD Punjab, to brief about reviving Punjab Lifeline, restoration of the canal system. Mr. Gagandeep Singh.
Thank you, sir. How do we go forward in the slides? Okay, respected chair, the organizers, fellow delegates, professionals, a very good afternoon. I represent Water Resource Department of Punjab. Punjab, the name comes from Punjab, means it is land of 5 rivers. Post-independence, 2 went to the western side, we are left with 3. Basically, we owe our existence to these rivers. Owing to the geographical location, the rivers, the soil type, Punjab is primarily an agrarian economy. With this, how do we move in it? Okay. With this, during Green Revolution and post that, Punjab had been or has been food bowl of the country. We are just around 1.5% the area, but we are, we are resourcing in the maximum of food grains. And they say with growth come challenges. The major challenge which now we have in Punjab is the drastic groundwater condition. That is because of the incessant and unprecedented withdrawal of groundwater for agriculture purposes. So much so that out of 153 blocks, 115 are overexploited. So we are in a very grim stage of groundwater. The stage of development of whole of the state is around 157%. That means the available resource is 100 and we are extracting out 157. Such is the grim state of affairs in Punjab state. So for water management, so we have been employing all the technologies, the monitoring, the data acquisition, all the latest technologies like my friends have, they have talked about. But we have gone to the basics as well. So I'm little, out of context for the topic of this session because we went back to the basics. So how do we go? How do we go? Next slide. The green button. It's not working. Okay, now I get it. So we have gone to the basics, means we are restoring, resuscitating, or refurbishing the canal system again. Now Punjab has a canal network of around 14,520 kilometers, where the CCA is around 31.9 lakh hectares, and the entire canal system irrigation is primarily divided into 7 systems, and these 7 systems, they cater for about 31.9 lakhs hectares of CCA out of the total area of around 40 lakh hectares of Punjab. So we can see the different areas of Punjab in different colors where the 7 systems cater these areas. The Sarand Canal system is the largest system. Then we have a UBDC system, then the BML system, Bishdwab system, Shah Nair system, and the Sarand Nair system. So This is the division-wise jurisdiction of the canal system in Punjab. The area up there, above the light blue one, the white area, this area is still not under canal systems. So, applying all the major technologies, the present technologies, we started to resuscitate, to restore the canal system. So objectives were very clear. First and foremost, contain groundwater depletion. So others are corollaries to it. We need perennial canals for proper cultivation, improve water quality, reclaim encroached lands. Now, because this canal system is very old, so it is kind of obliterated. People have encroached upon the canal system. The landowners who were adjacent to the canal system, they had encroached upon the water courses, the miners, the sub-miners. So we had to resuscitate it, the entire system. This is the main canal system. Everybody knows this. Main canals, branch canals, distributaries from that, miners, and on that we have outlets, then escapes as well. Now we worked from the source till the user. So we adopted that approach for water management, that we went from the source to the users. So the methods adopted for restoration, first and foremost is strategic shift from brick lining to concrete lining. It is an age-old system. Some canals were brick lined, maybe 30, 35 years old. Some were unlined. So we switched on to the concrete lining for efficiency and for durability. So we wanted the water to reach the end users, so we adopted this system. Periodic cleaning of canal systems. Now, periodic cleaning means we clean those canals before the primary two seasons, the Kharif season and the Rabi season. So we ensured that we cater out the cleaning of canals before we release water into that for agriculture. Adaptation of comprehensive canal restoration drives. Now, with the approach of source to users, we adapted to this restoration drives, restorations of canals, miners, and we went till the water courses, which are the end user things. So we restored, we tried to restore, we are still restoring the major part of it, the canal conveyance system, the canal distribution system, the canal water distribution system. Water courses restoration drives, because the water courses in Punjab are primarily, they are not government owned. They are people-owned canal systems, the water course systems. So we restored those. We gave ownership of those water courses to people, so that the entire conveyance system may be working efficiently. Restoration of gate and gearing system. Now, for proper functioning of the canal, we have the cross regulators, the head regulators, the gates at different locations. So we refurbished those after maybe around 10 years. And now we have made a scheduling of it so that we can oil it, we can grease it twice in a year so that they can work well. Then comes restoration of abundant canals. Like I said, most of the canals, they were not fully functional because they were obliterated. People had unauthorized occupation on the lands of those canals. So we went on the drive. We identified those canals which had been abandoned, canals which could be revived, status of encroachments. We joined hands with district administrations, removed all those encroachments. Structure status of canals, that is earthen, brick or concrete, it was ascertained, and if any improvement with latest technologies was required, we did that as well. Status of water courses.
Mr. Singh, please fast, 1 minute is left for you.
So we basically restored 79 canals, which cater to around 500 kilometers, more than 500 kilometers. This is before and after pictures, so I'll rush through it. Extension of canals, where groundwater situation was alarming, like Sangrur, It's a district in Punjab. So we extended few canals. Construction of new canals. The uncommanded areas, we proposed new canals like Malwa Canal, like the Smesh Canal. We proposed new canals like Malerkotla Canal, so certain like that. Then we we adopted lift schemes for Kandi area, the sub-mountainous region, which was not irrigated in past 50 years. So we adopted those areas for lift irrigation. We constructed around 82 escapes so that when there is unprecedented rain or there is a sudden gush in water, we can release those in drains so that the crop doesn't get affected. So we made 82 escapes. We utilized, government machinery for restoration because there is a law and order problem while you get when you get the land back, reclaimed land back. So we adopted the government machinery for that. We devised a new mechanism like tail gauge monitoring system. We increased water allowance at different places, and we adopted public awareness camps. We went to panchayats, we went to public gatherings like religious places like gurudwaras, mandirs. We involved water user associations. We conveyed them that the groundwater situation in Punjab is very grim, so we need to use canal water system. We adopted a new canal water usage policy for outlets other than irrigation. That means we started giving water for industries, for power plants, for fisheries, for drinking purposes, free of cost. The cost of this for these purposes was kept very, below the cost of groundwater used for the same purpose. And the drinking water, it was free. So in recent times, we got around 84 connections for such things, totaling to that. So what is the outcome? So outcome is that in last 3 years, the area which is actually irrigated has increased by 80%. So the very basics we did, the area under canal water, it increased by 80%. Punjab has utilized 100% of its allocated share in Rabi season in this year only. So it had never been done before. So we have utilized 100% of our allocated share. Lesser depletion of groundwater owing to far-reaching canal network. So the rate of water going down has reduced a lot. And at the end, it's my acknowledgement to the department, to the administration who have proactively worked for this. Thank you so much.
Thank you, Mr. Singh. You have well addressed about the canal, how rehabilitation has been done in the Punjab and how you have done it. So thank you very much. Now the next speaker is Dr. Sarath Raj B. and Dr. Saifi Ullah, who will brief about the effectiveness of IoT-based smart irrigation system in water conservation, a case study of Bangalore Rural District, Karnataka, and Atal Jal initiatives.
Thank you, sir. So good afternoon and all. So I am Dr. Sharath Raj, representing Atal Bhujal Yojana, Karnataka, and I am here to take you through a pilot project which is an effectiveness of IoT-based smart irrigation system we have taken up as part of Atal Jal initiative in the Karnataka. May I know this mechanism? Bigger one, right? Yeah, thank you. So, we have been discussing about how the irrigation network system or how the groundwater is being depleted in the country since 2 days. I'll just take you through what is Atal Bhujal Yojana is doing. It is basically a central sector scheme running in 7 states of the country, wherein in Karnataka it runs in 14 districts, 41 blocks and 1199 gram panchayats. So it basically works on water budgeting at the gram panchayat level, where what is the water availability, water utilization and water balance is estimated at gram panchayat level, and based on it what is the deficit we found in the Gram Panchayat level, based on the what is the water deficit we have. Accordingly, we plan water security plan by implementing demand reduction strategies and artificial recharge increases through different activities along with the convergence as well as Atal Bhujal initiative incentive funds. So while estimating the water utilization from the irrigation aspect, there is Karnataka Agriculture Department which takes up crop survey every year. In the crop survey, it is like what are the crop types present in that particular year will be mapped, and we have did an exercise of if the crop water requirement is considered for that particular crop per hectare, for whole Gram Panchayat for an year how much water would be required to irrigate. So that is the very basic minimum requirement needed for the irrigation. So once that exercise is done, and once we compared it with the actual field data, so for the actual field data, what we have done is one thing, in one side we have done it like we have taken flow meter data. We have installed water flow meters to the irrigation bore wells of the selected farmers, and we have observed that data as well as per the groundwater evaluation committee GEC norms, there is a water budgeting system. So in that water budgeting system also, how much is the actual groundwater withdrawal happened for that particular year. We have considered that data also, and we have just cross verified, then observed that what is the minimum requirement that should be there for the irrigation and what is the actual groundwater extraction happening has a very significant difference. So as part of the incentive component of the Atal Bhujal Yojana funding, we have taken up this work. This is currently running, just 2.5 months is been completed after the installation of these units, wherein a smart irrigation, IoT based smart irrigation system at a community level we have taken up. So in a community level, 24 farmers have been considered in a particular area based on the preliminary field surveys carried out considering the different crop types and the different areas of irrigation. So this is basically falls in the Devanahalli Taluka of Bengaluru rural districts, which is a semi-arid climatic condition and overexploited blocks. And you can see this overexploitation from 2020 to 24. It is almost 193% was the groundwater exploitation in 22, then 152%, and then it is 179%. So as a methodology, we have taken up the preliminary survey, then installation of the hardware component, that means a weather station and its subunits, that is soil moisture sensor, different sensor including soil moisture, temperature, humidity, leaf wetness, pressure, sunlight and wind. So we will be mainly focusing on the water conservation aspect in it. So before the installation of this system, irrigation system, it was like farmers used to irrigate based on the intuition. So, and it also adds to it that there is a separate feeder channel system for the irrigation in the state. So every day or every alternate days for maximum of 2 hours, this power supply will be there for this irrigation system. So farmers will utilize completely these 2 hours or 2.5 hours, whichever is the power supply they have for the irrigating their land. And with the Philo system, so Philo is a Bangalore based startup that we have taken up for our work. So with this system, there is a stage-wise irrigation alerts we have started giving to the farmers. So with the stage-wise irrigation status, what results we have observed? Let us look into it. So in the irrigation aspects, so this is the first graph. You can see it is a soil moisture data representation of pomegranate farm, wherein the lower levels, orange color represents the wet conditions in the farm, and higher at the top end we have also again orange color alerts. It is the dry conditions observed in the farm. So wherever there is a dry conditions observed, then irrigation happens, then it comes back to the wet condition, then again this continues. And whenever there is rainfall happens and it shows that there is no irrigation requirement, so it continues in the same level. So before the fallow irrigation system, for 2 hours of every alternate days were followed by the farmers, and for the grapes it was 2 to 2.5 hours for every 2 days. Then for rose it was 1.5 hours daily. So after this installation, we could see a water saving of about 30 to 35% in pomegranate, then about 40% in grapes, and in about 25% in the case of rose. So an attempt was made to quantify this water per hectare by considering a hectare land of area. For the grapes, the plant spacing is about 3 meter into 2 meter, and in an hectare about 1,666 plants can be placed, and per plant there is 2 drippers, and a dripper flow rate is about 4 liters per hour. So with that, with an hour, a total of 13,328 liters of water will be utilized in an hectare. So similarly for pomegranate and rose were considered. It is an ideal condition, and with this consideration, so what will be the water utilization happening? So with the before average irrigation, if we consider before the installation of the IoT system, you could see about water used is 766 cubic meters in the grapes, then 448 in the case of pomegranate, and 8,400 in the case of rose. So this is estimated based on the average irrigation they use before the installation of fallow. So after the installation, you could see the difference of 233 cubic meter in the case of grapes, then 153 cubic meter in the case of pomegranate, and 5,600 in the case of rose. This estimation is for the period of 2.5 months. So if we consider it for a whole area, we could see a bigger difference.
Dr. Sharad,
yes,
1 minute left.
Yes, concluding it. So coming to the, apart from these irrigation aspects, we have technologies towards how the sprays can be scheduled for the farmers and how fertigations can also be scheduled. And why we have taken up this work is that we all know that there are systems which can be utilized by the farmers for the better irrigational practices. But once we try it in their farming land, and once we show them that this is what the difference you can see at a community level, so they can adopt in a community level where the cost of the system comes down. So if a community of farmers takes up this work in a bigger area, and if it is continued to the Gram Panchayat level, so there will be a bigger water conservation happening in the area. So because just only with the drip irrigation system, there is a limitation, because they doesn't know how much is the water to be irrigated to the plant. But once they have a data-driven decisions, then it comes in a better picture for a better world, better society. Thank you.
Thank you, Dr. Sharath. You have well briefed about Atal Jal initiatives at Bangalore rural area by using IoT-based smart irrigation. Now this is time to call again for a case study of Nepal by Mr. Sandeep Kumar Chaurasia, Sunil Kesi, and Ashish Pandey. The topic is performance evaluation of irrigation system using IS, RS, and GIS. Mr. Sandeep Kumar.
So, respected chair, esteemed guest, and my dear friends, namaskar to everyone. Myself, Sandeep Kumar Chaurasia. I am PhD research scholar at the Department of WRDM, IIT Roorkee. Today, I am going to present performance evaluation of irrigation system using remote sensing and GIS system, a case study of Ganga irrigation system, Nepal. So, in the Nepal GDP, agriculture sector contribute 24%. This highlights the significance of agriculture in the Nepal economy. And out of the total area, about 2.64 million hectare is cultivable land, and however, only 1.76 million hectare, approx 66%, has irrigation potential. So let me now explain why evolution of irrigation system is critically important. So evolution help us to pinpoint the underperforming locations. Through performance evaluation, we can detect water losses, inefficiencies in canal operations, over and underperforming areas, so we can address these issues and improve water use efficiency. And when irrigation scheduling and coverage are properly aligned with crop water requirement, it improves both yield and quality of crops. Evaluation of irrigation system promotes sustainable water management, and evaluation serves as a foundation for informed decisions. So, for performance evaluation of the large irrigation system, remote sensing and GIS techniques are very useful for visualize spatial, temporal, ET, and soil moisture maps. We can merge field data with high-resolution satellite images, generate irrigation inventory and water use for further analysis. So for this study, the study area is Ganga Irrigation System. It is in Nepal, and the total gross command area of the system is 14,174 hectare, and cultivable command area is 11,1668 hectare. So this slide explains the methodology that we followed for evolution of irrigation system. First, let's look at the data collected for the study. So we used Sentinel-2 data with 10-meter spatial resolution for crop area mapping and for NDI estimation. We collect ground data like crop type, crop calendar, irrigation source, growth stages, and crop period for Ganga Irrigation Management from Ganga Irrigation Management Office and Water Users Association. We also collect daily weather data like rainfall, temperature, wind speed, relative humidity, and solar radiation from Department of Hydrology, Nepal. Irrigation water supply data we also collected from Ganga Management Office. Now coming to the process flow shown in the right side. We started by estimating monthly reference evapotranspiration by using weather data. In parallel, we used Sentinel-2 data to generate monthly NDVI maps. And from the Department of Nepal, we obtained crop coefficient values of different crop. Then we stabilized relationship between NDVI and crop coefficient for each crop type. By combining reference evapotranspiration with crop coefficient, we derived spatially distributed ET maps. From this, we calculate irrigation water requirement for the command area. And we also have how much irrigation water we supply to the crop. So finally, with the help of different performance indicator, we developed key conclusions and recommendations for the study area. To evaluate the Ganga irrigation system effectively, we used a comprehensive set of performance indicators classified into 3 categories. First one is water delivery performance indicator, including relative water supply, depleted fraction, and relative irrigation supply. These indicators help us to assess how well irrigation system is meeting water demand. Second type of indicator used as physical performance indicator. These indicators reflect the system hydraulic efficiency. Third one is agricultural performance indicator. These indicators assess how effectively water is converted into crop yield and economic return. Now moving to the results. Using Sentinel-2 data and ground-truth data, we classified the major crops grown in the region. You can see wheat is the dominant crop, covering approximately 39% of the region, and potato comes next around 22%. Winter vegetable and pulses contribute 11 and 10% respectively. These are the some NDVI maps generated for different dates and for the different crops. And from the regression equation, we determined the crop coefficient values for the different crop and for the different stages. And from the effective precipitation and actuality, we calculate the irrigation water requirement for each crop. We have the measured discharge of the Ganga irrigation system. So we calculate different performance indicators. So in water delivery performance indicator, relative water supply, this is the ratio of total water supply to the total crop water demand. So the highest value of relative water supply is 1.23 for winter vegetables, which shows over irrigation. And relative irrigation supply is the ratio of irrigation water supply and irrigation demand. So pulses and wheat shows relative irrigation close to 1, indicating efficient irrigation, and winter vegetable relative irrigation supply is 1.18, it means over irrigation. This is the agriculture performance indicator of Ganga irrigation system. This shows the crop water productivity of chickpea and potato is below average, and wheat crop water productivity is in satisfactory limit, and cauliflower performs excellent crop water productivity. And so, based on the analysis, we found that Ganga irrigation system is performing satisfactory in terms of water delivery and crop productivity. However, there is a scope for improving irrigation efficiency by doing some proper irrigation scheduling. These are some references used in this study. Thank you. Thank you so much.
Thank you, Sandeep. And first of all, thank you very much for completing your session on time. You have very well presented case study of Nepal, performance evaluation of irrigation system with the remote sensing and GIS. Now this is time to call upon Mr. Rotash Kumar, Khemraj Nirola, Aman Karki, Krika Kuthari, Sumit Chaudhary and Ashish Pandey for utilizing high solution UV imaginary for estimation of soil moisture in hilly agriculture environments.
Respected Chairperson, dignitaries, ladies and gentlemen, I, Rotash Kumar, PhD scholar, IIT Roorkee, a very good afternoon. I am going to present my seminar on utilizing high resolution UV imagery for estimation of soil moisture in hilly agriculture environments. As we know, water is very crucial for our earth, for living organisms. Likewise, soil moisture content is also important for vegetation. So, estimation of soil moisture content is important for analysis the growth and development of crops and plants. This can be achieved by conventional methods as well as modern methods. Conventional methods are direct and indirect. Direct methods like gravimetric methods and indirect methods like using tensiometer, TDR, probe, etc. instruments. And the limitation of conventional methods are labor intensive and time consuming. So, modern methods are some types of indirect methods using the data of satellite and UAV. Nowadays, modern methods are important due to their large scale and high resolution. This study mainly focuses on millet crop and utilizing UAV-based multispectral images. And the primary focus was to measure soil moisture using direct and indirect soil moisture techniques to predict soil moisture using UAV-based multispectral images and to validate UAV-based soil moisture with field observation. This experiment was conducted on 2 millets crops using factorial RBD design with mainly 3 treatments: sowing date, variety and irrigation regime at 2 locations of Tiri Garhwal district of Uttarakhand. Site 1 is Ranichori, that is hilly region. Site 2 is Nagani, that is valley region. And soil data collection using 3 methods. First one is indirect, that is TDR instrument. Second one is soil samples, that is collected up to 30 centimeter height. Third one is UAV with mica sense multispectral sensor. These pictures showing the field data collection using soil sampling and TDR. And this picture showing the data collection using UAV images. After UAV images collection, post-processing done by aegis soft meta professional image processing software. After image processing, soil moisture indices, that is evaluated, that will be explained in next slide. After evaluating soil moisture indices and field data, a multilinear regression model have been developed, and site 2 and site 1, site 2 used for training data and site 1 used for calibration. And 2 MLR methods used, enter and stepwise method. In enter method, we used entire indices, while in stepwise method, we use indices on the basis of their correlation. And on the basis of model accuracy, best model selected for soil moisture prediction. These are indices that is used in this study, like NDVI, ND, WI, SAVI, EVI, etc. And now coming to result and discussion. This graph showing the correlation coefficient between soil moisture content and soil moisture indices. This is showing the NDVI is highly correlated and WBS it is weak correlated. And these graph indicates the ground truthing of spatial soil moisture content using both the enter and stepwise method by UAV data in 4 different time period during the crop season. And these indicate the UAV data using predicted highly correlated with ground truthing observations. These graph indicates the validation and calibration. Site 2 used for calibration, while site 1 used for validation. During validation, R-square value slightly decreased, but this is within the limit. And higher value of R-square and lower value of RMSE indicates the enter method is suitable for soil moisture prediction in our study area. Likewise, for stepwise method, also higher R-square value during calibration and validation and lower RMSE indicate the stepwise method also suitable for soil moisture prediction using UAV data. These are the soil spatial mapping of soil moisture content at site 1. And both the method, like enter method and stepwise method, successfully capture the soil moisture variation when compared with actual soil moisture data. But in stepwise method, moisture slightly underestimate due to lesser used soil moisture indices. And likewise in site 2 also similar trend has been observed also, and both the methods successfully captured soil moisture variation at both the locations. We conclude UAV-based multispectral imagery integrated with multilinear regression modeling effectively estimate soil moisture content. Enter-and stepwise method models show good prediction accuracy in hilly region of Uttarakhand. Soil moisture indices and field validation TDR and gravimetric data contributed to robust model development. Spatial soil moisture content maps successfully captured field level moisture variability. UAV-based approach enhance real-time water use efficiency and support timely decision-making in irrigation, particularly beneficial for remote and hilly terrains with limited access to ground-based monitoring. These are references, and thank you.
Thank you. Thank you for timely completion of your session. You have well presented. This is regarding this technology you have used for utilizing high resolution UV imaginary for estimation of soil moisture. Very well presented. Now this time is for the next session, and that is Dr. Sivaji Sangle, Dr. Pradeep Bhalage, Ms. Sivani Sangle for soil health monitoring and improvement technique for sustainable agriculture. So Dr. Sivani. Dr. Sivali Sangle is not here. Now, so yes? No? So we'll move for the next session. That is by Ajit Kumar Nayak, Sangli, Sanatan Pradhan, S.K. Rautre, design and development of an IoT-enabled soil moisture sensing system for irrigation scheduling. Mr. Ajit Kumar.
Good afternoon, one and all. So the topic for me is on design and development of an IoT-enabled soil moisture sensing system. I am in this session. I am second presenter on this IoT-enabled system. So I will share my experience of developing a system, then installation and the challenges. So if we talk about data, it is said that water is the blood of crops. So, but if you talk about data, it says that, almost 70% of global fresh water is used for agriculture globally, but in India it is 90%. So, as one of other speaker was mentioning, the rice and sugarcane, one of the biggest consumer of water. There are n number of data set is available where, and there are also some reasons why you are consuming more water. But if you talk about the production also, productivity part also, India is almost per unit crop production, it is taking 2 to 3 times more water compared to our other developed nation. Similar with groundwater, because why I am telling it, because if you talk about groundwater, surface water, the amount of water consumption is quite high. So, to avoid this, to counter this problem, there is a very important parameter to design and development of an IoT-enabled soil moisture sensing system. So, to this August gathering of the house, I will start with the question. If I ask there, what do a thermometer measures? The question answer is temperature. If I ask what do a barometer measures, it is pressure. If I ask you what do a soil moisture measures, probably all will say soil moisture, but the answer is not. The challenge lies there. The question itself is the challenge. When I say that the soil moisture sensor do not measure the soil moisture, then what it measures? It measures the electrical properties of the soil. So basically soil moisture sensing is an indirect way of measuring the soil moisture, and the whole challenge is there. Because if you talk about India, there are so many soil types there, you will share the experience. So the problem statement is that for different, so I will say that when you design and develop a soil moisture sensing system, the most important part is the kind of calibration you do. You start it from field capacity, 27-28%, you keep on down, then go to MAD, then you go up to PWP, you do again and again the calibration. So the stringent calibration you do, the better accuracy you will get in the field, because if you talk about two extreme examples, one in Delhi and one is maybe in Thiruvananthapuram, the kind of soil, though it looks more or less same, but it's quite different if you talk about the electrical properties. So even the soil moisture sensor looks same. Same thermometer will work in Delhi and maybe Tirchi, but the same soil moisture sensing system will not work in both the places, because the electrical properties of both the soils are different. Why? Because the sand is different, silt is different, clay is different, and other parameter. So what the problem statement is that you have to make a soil moisture sensing system that will work across maybe in all different soil types. So the most important also when you're considering about the soil moisture sensor, because a lot of people are professional here, we know about TDR, we know about FDR, but how much a TDR cost? So TDR is cost, if you talk about all the access tuned everything, it almost cost 10-11 lakh rupees. The same with FDR. Of course, there have been different advantages, can go up to 1 meter depth, we can go there. But the point I want to make is, it's important is accuracy is very much important, because when you develop a machine, that has to be accurate. But the question is also about the cost part. So the machine we have developed in-house in our institute, that is costing around 20,000 rupees, and we are using, again, when the question is cost, and for how long it will work. So that part also, that problem statement, that 2-3 things I want to mention it here. One is the cost is important, accuracy is important, and the longevity for how many number of years and how many number of seasons it will work. That is the 3 things that is very important when designing an IoT-enabled systems. Give any sensor, temperature sensor, humidity sensor, IoT enabling is not a major challenge. It's very like it's a monotonous work. The same process works for temperature or humidity, but the core lies in the calibration. So the whole purpose and the objective is that we have to develop one setup for soil moisture sensing system, but few things we have taken into consideration. One is our that real-time monitoring of soil moisture data, but also it's about the portability and scalable, that is very important, because when you develop a system, like where some institutes are using it, it's not always you put in the soil. Sometimes people or maybe the PhD guys are taking it to the lab and also measuring the soil moisture. So when I talk about the portable and scalable, portable is something you can take it to the field. Also, it's sometimes take the soil sample to the lab. So one machine can take care of all, from the field, lab, and all such consideration. That of what I basically meant is in the portable and scalable. And cost effectiveness is very, very important. Because we talk about in ICR Institute also, there are few ICR institutes who are having a TDR and FDR, let alone the farmers. So it's imperative, it's very important to come with an indigenously developed soil moisture sensing system. 3 things that can take. One is accuracy, the second one is cost, and third one is mentioned is the portable and scalability. Then the material methods, I will not, because as I told, because IoT enabling of any sensor, the process is same. But here only I will, it's very important, because when you go for irrigation, let's assume, I will give an example of a cotton crops. So in cotton crops, what happened there when in different stages, the crop, the crop root goes up to maybe 90 centimeters, something 3 feet, almost about 1 meter. So what is the last point is very important, is to at what depth you will keep it to get that, because most of the probe length is limited. So the challenge also comes to what is the representative depth that you will keep the soil moisture sensing system to get the accurate value of the soil moisture soil moisture value. So as I mentioned in my first slide, that it's an indirect measurement of soil moisture sensing system. So basically what we do is, for different soil moisture, as I mentioned, that we started from field capacity and lowest down to MAD, then we go to PWP, and sometimes maybe 14 to 15%. So there we have to put it that how much voltage corresponding it is generated in the field. Because when you do that, we do this experiment repeatedly, because when you do it in the field and you do it in the lab, almost it's like the kind of repetition you do, you develop a proper relation between the soil moisture different. You can see that we have divided into 3 zones. So it's important to bifurcate in different zones, because then only you can correlate y is a function of x, where y is soil moisture and x is voltage. So again, for different type of soil, again it has to be calibrated. So the process flow diagram is, as I mentioned, I repeatedly, this is my 3rd time I'm telling, IoT enabling is not the challenge. The challenge is the calibration for different soil types. So this is a regular, so far I will tell the experience in this. So the result we are getting is, in different soil types we are getting different R-square value. Like as I mentioned, we have installed in IRI, we have installed in IRI, we have installed in IIVR, we have installed in 7 ICR Institute and SIUs. The results varying from the R-square value varies from 0.78 or maybe some 0.75 to 0.9. This is best result I am showing. In Bhubaneswar we are getting, and Sandiram soil we are getting at 0.91. But here the challenge I will mention is, it varies. The point I want to make it is because the soil moisture sensor looks same, but the setup, the results, the accuracy is varying from soil to soil. Why? Because, for example, I will take out clay soil in Bhopal. In vertisoil, if you talk about, what happens when the soil dries up, it gets loosened from the contact of this probe. So again, because the soil do not get contact with the probe, definitely the voltage will come less and the soil moisture will come less. So every different soil comes with different challenges. That's what I want to make this statement. So we are getting the R square range from, as I mentioned, 0.78, 0.77 to maximum up to 0.9. So as far as who is using this technology, so we have installed, as I mentioned, we have installed in 7 places. We have started with Varanasi, then IRI New Delhi, then NRC Banana Trichy, our institute, then Cotton Institute Sirsa, then KVK Murshidabad, and IWBR Karnal. If you see, there are 7 institutes, 7 we have categorically put in different type of soil texture. So the point I want to make it here is because when you develop soil moisture enables, our IoT enabled soil moisture sensing system, the key challenge is these 3 things I am repeatedly. The first is the cost, the second is the accuracy, and the third one is for how long it will work, the longevity of the product. And I will say that in our institute we are working almost more than 2 years, and IRI it's working since last maybe 7-8 months. And first thing we have installed in IIVR Varanasi. So IIVR Varanasi earlier was using another company, but again because when you talk about accuracy, we are comparing with the gravimetric method, and we found even in our soil also we got it a comparative value with our TDR. So this is our experiment from our from Indian Institute of Water Management, Bhubaneswar. So the point I want to make here is in the conclusion is I repeatedly told the calibration unless and until, because we are as a IIWM is the leading center as far as this irrigation scheduling and the different part of water management is concerned. So because we also come across with different type of soil moisture sensor from different organization. So we found that it's like every sensor has to be calibrated in the field condition, in lab condition. Then only it will work to maybe the accuracy will come to a significant increase. And low cost is very important. And experience says that we have done one experiment in banana. So banana under drip and banana under this standard practice of our making that is called I'm not able to remember, that is a kind of bond kind of thing around the plant. I'm not able to recall the name. So we are getting it like almost 20 to 20% saving of water. But again, that comes is like, today we call about everything like ease of doing business. Then the question comes ease of doing agriculture also. Because when you talk about mechanization, irrigation mechanization start with my understanding is the kind of a soil moisture sensing system. Because we cannot every place where you not have AWS, automatic weather station and other things. So it's very important to have a kind of a soil moisture sensor that is well calibrated in different kind of soil type, that is cost effective, and that can work maybe at least for 6-7 seasons with at a good accuracy. And this is one, our organization ICID gives certification. Also, this is one of the technology that there are 5 technologies in India that is presented in International Telecommunication Union and FAO, that is called 5G, successful use cases of 5G in agriculture. And this technology is one among them. And we got, the patent is under process. And we also got our certification from our council. So I will nothing more. So this is a lot of, there are a few media publications from different part of the country. And just this is the last slide, I will tell here because one of our other, speaker has mentioned about it. The energy is very important. So we have kept it both. We are both using a lithium-ion battery because these days if you talk about battery, power banks, normally what you use along with mobile phone, power banks are coming much more cheaper than other sources. Because also the thing is that, power banks are coming with maybe 20,000 mAh is coming around 15 to 200, up to 2,000 rupees. So we have made it compatible with power banks. Why it is important, as I told, because when a student is taking maybe to anywhere to the field, he can have his own power bank, his own source of energy, then he can measure the soil moisture. Also we have made it along with, in couple with, like when you do install permanently in the field, it is going with solar, they have step down and we have made it up to the, it can work on both on solar energy as well as lithium ion. So that's all from my side. Thank you, sir. Thank you for listening.
Thank you, Ajit Kumar Nayak. You have well briefed about the design and development of an IoT-enabled soil moisture sensing system. It's true that accuracy is very important, but for which the IoT is there, that is to be there. Now one participant was left. I again request if Dr. Pradeep Wangle, Ms. Sivani, Dr. Sivaji Sangle is there. Please come and present. I think they're not there, so ma'am, you can proceed further.
Thank you, Session Chair. And now I invite our Session Chair, Shri Arvind Kumar, to speak on the topic, present on the topic on improvement in irrigation, planning and practice. And I also request you for your closing remarks for this session.
Thank you, ma'am. It's a really very insightful session, and the total 5 speakers have presented. First one presented about the focus on canal restorations, then a case study of Bangalore rural districts using IoT-based smart irrigation. Afterwards, again case study of Nepal by using remote sensing and GIS, utilizing high-resolution UAB measuring estimation of soil moisture at hilly agriculture area, and finally design and development of an IoT-enabled soil moisture sensing system for irrigation schedule. In conclusion, the irrigation of remote sensing and geospatial technologies holds tremendous potential to transform irrigation practices for sustainable and efficient water management. Continued innovation, capacity building, and policy support will be vital in realizing this potential. Thank you all for this session. But before the last session is left with this improvement in irrigation, planning and practices. This is by me. First of all, before start of the session, I would like to make this session some communicating session so people will interact with us. I would like to understand why the improvement in irrigation planning and practice is required. You know, as on date, close to 68-69% people are staying in rural areas, and 31-32% are in urban. And the people are moving towards urban. So urbanization is going on, the factories are coming and all those things. So the demand of water will increase in the urban area more, because it is required for the drinking water, other application, also for the industry applications. Whereas the water quantity is limited, or rather water level is being down. So it is very important for us, the water which is being utilized for the irrigation is fully optimized. There should not be wastage of water. There should not be any soil erosion on everything. What is the current state of irrigation? Still, farmers relying on traditional methods, and they're waiting for the flood or surface irrigation. They're relying on the surface the flood or the surface irrigation. What is the impact on this? Impact is uneven distribution of water. Uneven water distribution. There is a soil erosion and significant water loss. So these are the impact on the current practices and the current plan. So we need to meet the increased demand of agriculture and conserve our precious water resources, we need to do the modernization and smart practices of irrigations. So what we need to do? What are the key improvement we can do? The first one is technology and better resource planning, what we're talking about right now with the various speakers. Use of Geographic Information System, GIS system, what we are talking about through the various speakers. Remote sensing, data-driven decision-making tools. This is all proper planning ensures water is allocated efficiently and promoting sustainability. What are the technologies? Technologies like GIS and remote sensing, what we are talking about, that measures the soil types. What are the soil types are there? What are the crop needs? What are the water availability exactly requirement? That is being done by this technology. Another is GPS system, which precisely monitor, precisely field mapping is being done by this GPS systems. Weather forecast informs the irrigation schedule, when to be done. This integration enhances the efficiency and effectiveness of the water use, and that is the best. This is the best thing we have to do for the better planning. How can we do it? how the resource management and sustainability can done. We can do by effective water source management, watershed management, water budgeting. We can do the water budgeting, watershed management, integrating land and water development, promoting rainwater harvesting, and all this supports sustainable practices for and avoid us and keep us away from the dependency on the external source. What are the automated and smart irrigation can be done? Automation through sensor that monitors soil, moisture, and weather condition enables real-time control of irrigation systems. IoT-based solutions, what we have already discussed, make irrigation smarter, saving time and labor and water. We can do the scheduling. We can effective scheduling based on crop requirements and the environment data ensures optimal watering. Decision support system help farmers make informative, enhancing productivity and conservations. What are the benefits of this? So first is higher crop yields. This is the first benefit we get. Another significant water savings, reduced cost, lower environmental impacts. So it also builds resilience against climate variability and water security. What are the challenges? Even by doing all this, using technology and all those things, there are various challenges because using technology cost higher. So the high investment cost is there. For the farmer, training is required because this all technology cannot be used directly by the farmers as on current date. So they need a proper training to make it utilized. Moving forward, embarrassing artificial intelligence, big data, and drone technology holds great promise for further advancement in it. And finally, integrating modern planning tools and sustainable practices vital for efficient water use agriculture, collaborating among farmers, policymakers, and technologists to quick to realizing these benefits for ensuring a sustainable future. Thank you all. Thank you all for patiently listening. Thanks.
Thank you, our Honorable Chair of this session, for your presentation. Ladies and gentlemen, we thank all of you for your attentive participation. And we are also very thankful to all our eminent speakers of this session who have contributed. So as a token of our gratitude, we would like to present them with a memento, and I would request our session chair to kindly honor the speakers with a memento. I request Mr. Gagandeep Singh Gill to kindly receive the memento, and I also request Dr. Sharad Raj B to kindly join the queue. I now invite Dr. Sharad Raj B to receive the memento, and I request Mr. Rohtash Kumar to come forward, please. Mr. Rohtash Kumar. I request Mr. Ajit Kumar Nayak to come forward, please. Yeah. I would now invite Mr. Ajit Kumar Nayak. Okay. Mr. Sandeep Kumar Chaurasia. Now I invite Mr. Sandeep Kumar Chaurasia. Thank you, Session Chair. And now I invite Engineer Felix Reinders, President Honorary ICID South Africa, to kindly present a token of gratitude to our session chair, Shri Arvind Kumar, Joint Vice President, Sales and Marketing, Rungta Mines Limited. Thank you, Engineer Felix. Thank you, our session chair. Ladies and gentlemen, with this we conclude our technical session 2 of the day. We also request you to kindly go and visit our exhibition area. We have 16 exhibitors over there. It is around the registration counter. And with this, we invite you for lunch. Ladies and gentlemen, may I request all of you to join us back at 2 o'clock. Please join us back at 2 o'clock. That is 40 minutes from now for our third technical session, which is on inclusive water management for sustainable irrigation development. May I request all of you to kindly join 5 minutes prior to 2 o'clock so that we are able to start it on time. Thank you. Enjoy the lunch. Let's now begin session 3, focused on a vital yet often under-emphasized pillar of sustainable development, inclusive water management. True progress in irrigation is not just about engineering systems, but also about empowering people like farmers, communities, and institutions to co-create, manage, and benefit from these resources equitably and sustainably. Based on these thoughts, our next technical session emphasizes on inclusive water management for sustainable irrigation development. Please join me in welcoming on the dais our Honorable Session Chair, Dr. Rajendra Podar, former Director, Valmi, Dharwad, Karnataka. I now invite Dr. Rajendra Podar to kindly join us on the dais. Thank you for your time, sir, and thank you for being there and agreeing to chair this session. Now I hand over the session to our session chair, and I also request him for his opening remarks. Thank you.
Good afternoon, everybody. Namaskar. I am Rajendra Podar, coordinating the session between 2 p.m. and 3:30 p.m. The session topic is Inclusive Water Management for Sustainable Irrigation Management. We have 7 speakers, and as all of you know, today is the closing day. We'll be rushing for valedictory. Maybe we are expecting VIPs. So I request the speakers to be very, very careful about the timings. Even if you are given 10 minutes, you can talk about 8 minutes and finish off. So that you know the difficulty with organizers. Time is a very serious constraint. So I request, I just read out the names of the people to be ready. Avdesh Kumar Sinha from Bihar. Then next myself. Then Dr. Man Singh, he is there very much, my beloved friend. Then Dr. Sanjay Belsare, Secretary Maharashtra, he is not able to come. May I know where is Dr. Superintendent Govardhan is sitting? So please, sir. Then we have, very interestingly, for information of the House, one Mr. Ravi Kumar, he is from Karnataka. Probably, don't mistake me if I say he is the only farmer in this session. He doesn't dress like a farmer, he dressed like any one of us, but he is a 100% farmer. Interestingly, he is a secretary of one very famous water user society in Karnataka, which has won the award from the President of India. That is Mr. Ravi Kumar. Then I call upon Dr. Shivaji Shingle from Maharashtra. Are you there, sir, in the hall? Shivaji Shingle, because I want you to be ready. The next is about the Atul Mohan, co-founder of WSAFE. Atul Mohanji. Then the last one is the Telangana case study, Dr. M.K. Sinha, former chairman, Godavari River Management Board. I request each one of them to be ready. If I say something about this topic, the general impression about water resource management historically has been the historical impression about water resource management is that it is confined to one or two sectors or one or two people or precisely to civil engineers. But over the centuries, over the decades, water has become such a complex issue, it gets connected to every other sector. So therefore, this session, I feel, will make an attempt to make a paradigm shift in our thinking, basically. This is not, strictly speaking, a technical session. It's more about social engineering. We have been talking about engineering and civil engineering more precisely in terms of dam building and water management. But I feel that this session will talk more about social engineering. How different sectors of the society in the entire globe can be involved in this. That we will be making presentation. I'll be dealing in detail about this inclusive water resource management, how the engineer, a farmer, a researcher, academic institutions, all of them can, join hands to make irrigation development a very successful enterprise. And as all of you know, this water is getting scarce and more complex with the climate change issues. So this has to be handled in a very systematically multi-stakeholder world. This session, I feel, I request the speakers to focus more and more on inclusive water resource management. Basically, this is an appeal. It's not a laboratory discovered instrument or a technology. It's a social engineering, I basically mean by that. From today onwards, let us shift our mind towards social engineering, how all others in the water resource management can be involved collectively to make irrigation development successful one. I request Avdesh to start this presentation.
Thanks ICID for giving me opportunity to present here Bihar's initiative towards inclusive water management for sustainable irrigation development. Bihar's government commitment to the principle of न्याय के साथ विकास, the program of good governance was implemented across the state under the Atmanirbhar Bihar 7 Nikshay 2 2020-2025 schemes. Objective of the scheme is to improve the lives of people and plan for a state development and make it self-reliant. Saksham Bihar. Launch of the scheme 7 Nikshay 2 was launched on 15 December 2020, out of which हर खेत तक सिंचाई का पानी program was one of the 7 Nikshay 2. Under the 7 Nikshay 2 program, Nikshay number 3, हर खेत तक सिंचाई का पानी, irrigation water to every farm through all possible means, was implemented by assigning specific targets to each of the following departments of government of Bihar: Water Resources Department, Minor Water Resources Department, Rural Development Department, Rural Agriculture Department, Environment, Forest and Climate Change Department. Under this program, a joint technical survey team was constituted for each block, consisting of local administration and technical officers from above mentioned departments of Government of Bihar. Aforesaid technical survey team conducted meetings in 74,134 villages, hamlets, tola of the state, and in light of the suggestions received from local farmers, a scheme were selected on the basis of available water sources and its initial technical feasibility. During the survey, 8 types of schemes were selected: construction and rehabilitation of field channel, rehabilitation of canal, check dam construction, ahar and pine. Basically, ahar and pine is a traditional irrigation system in South Bihar, particularly in South Bihar, where rainwater capture the rainwater and divert through channel, irrigation field and water recharge also. And lift irrigation scheme, irrigation through anti-flood sluice, possible expansion of canal, tube well irrigation schemes. Under this scheme, WRD Bihar has taken 1,378 schemes, and against which 1,342 schemes were completed as of now. These all schemes are executed in 3 phases. Phase 1, 597 schemes were completed against 604, and phase 2, 328 schemes were completed against 332, and phase 3, 417 schemes were completed against 442 schemes. And what we have achieved under phase 1, 1,18,577 hectare irrigation potential achieved against target of 119,062 hectare. And phase 2, 1,83,126 hectares of land irrigation potential achieved against target of 186,679. And phase 3, 316,152 hectare achieved against target of 1,360,124. Hence, total irrigation potential creation restoration about 6,17,100 hectare. Remaining 36 is like targeted to be completed in this year. Now, the state is facing profound and dangerous paradox. We are a land of both, devastating due to flood and drought, due to a scarcity of water in the same year. Bihar has a unique geographical location due to which almost every year the northern Bihar is affected recurring floods, whereas southern Bihar suffer from floods, the drought. Geographical area of the state is 94.16 lakh hectare, out of which 68.8 hectare is flood prone. Moreover, within the Bihar region, river Ganga flows through an area that has predominantly flat topography. The feasibility of constructing water storage structure is such terrain is considered impractical. In the region of South Bihar, where water storage is feasible, there are several reservoirs. However, field water storage capacity of these reservoirs has only reached an average of 35% over the past 3 years. Consequently, there is need for regular replacement of these reservoirs. The condition of South Bihar groundwater condition has depleted significantly over the past decade. This depletion has exacerbated by reduced rainfall, leading to emergence drought-like condition and a scarcity of drinking water also. The increasing demand due to industrialization and population growth has put further a strain on water resources in Bihar. Climate change and erratic rainfall pattern have compounded these issues, leading to water scarcity in many regions of Bihar. The situation not only affects agriculture but also has serious implications for drinking water availability as well as ecological balance in the region, especially in South Bihar. Recently, a state has started one of the notable Ganga Jalapurti project. Through this project, during monsoon season, Ganga water is transferred to reservoir located in South Bihar for its storage and supply it to the urban population throughout the year. Gayaji, Rajgir and Namada. Now we are thinking about irrigation through diversion of flood water. One project, Government of Bihar is executing transfer of surplus water of Ganga river during flood period to Badwa reservoir of Banka district and Kharagpur reservoir of Munger district. Due to climate change and irregular rainfall, there is a difficulty in providing assured irrigation facility for Badwa and Kharagpur reservoir. To overcome the problem, it has been proposed to provide assured irrigation facility by lifting the water of Ganga river at Sultanganj only during flood period of 4 months, July to October, and storing it in Banka and Kharagpur reservoir. Benefits of the scheme is to ensure irrigation facility to 45,850 hectares from Badua reservoir and 5,310 hectares from Kharagpur reservoir, along with fulfillment and drinking requirement also. Here are the pictures of Kharagpur reservoir, benefited district Munger, cultivable command area 5,300 hectares, lost irrigation potential of 3,434. Another reservoir, Badua reservoir, benefited district Banka, Bhagalpur and Munger, cultivable command area of 45,850, lost irrigation potential of 25,813 hectares. Here the component of the scheme, intake well and pump house will be constructed near Sultanganj in Ganga river, and 2.4 meter dia pipeline of 31 kilometer will be laid, and regulator near Mania village will be constructed, and 1 meter dia of 70 kilometer will be laid up to Kharagpur reservoir, and deficit water of 11.33 MCM will be lifted from Ganga during flood period. And another pipeline of 2 meter dia of 24 kilometer length will be laid, and detention tank and pump house in Bijforwa irrigation colony will be constructed, and further 2 numbers of 1.4 meter dia pipeline of 3.12 kilometer length up to Badua reservoir will be laid, and deficit of 43.67 MCM will be filled from Ganga water during flood period. Thanks.
Thank you, Avdesh ji. I would reserve my presentation to the later period. May I request Dr. Man Singh to kindly come out to the stage. Dr. Man Singh is a former director of Water Technology Center of ICR, so based in New Delhi, and very excellent academician. Dr. Man Singh ji, please.
Good afternoon to each one of you. With the permission of Chair, I would like to thank ICID for giving me this opportunity to be part of this function. Also, I would like to congratulate ICID for their Platinum Jubilee celebrations. We heard a lot of things yesterday and today also. I have chosen a topic. This might sound a little bit provocative, but I did it deliberately. Land drainage, elusive in the development of irrigation infrastructure. Although our visionary people, way back in 1950, they named International Commission on Irrigation and Drainage. So on that line, I thought that we are celebrating irrigations for a couple of days, but also we have to pay little attention to the drainage. That's why I chose this. Next one, please. Or I can operate. Can somebody help me? ग्रीन बीच में दबा रहे हैं ये तो sorry. This slide reads, we'll explore the contemporary issue on water related subject. Here, when we say inclusiveness, I think we are not including the adequate measurement of water widely, not including land drainage and salinity control. The water will determine the quality of life of both rural and urban citizens of the world. The strategy for water resource management and governance ability will decide the fate of future generation. Governance ability, I will display some slide related to USA and China and will compare with India. This is the pronouncement of our very popular Prime Minister, Mr. Narendra Modi, that har khet ko jal, har ghar ko nal se jal. I can translate in the English that this goal suggests that the country should have water at each and every farm, and also each and every household should have tap water flowing throughout the year and 24 hours. To achieve this, we need adequate network. This slide just suggests that everyone for water can walk to the source except the plants and the trees. So that case, irrigation network is needed. You are all very learned people. I need not elaborate. So everybody can think that we need to feed the projected population in the 2050 adequate intensive irrigation network. How we will have it? The facts of the nature, kindly pay attention to this. I just synthesize few things. Even if irrigation water is of excellent quality, it still brings some amount of soluble salts into the fields that are being irrigated 30 years, 40 years, 50 years, and so on and so forth. And next one is import of irrigation water means an input to salt. It is inevitable to import the water for irrigation, but at the same time, we have to think about the drainage and the leaching of the salt as well. General irrigation practice has been talked right from yesterday. For your information, I would like to mention that from yesterday, the first presentation, Secretary General Dr. R.K. Gupta said 70% water is for agriculture. Then one South Australian governor, she said 75% of water in agriculture. Secretary Government of India, she said 80 to 83% of water in agriculture. And then one company representative today said 85%, and one Nayak, one young presenter, he said 90% of water. So there is a lot of discrepancy. When yesterday Saroj Kumar Jha, he said that the data is a deficit in this entire world about the irrigation, how much really water is, because it is not being properly measured. So that discrepancy is there. So we have to look further. For a standing observation for 7 decades, salinity buildup in agricultural land is a very slow process. Therefore, farmers, engineers, government officials, policymakers, and political leaders see irrigation only as the need of today, and salinity and water table control through subsurface drainage is a problem of tomorrow. We are postponing this problem. Why I want to say that there has to be adequate investment, futuristic investment. How it will happen? The knowledge of the professional knowledge and wisdom suggests that irrigation and drainage go together like head and tail of the same coin. Face of irrigation is seen for the past over 100 years. The drainage is still waiting for its turn. When I talk about this, again I recall when Saroj Kumar Jha mentioned that by 2050, the world will have 10 billion population and the world will not be able to produce more than 3.5 billion people. That's what he said. If our BAU, business as usual, goes on. So this is the really a problem. The land may degrade and we'll have like that. This degradation process is slow, so it is not very visible. It is similar to what diabetic and the dyslipidemia happens in our human body. Let us look at how we practice. Yesterday, one of the former president, honorary president, mentioned that around 100 million hectare irrigated, the land is irrigated in India. So we see that surface flow, 90 to 95% irrigation with this method, but intellectual attention only 5 to 10%, whereas the micro irrigation only they mentioned about 10 to 12 million hectare in the last 30 years of effort in India. So what I want to say here is that the major loss of water is happening in that method. So this intellectual attention has to have a paradigm shift, as Mr. Chair you mentioned in the beginning, Dr. Podar. Here, this is the view of, a very schematic table of Indian context. We have 690 billion cubic meter of surface water. We are able to store only 257 BCM out of 5,500 dams, And 80% why I mentioned, I took a highlighted one, the average of those things, the 80% water we are using in agriculture. So the efficiency we assume little higher. It is around 40% in different literature, overall irrigation efficiency in this country. I took 50%, so loss is around 103 BCM because of poor efficiency. And the entire population of 142 billion in the country, 142 crore, 142 crores, 360 days, every 120 liter per day, we need this much. So this table suggests that the water we waste in surface irrigation method is much more than fresh water we need to feed the entire domestic need. So long-term investment for long-term gain as compared to the short-term measures, why investments? When I was young at the age of 51 years, around 13, 14 years, I used to say this country in those periods, at least the country needs investment in water sector 4 lakh, 5 lakh crore 13 years ago. Now let us see here, why we should do investment. I synthesize that. These are the viewpoints. Causes of investment, socio-economic, political, geopolitical, and reputational consideration all contribute to water resources development for the sustainability. Sustainable development goal is approaching fast 2030. Let us see this very interesting data. I did some research and I found that large dams data, the USA has 19,700, China had 22,104, India 5,500, number could be here and there. This is from World Commission of Dam 2000. But look interesting, last 25 years, 2000 to 2024, China added 1,732 large dam, means 70 dams per year in last 25 years. Now China has a different vision. That's why, when we are discussing in the last maybe couple of 2-3 months about the world power balance, that China is talking, head on head with Trump. Everybody knows about it because of the strength and power. This is very startling. Now, this is 21st April. The Ministry of Jal Shakti Government of India proposed, I think the figure says 9.1 lakh crore for Jal Jeevan Mission only. Forget about irrigation, drainage infrastructure. Jal Jeevan Mission, the country, Ministry of Jal Shakti Government of India proposed that figure is the 9.1 lakh crore. Now you see that things are coming up. Mantra, think big, start small, act fast. The last one, we are struggling. We have to make a paradigm shift in this country. Let us look at this slide. Prime Minister Narendra Modi used a metaphor in 2015 when he launched Pradhan Mantri Krishi Sinchai Yojana and repeated on May 26, 2017. He said that farmland is like human body. Now let us see let us review the human body. This is the human body, this is a nerve system. The nerve system, all communication system, I did not elaborate because I can go on, but you are all very intellectual people, learned people. The mobile network, all communication is subtle. That means if you look at the globe and the body, it is analogous. Analogy is there. Then we see this skeleton. On the entire economy stands on road network, rail network, air network, ship network, blah, 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 many networks. But very important thing which I'll talk a little later. Can we make Indian farmers independent of monsoon and climate change? What China and India, USA are thinking in their own ways. China thinks that they would like to export water in terms of fruits and vegetables. Like what we are talking for many years, that we export a lot of virtual water through rice. So you see this, we have to answer this question for our resilience. Now this is the last which I wanted to say. The artery and vein, which is very important in body. This is in human body. I would translate into the globe or maybe Indian map, and that looks like artery and vein model. This artery and vein model, first time I proposed in 2011, published in 2013 and 16 in Drainage Symposium that was held in USA in 2016. So this is what I was just wanted to convey very subtle, in a subtle way. The human artery, vein, tissues and cells correspond to irrigation, drainage, villages and individual farms respectively. I saw a lot of good development by the private companies in the forenoon session when I saw that arteries are being laid through pipe network for irrigation supply and this so on. Here, this is the land we will have after the so many years of irrigation, salinity and so on. So this machinery should come in Haryana, Punjab, Maharashtra, Karnataka, Tamil Nadu, Telangana and whatnot to reclaim. Otherwise, our fertile land will go degraded 8 to 10 million hectare of land, and that's why the food shortage might arise. So this is the technology of, putting veins in the land, the fertile land. That's what I was talking, artery and vein. And the other improved technology is this state. So these machinery should lay. I think I'm missing Dr. Chandra Madhuramattu. He would have been here, a drainage expert from McGill. So major flaws are reality. Let us analyze this. Nowhere irrigation water is measured, no fair pricing of irrigation water. So the commodity that is neither measured nor fairly priced, no matter how much effort we'll make on the ground, efficiency cannot be achieved. That's what I have a very strong conviction to state that. Now let us possible solution. Measure and treasure and pay some appropriate amount. This bracket I put because many people call that this is a very sensitive topic. But we have to talk the talk. So here, if we do not agree to pay the water resources now, we will pay heavy price after 20 years. That's what the World Bank representative, Mr. Jha, flagged yesterday. Policy change, he also mentioned about free irrigation, muft sinchai, no. Muft bijli, no. Because we have to think about it, find some alternative. That's what I would like to say. So 3 points to ponder: irrigation water economy. That's what I think Mr. President mentioned. Ultra low discharge, low drip irrigation, ULDA. That's what the technology will do. Land drainage not to be forgotten while reforming water infrastructure. 2047 developed India goal. If we miss this, we will not be able to produce that much of food grains which is needed because of degraded land in those periods. Need for enactment of law. Many people talked. Irrigation water rights and effective policy for controlling groundwater resources. So this, I just wanted to say that these things happened right from 1972 when National Water Grid was referred by no less than that, the then irrigation power minister, Dr. K.L. Rao, subsequently Dastur, interlinking of river, 2001, finally mandate given by the Supreme Court of India. So this has not been done because 2-3 places are done. So what I want to say that the pace has to be there, pace, otherwise we may miss the boat. Now this business as usual, individual ambition, every state has its own, every person has his own. This, for the sake of water, this has to be ups and down. Cooperation ambition has to go up, not the individual ambition. This is, I'm talking in a generic sense, for the sake of water infrastructure. Expected outcome, once the countrywide network of irrigation and drainage infrastructure is in place, functional one, with the strong political will, farmers may become independent of monsoon rainfall and climate change. Poor husbandmen can take diversified crops round the year, minimum 3, maximum 4 crops per year, and can earn money like any salaried person. Something to inspire, you are listening for quite some time, to make little lighter. When dealing with water, place practice before theory. Leonardo da Vinci, 500 years ago, he said, let us collectively modify the dictum in the context of today. When dealing with water, place ancient practice, theory and modern know-how. Many people have talked about modern know-how together to solve the water problem. and a robust and economic irrigation and drainage infrastructure is needed to achieve those two goals which I flagged initially. Big investment is inevitable for irrigation and drainage network, artery and vein model. That's how, if the entire country can move if there is a water, because the body moves with the help of water. The vehicle moves with the help of gas and gasoline and petroleum, etc. So, thank you so much for your patient hearing. This is what I just wanted to submit very respectfully. Thank you so much. Thank you so much. Once again, thank you so much, ICID, Mr. President and Secretary General and Chairperson. Thank you.
Thank you, Dr. Mansingh, for a very colorful presentation. The carry-home message is that out of the total irrigated area, 20% and more has gone out of cultivation because of mismanagement and unscientific water management. This is a negative externality of irrigation development that is often being neglected. That's why when we spoke, he said, I will try to bring this issue or the dialogue or discussion on land degradation to the forefront of discussion. I think he has done it rightly. We will start thinking on this very serious problem. It's a negative fallout or negative externality of irrigation development that needs to be rectified. This component needs to be included. Thank you, Dr. Mansingh ji. Then Rajesh Govardhane from Maharashtra. His topic is, Maharashtra has done some very innovative programs and innovative policies also. And one of the persons leading these initiatives, Dr. Sanjay Belsare. I spoke to him yesterday and he said, I'm busy with the government cabinet meeting. So his colleague, Rajesh Govardhane, will make presentation on innovatives of Maharashtra Water Resource Department.
Namaste. Myself, Rajesh Govardhane, representing WRD Maharashtra. First of all, I greet ICID for their Platinum Jubilee. Friends, Maharashtra is a progressive state, and Maharashtra is always ahead of adopting new techniques in WRD. In Maharashtra, nearly 2,400 dams are constructed, which is nearly 42% of India. Here we take a review, generally, in what parts, for the betterment of stakeholders, Maharashtra taken steps ahead of others. Firstly, planning, then participatory irrigation management, then regulatory authority, then auditing and benchmarking of irrigation projects, then PPP, public-private partnership, then academic institutions participation in WRD, then technological intervention for efficient water management. We go step by step. Friends,
so I hope restrict to the time present.
Okay, sir.
Given, sir.
Yes. Integrated state water plan. Out of 29 major basins in India, 6 basins are in Maharashtra. In Maharashtra, we formed 5 river basins. River basin agencies, and through them we plan the integrated state water plan with the help of various stakeholders with concerns of them, and we consider the future planning up to 2030, considering the requirement for irrigation, industry and drinking. And while doing this, we plan the 6 river basins and considering nearly 1,500 watersheds. While considering that, we also consider the water divergence that is from western flowing river of Maharashtra. Farmer participation. Since long in Maharashtra, third irrigation system is developed in Maharashtra since 16th century. We are always ahead in PIM In Maharashtra, nearly 48% of irrigation potential that is created, that is under WA now. We have started MMISA Pact. In that, these are some facilitated for the farmers. Here we give waters volumetric basis, and then for water users association there is freedom of cropping, and there is adequate representation for women particularly, and we always do irrigation from tail to head, and we are also giving them the whatever the water says that are collected, we give them back nearly about from 50% to 93%. Whatever water is collected, we give them back for the operation and maintenance to WAs. This is the scenario of WAs in Maharashtra. Up till now, nearly this chart shows the functional WAs in two acts, that is MMIS Act 2005 and Cooperative Acts. Nearly 2.65 million hectare that is covered under WAs, which is nearly 48% of the irrigation potential created by Maharashtra. To facilitate the WAs at various level, that is on division level, circle level, we created a facilitation cell for WAs. We also started the awards for best working WAs from 2009. That is Punya Shlok Ahilya Devi Holkar award under the Mahatma Phule WA Abhiyan. Here we give the awards to WAs from all the 5 regions of Maharashtra. You all know Vaghad system. That is the best example of PIM and WAs, and this is Vaghad success story is now we all were knowing it. Here in Vaghad, active women's participation is appreciated all over the world. Now 6 chairpersons are women out of 25 WAs, and nearly 75 women members are present now in 25 WAs on Vaghad project level association. Here we just go through the achievement. Vaghad is the first project, that is the whole project is handed over to WAs. After the handed over of project to project level association, we see the difference. That is before handing over to project level, the area irrigated in year 2004-5 nearly 800 hectare, 8,000 hectare. Now it is above 11,500 hectare, and the whatever the water recovery, that is water charges recovery, is nearly 3 times of that. And now the irrigation methods also changed from floods, 75% area irrigated through flood irrigation. Now nearly 40% area is under drip and sprinkler, and the average net income of the farmer is increased from 60,000 to nearly 5.5 lakhs per hectare. In Maharashtra, for the regulation of the regulatory authority is formed in year 2006. Here the main work of this MWR is, it is a quasi-judicial body, and here the whatever the project that is included in integrated state water plan, that is scrutinized in MWRA, and then construction is started in Maharashtra. And basically, what are the water rates that are finalized by MWRA in consultation with the stakeholders, various stakeholders like farmers and various NI customers, that is various industries, and also the whatever the redress of whatever the water rights enforcement and grievances are also redressal at MWRA level. In Maharashtra, we also PPP. We are also taken the help of ITC company in Maharashtra for various projects, like in Vidarbha Dehni project, in Uttar Maharashtra Palkher Irrigation Division, then Central Maharashtra Kukdi Irrigation project, and in Paschim Maharashtra, that is Tembu and Krishna Koyna lift irrigation scheme. Here this is the universal and then baseline, what is the target fixed and the progress. Now this project is in progress, nearly 1.5 year completed, and 1.5 year is balanced. This is the progress card of PPP model with the help of ITC company. This is the whatever the ITC company mission under Sunairakal, that are the these officers or whatever the persons, they are giving education to the farmers in the command area of the projects enlisted before. In Maharashtra, we also included the academic institution participation for the involvement for WS, improving the WS and water use efficiency. For example, Mumbai School of Economics and Gondwana system. Mumbai School of Economics is working for Lower Dudna project, and Gondwana University for Gosikur National project. We are also empaneled some NGOs for WS empowerment. That is Pani Foundation, then Yuva Mitra from Sinnar, and Development Support Center. With the help of these companies, we are also started some farmer producer companies, and this chart shows the number of farmer producers company formed under the various projects like Gosikur, Lower Dudna, Waghad, and the number of WAs associated with that farmer producer company, also number of farmers and whatever the area covered under that farmer producer company. Technological intervention for efficient water use management. Another is now in Maharashtra we providing water to all the stakeholders volumetric basis. In Nasik district, Tisgaon Dam, this is a medium project. Here nearly 450 SCADA based water meters being fixed by 811 farmers, which are the members of the 7 WAs form over Tisgaon Dam. We are also introduced the RTDAS system over Krishna and Bhima basin for flood mitigation. Then PM Gati Shakti portal mapping is in progress. Then Yuva transpiration based irrigation performance assessment also started. This project also started in Maharashtra. Tisgaon medium project, these are some photographs of that SCADA based water meter. RTDAS Krishna Bhima basin. Krishna Bhima basin covers the nearly 70,000 square kilometer of Maharashtra, and in Krishna Bhima basin nearly 250 dams are there that are gated and ungated. Here we introduced RTDAS, that is real-time data acquisition system, RTSF, that is real-time stream flow forecasting, and ROS, that is reservoir operation system. These are worked with the software Mike 11, and for this we fixed automatic full weather station, about 42 numbers, automatic rain gauge station, nearly 127 numbers, gauge discharge station at 37 numbers, and reservoir discharge for gated dam, about 47 gated dams, and this data acquisition is collected in monsoon about every 15-minute cycle, and with the help of that we forecast 72 hours before whatever the flood is going to become in next 72 hours. This is the dashboard of Krishna Bhima Basin RTDAS system. PM Gati Shakti. PM Gati Shakti, they are launched in 13 October 2021, that is Central's flagship program. This includes dynamic mapping of all infrastructure projects with real-time updation, comprehensive database of ongoing and future projects of various ministries integrated with 200 plus GIS layers to facilitate planning, design, execution of infrastructure project with common vision. We also feed the data of our major and median dams, now minor projects data feeding in progress. We also used PM Gati Shakti portal for alignment of canal, dam. Here we use the forest departments layer to identify the whatever the forest line is required to we required for the acquisition to build future irrigation projects. And the final one is evapotranspiration, that is ET-based irrigation performance assessment. By CWC, with the help of CWC, we are from Maharashtra, 2 projects are selected for this work. That is Mula Major Irrigation Project and Purna Major Irrigation Project. In Maharashtra, we started the to establish the irrigation projects with 12 indicators, performance indicators, that are system performance indicators, 3 numbers, agriculture productivity indices, 2 numbers, financial performance indices, 5 numbers, and social aspect, 2 numbers. Nearly 12 indices we are developed to evaluate the performance of particular irrigation project. And by considering this Maharashtra's initiative, CWC contacted us, and they are we are working in hand to test the irrigation performance based on evapotranspiration. The conclusion is that inclusive water resources management is the base of various reforms in Maharashtra. Water policy as well acts policy and acts empower the inclusive management with the technological interventions I mentioned before. It will further facilitate participations of farmers and various stakeholders. With inclusive water resources management approach, goal of sustainable development can be achieved. Thank you, gentlemen.
Thank you, sir, for your beautiful presentation. Mainly, Sri Govardhan is highlighted on a part, a component of the inclusiveness. One is the farmers' participation, that's very important as part of PIM. The second one he highlighted, and that is a highlight of Maharashtra water reforms, that's more and more women are being involved or included in water resource management activities like being members or chairpersons of the water resource societies. That's really a model to be copied by other states in India. Next is Ravi Kumar, farmer from Karnataka. May I request Ravi Kumar? He is Mr. Ravi Kumar. There's a project called Gondi project funded by Asian Development Bank in Karnataka. So very old project, century-old project has been repaired and rejuvenated. They have formed 11 water user societies. And one of them is Kage Kodamagi. It's a little difficult to pronounce in Kannada, Kage Kodamagi. He has been secretary of the society for the last 10 years. It's the most innovative society in Karnataka, even you can say in India, along with Wagad and Wagad project societies. He himself takes a lot of interest and brought out many innovative ideas. He may have difficulty in presentation in English. May I request Dr. Dongre to kindly support him in English for the global audience. Please come over. He is a land development officer who looks after these societies. He may support Mr. Ravi Kumar in his presentation. Only request is try to limit yourself to time given. Dr. Dongre. We lost 15 minutes just to begin with, and we are spilling over and 5-6 minutes. Please, Ravi Kumar and team.
Good afternoon, everyone. I am Ravi Kumar a farmer and the secretary of the Water User Cooperative Society Limited, Kagekodmagi, Karnataka. I extend a warm welcome to all the dignitaries and participants attending this conference. Congratulations to the International Commission on Irrigation and Drainage on its Platinum Jubilee. Our Water User Cooperative Society was established in the year 2000 and falls under the Gondi Dam Command Area. The society covers 323 hectares of irrigated land, includes 439 landholders, and has 417 shareholders. The society spans 3 villages with 2 branch canals, 9 DP outlets, and 19 PO outlets. At the time of the society's inspection, water from the Gondi Dam Canal was not reaching the tailland farmers, leading to crop losses due to insufficient supply. With the cooperation of local legislators, the Karnataka Niravari Nigama Limited and the Bhadra Command Area Authority, we undertook canal cleaning of the Gondi Canal, which helped ensure water reached all farmers under the society. Water management is handled by operating canal gates provided by Irrigation Department structures by Karnataka Niravari Nigama Saudis. Since 2008, the society started collecting water charges which are paid to the Irrigation Department, with the remaining amount being utilized for administration and canal maintenance. In 2009, with the support of the Bhadra Kada, we constructed an office cum godown. Later in 2018, a meeting hall was built with assistance from the Asian Development Bank. Under the Gondi Modernization Scheme, 2017 to 18, works worth approximately 3 crore were executed by the society itself, including field canals, sub-canals, cart bridges, and pipe culverts. From 2015, with Rs 65 lakhs from Bhadra Kada, we undertook construction of irrigation roads, sub-canals, and underground pipelines. For effective water management, since 2015, through the Gram Panchayat under the Narega scheme, cleaning works have been carried out for the main canal, branch canals, and field canals at a cost of around Rs 67 lakh. The society encourages organic farming and intercropping to promote integrated farming practices. It also rents out agriculture equipment to farmers. Through the society's website, we share water distribution data and complete organization information. In 2018, as part of the Gondi Modernization, a project-level federation was formed, which now oversees all societies within the Gondi Project Command. Our society provides training to office bearers and farmers from other societies. We provide training to members, secretaries, and office bearers on administration and irrigated farming practices. For the commendable efforts, the society received the Prerana Award in 2019 under the Gondi Modernization Program, and more recently in 2024, it won second place in the National Water Awards under the Best Water User Cooperative Society category, conferred by the Ministry of Jal Shakti, Government of India. I would like to acknowledge that these achievements were made possible due to the collective efforts of the Society's Board of the Directors and the support of various departments. With warm regards to all, I conclude my speech. Thank you.
Thank you, Ravi Kumar. We often talk of participatory irrigation management as a recommendation of the ICID as well as a national priority as envisaged in water policy of Government of India. But actually at the field level we have many challenges, but they have overcome. They have made it a model, and this model can be replicated. The entire water management is taken over by the farmers. It's a very simple and humble small farmer, very effectively managing. This is how the inclusiveness is highlighted in his presentation. Thank you for very nice presentation, Ravi Kumar. Next is Atul Mohan ji. His topic is WSAFE NBS Phyto Eco-Remediation, a nature-based solution for disease, pest and weather resilient farming. Once again, I request the speaker to restrict to the time allotted.
First of all, thank you to MC and ICID for giving us the platform. So the topic is that how do we make our farming disease, pest and weather resilient? And we have a nature-based solution. So WSAF NBS is nature-based solution. And how do we do that is, sorry, it's not. Yeah. Okay, just a short background. We have been recognized by Niti Aayog amongst the 50 innovations in the life sciences and biotechnology. We have won many awards for water innovation and also on the climate innovation. We have got some grants. So coming to the topic, so these are the challenges what today we are facing. High chemical inputs, soil degradation, biodiversity loss, climate stress, wastewater pollution and groundwater depletion. I think most, since yesterday we have been hearing all these issues. I'll just jump to the next slide. This also is very much, we are aware of it. And same here, right, for this issue also. So coming to the solution, so what is the solution? So we have developed a technology which is based on the phytoremediation. So it is advanced form of phytoremediation where we are doing phyto-eco-remediation. So this is all based on Indian ancient wisdom. Using that, we choose very specific herbs. It could be shrubs, it could be seed root, and we make a portion of it in a liquid form. And this is a very simple bottle in which this liquid is shipped to the location, and it is a very low cost solution. And what it does, right? So using this solution, we are able to create a very low cost solution addressing all the challenges what you have seen in the slide 3, right? How do we do it? What is the methodology we follow? So what we need to do in a farmland is, the basic thing what we need is a pond, right? Because why we need a pond is because there the three elements, the core three elements meet, which is soil, water and air. And there is a constant exchange which happens between them. So all your wastewater, whether it is from the village or it is from your wastage from the biogas plant, or it could also be from the animal waste, and whatever irrigation you want to do, you put all the, if it is from the canal, put the canal water also in the pond, or if it's from the borewell, you put the borewell water also in the pond only. And there, using this solution, you just have to mix this in a fresh dark water. Dark water is nothing but groundwater which has not seen the sunlight. In the fresh dark water, and release in the pond at the sunset time. So this is the very simple thing anybody has to do. So therefore, the whole solution is community driven. They can drive it on this own. We can ship this based on certain inputs once we have. And what you now need to do, all your farming, whether you are planting fruits or vegetables or flowers, whatever you are doing, you just have to spray this treated water and only use this treated water for the irrigation purpose from the pond, nowhere else, right? So this is what you need to follow. And as it's been said, the taste of the pudding is in eating. So I have a testimony from a customer who's been using our technology for the last 4 years in Raipur, and you can see the video. Can you please play that?
किसान आंदोलन जिसका मुद्दा है एमएसपी और मंडी, जबकि मूल समस्या है पानी और खेती में लगने वाली बड़ी लागत, इनपुट कॉस्ट। हमने शोध किया वैदिक विज्ञान पर और इस समस्या का जड़ से निवारण ढूंढ निकाला। फैक्ट्री के गंदे पानी को कच्चे तालाब में लाकर आयुर्वेद विज्ञान से शुद्ध किया जाता है और पानी को न्यूरो इम्यूनो बूस्टर बनाकर उसे खेती और पशुपालन के लिए उपयुक्त बनाया जाता है। बिना किसी केमिकल या जीवाणु के इस्तेमाल के ही पूरी खेती, पशुपालन और मछली पालन को पूर्णतः रोग, कीट और मौसम की मार से मुक्त किया जाता है।
You don't have to use any kind of fertilizer, insecticide, pesticide, weedicide, no urea, nothing has to be put in the farmland. Just the treated water has to be sprayed over the farmland.
हम एक पाउंड बना के इसका
So
पानी ले लें।
this customer has got a rice mill, and his rice mill wastewater is been put in this pond, and there we are treating it along with the biogas slurry and other contaminants.
आज की जनरेशन में लोग इतना अफवाह फैला दिए हैं कि बिना फर्टिलाइजर केमिकल की खेती होती नहीं करके। तो मेन जो खेती में जो ज़रूरत है वो है मेन पानी की। ज़मीन तो है ही, लेकिन मेन जो ज़रूरत है पानी की रिक्वायरमेंट 70% होती है, और वही 70% पानी के बारे में ही मैं आपको आज बताने जा रहा हूँ। बेसिकली मैं फार्मर नहीं हूँ, मैं राइस मिलर हूँ। राइस मिल उसना राइस मिल है, और राइस मिल का जो वेस्टेज पानी निकलता है उसको अगर ज़मीन में छोड़ दिया जाए तो ज़मीन को बंजर कर देता है। मैं एक पॉन्ड बनाया हूँ लगभग 10,000 स्क्वायर फीट का। उस पॉन्ड के अंदर उस पानी को डालता हूँ और सॉल्यूशन है वो डालता हूँ, वो स्लरी डालता हूँ। और सबसे खास बात यह है कि जो वेस्टेज पानी है, इतना गंदा बदबू भी आता है, उस पानी का स्मेल तो पूरा ख़त्म हो गया है, और ख़त्म होने के बाद उसका हार्डनेस और टीडीएस बहुत ज़्यादा रहता है पानी में। जिस समय वो हंडी से निकलता है, मिल से वेस्टेज के रूप में निकलता है, लेकिन यहाँ आने के बाद जब उसका सॉल्यूशन हम डालते हैं तो उसका टीडीएस लगभग 500 के आसपास आ जाता है और हार्डनेस भी 500 के आसपास आ जाता है। और सबसे अच्छी बात यह है कि वो पानी पूरा एल्कलाइन हो जाता है, 9 pH का पानी बन जाता है। हम उस पानी को, हमारे पास जो गाय हैं, हमारी जो गौशाला है, हम उस पानी को पूरे गाय को हम पिलाते हैं, और उस पानी को गाय को पिलाने से सबसे बड़ा बेनिफिट ये मिला है कि गाय में बीमारियां भी कम हो गई हैं। हमारी पूरी गाय उसी से धुलती है, गौशाला उसी से साफ होता है, और वही पानी हम गाय को पिलाते हैं। तो एक भाजी से ये पानी का हम उपयोग चालू किए हैं, तो उसमें हमको रिजल्ट बहुत अच्छा लग रहा है। और एक जमीन में एक फसल की बजाय हम अनेक फसल ले पा रहे हैं।
What he's saying is now, beside one basically yield, he's also doing flowering in that. He's doing vegetable. He's doing kela farming in the same farmland.
लगभग गेंदा का लगा लिए हैं, और वही 2200 के आसपास हम गोभी का पौधा लगा लिए हैं। तो ये दो चीज़ जो एक्स्ट्रा लगाए हमको एक्स्ट्रा इनकम में अच्छा सपोर्ट करेंगे। तो हमको जो है लागत तो कम आ ही रहा है, क्योंकि फर्टिलाइजर केमिकल का उपयोग है नहीं, और उत्पादन भी अच्छा आ रहा है, और एक जगह में हम 2 से 3 फसल लगा पा रहे हैं। तो हमारा माल जब हम मार्केट में बेचते हैं तो दूसरे से 2 रुपये ऊपर ही मिलता है।
So what he's saying is he always get a better price for his yield in the market as compared to other farmer. Coming to the outcomes, this is very, very important slide. SOC is the very important component of soil, right? If you say carbon in the atmosphere is pollution, same carbon in the soil is diamond. So we are the only technology which can not only sequester carbon, but it can also fix the carbon in the soil. And this we have been doing in this farmland for the last 4 years. The SOC level has increased by 5 to 10% over a single cropping cycle. The carbon sequestration, with what we have seen is, it's estimated that carbon sequestration of 2.4 tons per hectare per year through pond and soil system, both together. Sorry, I have to go back. Yeah, and its crop yield has shown 20% to 30% increase, and the best part is the 100% reduction in chemical pesticide. So he's not using any kind of fertilizer, pesticide, insecticide, weedicide in the farm for the last 4 years, and his yield has almost 20 to 30% increased. And this treated water, so beside treating the water, what is happening, that is very, very important to consider, is we are also bringing the groundwater level up. Because using our technology, we enable the natural flow, the vertical flow of the water, so that it becomes perennial. Earlier, the well which was there in the farmland used to get dry, and for the last 4 years, it has not gone dry even once. So that is the additional advantage of the technology. So coming to conclusion, it's a pathway to disease, pest and weather resilient agriculture, as I've already told. Important thing is that it's decentralized and low energy, because there is energy we hardly use, only for filling that tank of through the borewell where we need to mix the medicine is where the basically the electricity is used, which is maybe 100 rupees a month. And it is community driven. He is doing on himself. We don't go there. We have just shipped the medicine to him, and he is putting that in the field on his own. He has developed various kind of technology options to deliver this in the field. If you see on this slide, different technology. Now he has developed this on his own. We have not shipped any of this technology. If you are the technology people in irrigation, if you have something where we can efficiently spray the medicine all over the field, we will like to align with you. And yeah, that's it. Thank you. Thank you very much.
Thank you, Atul Mohanji. Now, do you have Mr. Shivaji Singh here? I don't find him in the hall. So that's an advantage for me. Because I was thinking, being very generous, I lose my point time. But thank you. Let me make my own presentation at the end. Yes. Just 10-15 slides. As I said in the beginning, it's carrying just a message across to the whole globe, or the what workers who are joined here from all over the world, that we have to think differently from isolated to a very broad and general inclusiveness. Before I forget, let me place on record my gratitude to the entire ICID family from all over the world for organizing this 75th anniversary and also this summit. Best compliments to all the organizers, including the President, Dr. Marco, Secretary General, Gupta sir, and all the seniors and office bearers of ICID. Best compliments for organizing this global event in New Delhi. Second, thank you very much for giving me an opportunity to share this session. Especially my special thanks to Dr. R.K. Gupta sir. Just he didn't write an email to me, he called up, said, "Sir, I am retired." I said, "I am retired from the government service." Said, "You are not retired from the water resources activity, so I am here." Thank you, sir, for that kind gesture. And let me speak few things about inclusiveness. This session overall broadly inclusiveness of water resource management for sustainable or successful irrigation development. I also have difficulty in moving this slide further. That too can move physically. Because slide preparation itself had difficulty.
It's not moving.
Can you help me from there? No, मेरे पास नहीं. You can keep moving the slides. Before I start, it may take a few minutes to set up this presentation. I thank all the previous speakers, starting with Avdesh Kumar Sinha, Dr. Man Singh. Yes. Ravi Kumar and Atul Mohanji. One more is left out, Mr. M.K. Sinha. All of them have made their very beautiful presentations. They have highlighted different fields. One is on the land degradation, the other one is participatory irrigation management, two cases, one from Maharashtra, the other one from Karnataka. Start over, sir. Yes. इसे चला सकते हैं? This one. And then bio-eco-remediation. All these are the different fields. Either it is the individuals or sectors or the subject matters which have been brought for discussion here, and we'll further elaborate on this topic on inclusiveness. These are the few points I would like to cover: water resource overall, and then components, role and responsibility, irrigation development, objectives, and what we can do for having more and more inclusiveness. we all know this. It's a very basic structure that 97.5% of the water is not available for the human consumption and other productive activities. Only very small percentage, 0.4% surface water in lakes, rivers and atmosphere soil moisture is available for productive purposes. Just to remember how we have a mindset that there is enough water in the world, but the utilizable water is very, very small in terms of our demands. And this is a threat the world will be facing in the next few years. There is no time for complacency. As per the World Resource Institute, you can see the extent of water being exploited as against the supplies. Here, you can see the dangerous spots, including India and the so-called superpower America and China. All these will have to face dance in terms of water crisis. Therefore, it's time for us to have more and more sustainable approaches, more and more inclusive approaches for water management. Otherwise, it's not time to remain forgotten and complacent. We have to be alert and sensitized for very aggressive reforms in water resource management. This is the gap. You can see the supply is declining. Water supply. There is a general impression that water supply has been constant over centuries and decades. But friends, remember, due to climate change impacts, and also the so-called water pollution, the net water supply is reducing by the decades. It's not constant. We say the water supply has been constant, but it is going to reduce in terms of utilizable water quantity. Whereas all of us know the demand has been increasing constantly with a multi-sectoral demand. And at certain point, it will cross over, demand will take over supply, and after that we'll have deficit. After the, maybe in 2024 we are at the breakthrough, and here onwards we'll be running into deficit. This is again an eye-opener for all of us who are working in the water resource sector. So here my point would be to highlight that historically, water resource management has been taken, in a fragmented way. It has not been inclusive. This is my belief, my experience for the last 3 decades in water resource management. Traditional management, sectoral approach to water resource management have led to unsustainable use and poor service. Whatever the fallouts, negative impacts we are seeing today, it is because of this approach, non-inclusive approach. Either there is a pollution, or there is a wastage, or there is a unscientific management, etc., whatever the complaints we see, it is because of a non-holistic approach that needs to be corrected at this historical juncture. There have been imbalances or disconnects in water management. There are several sectors, as we said, government, service providers, end users, academia, regional and sectoral gaps, etc. This one portion, part of it, part of the stakeholders. There we have a lot of disconnect. Quite often, as I said, there is one single farmer here. We need to have more and more farmers in water resource management, even at the state level also, even at the department level also, even at the institution level also. Then there is a social inequality, historic, these also we know. We just learned from Maharashtra experience, they have made reservation for women representation in their water resource society. That's really a very positive step. Like this, you take water resource management. It's quite the men who come forward. Whether it's a training program, I have been director of Water and Land Management Institute for 6 years in Government of Karnataka. We call the people farmers for training. 99%, either there could be a woman or no. 100%, they all come forward. But actually, the irrigation work is, in a burden lies on a woman. This is a travesty of things. The actual work who carries out at the field level is women, but when it comes to receiving awards or attending a training program or recognition, it's a man who come forward. This imbalance needs to be rectified. And there are many marginalized sections, the Adivasis, who are equally important stakeholders in water resource management, but we have neglected them so far. If there are corrections here and there, they are welcome. As climate change alters the hydrological cycle and the world's population grows, multi-sectoral demand is increasing. It is becoming even more important to sustainably and equitably manage our precious fresh water resources. Earlier, it was business as usual. This sudden change, a paradigm shift in the entire water resource scenario due to climate change, it's a time for us to change. Therefore, and also the population growth and demand from the various sectors. Now we are facing big challenge in water resource management. Therefore, this mid-term course correction is required. Therefore, inclusive water resource management encompasses a wide range of individuals and groups. It could be individuals, it could be social groups, or government departments who are affected by or can influence water-related decisions, and it's a dynamics. They are the people who influence others, and they're also being influenced by the water sector and other players in the whole dynamics. Therefore, that's why the word inclusiveness gains importance. Their perspectives, expectations, and challenges have to be addressed for a successful water resource management, including irrigation. Water resources is a big component. There are non-irrigation sectors also. We often equate irrigation with agricultural water management. That's not the case. Therefore, water resource overall sector, then agricultural water management, and then irrigation a part of it. You can see how overall look on this. First, there is government agencies who are the state is all powerful. Then there are water utilities, farmers who are the actual end users in terms of irrigation. But quite often we don't include them in policy making or in execution or in management or in whatever form. It's there symbolically, but I would request the global audience and the policy makers that we have to have more and more role and participation of the farmers. And they are the people who are the food producers. And the entire concept of irrigation is meant for this purpose of food production. And who are the food producers? It is the farmers. But we don't often hear their voices. We don't involve them in and I have had very bad experiences. Don't mistake me. In some of the governments, when we took proactive role in involving farmers and women, I was often restrained. And then industries, also they have their quite large sums of water consumed by industries. Environmental organizations. No, until about 3 decades ago, there was not such a controversial issue like environmentalism and environmental movement, etc., etc. With the growing constraint and more pressure on natural resources, environmentalism has naturally come up. And they also, there's always tussle between irrigation development activities and the environmentalist. It's where we strike a balance is very important. We cannot take the extreme stand. Somewhere, we have to have a eco-development concept where development takes place without harming much of the environment. Quite often, environmentalists say object to irrigation projects. On the other hand, the irrigation bureaucrats, irrigation technocrats, they don't try to listen to them or they don't care for the environmental activists. So this has to be done away with that. We have to work together in an inclusive manner. Then local communities. Other than farmers, there are several communities who have great stake in water management. Then NGOs, also part of the civil society. Then water resource association, of course, they are nothing but the farmer sector. Water resource association, water resource cooperative societies. In Karnataka, they are called societies. And then we have academia, institutions and research. I come from academics. I have been professor of agriculture economics specialized in water resource management. I have faced this problem personally. I don't know much about the European countries, and in America, to a great extent, the academia are involved in water resource management. But here in India, and there's a disconnect between academia and the executive department. There's a disconnect. The university professors, they don't want to involve with the activities of the water resource department, and water resource engineers, they don't want to listen to academicians. They have their own individual perspectives. This has to be, brought together. I often used to tell my bosses in Karnataka, sir, please send all our engineers to universities for some days. Let them go and sit in library and be happy with the academicians. They will learn something. And this is a big academic organizations today, what we are seeing. We exchange so many ideas. Otherwise, execution, what happens, we get confined to DPRs, execution, and bills, and again the cycle repeats. There are many, I salute engineers, they are very brilliant people. But they should also be exposed to academia, the new innovations, technologies. Like I requested my bosses in Karnataka, please send them to ICID conferences, the India Water Week, World Water Week. Of course, we had some difficulties, but these are the things where the exchanges happen. They learn from each other. This inclusion has to be there. Then, of course, individual as the citizens, we also have great stake in water management. And all these people have to be involved on equal footing. Quite often, when we generally talk of irrigation development, it is a civil engineer who comes into the picture. Civil engineer. But civil engineer role stops where the civil engineering work has been completed. Next part is the agriculture engineering. And then next is agriculture scientist. And then is a farmer himself. This chain or the continuum has no importance for in water resource management in the whole world and especially in India. The component has to be given equal importance. Then only the irrigation management will be very holistic and sustainable. I am speaking from my own experience, some of them in water resource management. Then these I already have explained, the government agencies, water utilities, farmers, industries, then environmental organizations, local communities, NGOs, water resource association. To talk about academics now, they have come out with a wonderful research paper, but it never gets translated into executive mechanism. And our engineers have great experience in the field. The professors or the academia researchers don't take it into consideration. They have to interact with each other, they learn from each other, then we can solve many of the problems. Otherwise, we are divided and there is a gap. This interface has to be developed very strongly. And apart from the individuals or sectors, we have different departments also, different sectors, health, agriculture, fisheries, though they look so different from each other, each sector is connected to water resource management. This should make it very clear. Health, agriculture, fisheries, drought management, and sometimes say agriculture engineers, agriculture scientists, they don't want to talk to engineers, and the civil engineers don't want to talk to agriculture scientists. This gap has to be bridged. As Director Valmi, I often made 3 important points. I used to bring them on stage, the civil engineer, agriculture scientist, and farmer, and felicitate them, symbolically to show that all 3 of you have to work together. And we have many photographs, I have not brought it here. Then energy production, urban and suburban drainage, industrial and domestic water supply. These are the various sectors where the stakes are very high. Then these are the roles and responsibilities. In each of the sector, you have the data and information, financing, regulatory framework, innovative governance, integrated transparency, stakeholder engagement, monitoring and evaluation. All these are various roles. And when we don't bring the stakeholders together, we don't understand their roles and responsibilities. They are hidden. They are kept away from our view, and we will not be able to connect them in a kind of interface. So only when we come together, these roles can be coordinated in a coherent manner. Each role player can understand his role and how I am related to or connected to other sector. This has been a very serious lacuna on the part of water resource managers, technocrats, bureaucrats, whoever is the helm of affairs. This has to be rectified globally and nationally. And as all of you know, of the total water consumption, majority, 75, 76, 80, or whatever it is, depending on the country, topography, weather conditions, around 80% of the water is being consumed in agriculture, about 11% in industrial sector, and municipal sector 9%. Why I am saying this is, the farmer's role is very important. We have to focus more on farmers. Without farmer, we cannot talk of irrigation. As civil engineer, you have built the dam, but please remember, there is a climatologist, there is a hydrologist, geohydrologist, geomorphologist, and then the civil engineer who builds the civil structure of the irrigation. Then the water flows, and then there is the agriculture scientist. As Dr. Mansingh rightly pointed out, this issue of land degradation is a very, very, very serious issue. I have been traveling several countries, India and in my own state. You know, one very serious critical statement made by farmers is, Dr. Marco, this question is being asked, is irrigation bane or boon? For no fault of mine, you have killed my land, killed my soil, you have spoiled my soil health. I have not done anything. So this externality is a very challenging. Therefore, the agricultural water management, very important. Then again, irrigation, and this also the negative fallouts of irrigation management. Then irrigation development, we have as generally globally we have accepted the economic efficiency, profitability, and then environmental component is also equally important. We cannot neglect. We cannot say that we are superior. Irrigation development or forward movement is more important than your environmental conservation. They are equally important. See, just because we have irrigation because there is a dam. There is a dam because there is a water flowing into our dams. And there is water flowing into dam because there is a rain. There is a rain because there are forests. All this is interlinked. We can't say that, no, we just look after the dams. We have to respect the environmentalists also. Though it may be painful and difficult in development process, we have to respect the views and concerns of the environmental workers also. And I would, in a simple, my own humble way, submit to the House that IWR is one such concept. Of course, it has many views, there are different views about this. Integrated water resource management is latest innovative approach, which I feel it has at the academic level, which needs to be brought down to the field level. For example, in Krishna, we have several basin issues, Krishna or Kaveri or Godavari. This IWRM or river basin concept, if it is brought at the operational level, various stakeholders can be involved, going beyond the political boundaries or physical boundaries. Krishna is one, Kaveri is one, this concept. Then the second one is participatory irrigation management, which has been highlighted by Engineer Govardhane and the live example from Mr. Ravi Kumar. Participatory irrigation management is a recommendation of the ICID. And also it is included in the water resource policy of Government of India as well as state governments. But more of it is on the news, on the papers. But I'm very happy to share with lot of efforts of Valmi Dharwad, we have been able to take it down to the farmers. Today, most of the water resource societies in Karnataka have been revived, vitalized and rejuvenated. Then the middle level, district level federations have been revived. Then the state level apex body has been revived, and thanks to Government of Karnataka, they have been very supportive. I feel very confidently with my experience 6 years in Valmi that we have been trying to make it very vital, very lively component in water resource management in Karnataka. Though all of us to talk, this has been there in the public discussion for the last 3 decades, but my personal feeling, you cannot have irrigation without farmers. There are 2 issues which sometimes look contradictory to each other. One is technology, the other one is community or people. Very sorry to say that the very top level bureaucrats say that PIM is dead. I don't know how many of you will agree with this. No, don't talk of PIM, it's no more, it's a dead. Can we subscribe to such views? PIM is nothing but involvement of farmers. As long as we don't involve farmers, there is no irrigation. No irrigation, no food production, enhanced additional food production. That's why this language, this narrative has to be changed. See, I've heard people in Delhi speaking, no, PIM is dead, don't talk of it. Then what else you want? Can we do irrigation without involvement of the farmers, one of the major component of the stakeholders? So we need everybody. We need civil engineer, we need a drainage engineer, as Dr. Mansingh said. We need farmers, we need cooperators. Dr. Nagesh Jongri from Karnataka, he's a cooperation man. He brings people together. He develops organizations, water resource societies, which is given a lot of importance in Government of Karnataka. Then multi-sectoral convergence within the government. Most of the departments in government, whether it is underground water or groundwater department or RDPR, any other department, there is no department which is not connected with water. Every department, animal husbandry, agriculture, they are connected, but there is a silo. No, I cannot, I don't want to talk to groundwater people. How can this happen? And fortunately, ICID has brought this issue for discussion. Each one of us should search our soul and think what has gone wrong. With the same state government, in the same state government, there are 18 departments, and when it comes to water, it is related to every department, and they don't want to talk to each other. No, it's concern of the RDPR, where it's concern of agriculture department, but water is one. Water connects the whole world, and departments are not ready to accept this fact. Therefore, this has to be If they don't psychologically accept, this has to be enforced through legislation. This is my submission to the House. This has some mechanism, has to develop. Though there are some convergence activities, but it's not happening. For example, there is a farm pond, or Krishi Bhagya, it's called Krishi Bhagya, or farm pond, you can understand, rainwater harvesting. The very basic principle of rain-fed agriculture policy of Government of Karnataka says all the departments need to converge in this. But with my own field experience, I did a research on this. One department doesn't want to talk to other. Livestock people say, no, we are not concerned. But the animals drink water, no? They don't want to talk to the agriculture people or farmers. Then prioritization of social inclusion is in water distribution. Social, we have different layers, whether it's America or India, several, there are Adivasis, the people at the margin, then handicapped people, or these people in the slum. Quite often we have a water workshop. We never call women from the slum. The Government of India runs Jal Shakti Abhiyans. This is my experience. And when they gave me 1 or 2 assignments, we included everybody. And we defended that the tribal should also be included in this program. No, tribals are self-sufficient in their own ways. No, they have very serious problem. Then a woman in the slum area, see her position. It's very precarious. Unless until we involve her, and we people who drink this, bottled water, we don't have any heart burning, but she has. And you know water crisis, how about 7 to 8 kilometers the girl child has to walk to fetch a pot of water to complete her day. So these are the various social groups, and even poor people also. We can afford to drink this bottled water. But what about those whose income is very marginal out of day's earning? So we have to, it's just not the intergovernmental, interdepartmental convergence. It's not interstate collaboration, intergovernmental, intercountry government. The entire globe, there's one commodity in the world which has no divisions. It has no north, no south, no male or female, no color or no higher or economic hierarchy. It is water. So when such is the commodity with which we are dealing, I feel and appeal to all of you that we have to bring in the concept of inclusion as involving everybody in water resource management. And here, as I already mentioned, if we try to influence them, try to train them, but if they don't yield, then it has to be brought statutorily as part of the government programs. You have to ensure. We have been trying to achieve things through statutory enforcements. If psychology doesn't work, you have to use rules and regulations until people get used to it. Then calls for capacity building. When we talk of intergovernmental, interdepartmental, intersectoral, often there is a mindset. This mindset can be broken. As coming from the capacity building institution, I feel this capacity building involves change in your knowledge, change in your skills, and the third and the most important, change in your attitude. We have this attitude, and that attitude can be broken only by capacity building as part of the attitudinal change. Yes, I can accommodate him, I can accommodate her, I can accommodate that department. So then see the beauty of working the sustainable water resource management. Then ICID, IWM or CGR institutions, they do have a role in bringing this inclusionist concept in all of our approach, even including the World Bank also. We have to have policy papers, research papers, and documents, and then arguments and dialogues, and even discussion in such. And I am really compliment ICID and President and Secretary General for including this very crucial. See, friends, we have achieved everything. There is enough water, there is rain, and then there are dams, so many dams, Dr. Mansingh was telling, and in the whole world, in America also. But until we have this psychological or the social engineering to include everybody, the end result will not be good. All of us aim for very sustainable and equitable and efficient water management. This will not come on its own without inclusiveness. We have to include everybody. Then ICID, IWM, universities, they have to come forward. University people should come and sit here. Even in training programs like Walmis, they should go and sit there. They will learn from the engineer's perspective and farmer's perspective. Then above all, I feel, having worked with the government, political and bureaucratic will to achieve inclusion in water resource management is a must. Let me be very honest and candid in, we lack political will and bureaucratic will. If the politician agrees, by and large they agree for any of our opinions and suggestions, but it's very hard to convince a bureaucrat. He says he knows everything. He says no means no. This inclusiveness has to be inculcated as a culture in the political class and also bureaucrats. As I said, politicians sometimes may agree, yes, आप जो कह रहे हैं, whatever you are saying is very nice and let us do it, do something. He will give some, positive feedback or some inclination, but very difficult to convince the bureaucrats. This mindset has to be changed. It's a very hard psychological issue, but there is no we cannot escape from this. And then I conclude with the statement from father of this nation. Earth provides enough to satisfy every man's needs, but not every man's creeds. So all of us remember this. There is a water enough for each one of us, but not for greed. But that is unfortunately is happening. This can be a lesson message for all of us that, as I said, 0.4%, and it is very less compared to demand. But this becomes very less, or one man becomes greedy. There's enough water, all of us can share, including all the sectors, all the men and women on the earth, including the animals and birds. That is sarve jano sukhino bhavantu. Everybody can be happy. And this is the cream of the cream, the global body ICID. It has great role and it can send message to governments of the country committees as well as state governments. We can achieve efficient, sustainable and very successful irrigation development through inclusive water resource management. Once again, I thank the President, the Secretary General, and all of you, and also ICID bodies, various committees, for giving me an opportunity to come out to stage and speak about this subject and also chair the session. Thank you very much. M.K. Sinha ji here. Please, sir. That will be last concluding part.
Very good afternoon. Well, friends, the topic is very political sensitive. I think those who are aware about Telangana and Andhra Pradesh would know about it. But I would take the subject as a river basin manager perspective, and I will take you along with that perspective. I think this problem remains. Yeah, it remains. Yeah, this there. Well, friend, I mean, those who are from India and who are pursuing the Indian political situation would be aware that recently, not recently, about 10 years ago, the Telangana state was formed and the central issue was water. In fact, we have been listening that water will be the cause for the Third World War, and it has happened in India. The public resentment rose to that level that finally the state was carved out. And the main central theme was water only. And if you really look at the topography of the Telangana state, it's not something which is unusual. It has got two major rivers on the top, the Godavari, and the bottom, the Krishna. Both are very large perennial rivers. But the central region was very high. The level was about 600 meters or so. Naturally, the water cannot flow by the conventional irrigation technology of gravity flow. The people of Telangana region can't take it like that because water is for life and livelihood. So they felt that not providing water is a neglect to them. And so the public revolt was there and the state was formed. But primary reason was the topography, which is very clear from the topographic map of the Telangana. Well, we all know the irrigation technology has been stagnant for almost about 2 centuries. We all know the technology is driven by economics. And because irrigation doesn't have the economy, the technology has remained stagnant. We have the lift irrigation technology at a very small level, but with the development of pumps technology, which is a mechanical engineering, not exactly agriculture or civil engineering, but the development in pump gave an idea that yes, this can be put to modernize or re-engineering our irrigation projects. Conventionally, the water was providing through canal, branch canals, distributaries, and finally the field channels. But with this, the development in the lift irrigation broke the barriers of gravity, as I've told. The irrigation was being provided based on the gravity flow. So this lift irrigation broke the barriers, and that gave the hope that water could be provided to higher elevation, and this called for re-engineering in the entire public revolution which has taken place. The next, all of you must be hearing in the news, Kaliswaram project. It is very much in the news. It was initially proposed, some dam with Tumiditi was proposed near Parnita and this at the merger of it. But there were challenges because at that point water availability was not, because Telangana region was allocated as per Godavari Water Dispute Tribunal 160 TMC, and that much water could not be taken up. Plus there were issue of submergence in Maharashtra, which Maharashtra government did not agree. So as a result, the government, Telangana government, took up the everything, put it down the barrage level, they made it below, and used the river channel. This is very innovative, using the river channel itself as a storage. Normally we build the storage, we require the land acquisition and other thing. So they did use the river channel itself, build the series of the barrages, and pumping from that, the next slide will show you the complications. The complete network was drawn, and finally the water was provided not only to something like 20 million hectares, but also the drinking water need of mega cities like Hyderabad. So the re-engineering was done, shifting of location of the barrage, as I've said, because of the water availability and submergence issues. And 3 barrages on the main river Godavari, Medigada, Annaram, Sandilia to utilize in-stream channel storage and major pump storage, Lakshmi, Saraswati, Parvati, Nandi, Gayatri to lift water, and all these are based on the goddess names are there because they are the symbols of the power, and these are major pumps there, as high as 135 megawatt pumps were there, and to lift water and to construct an to create storage. This complete network was developed as a process of re-engineering of the irrigation earlier project. Another was also is a fallout of bifurcation of the state. The earlier the project has a takeoff from this point, but when the bifurcation took place, the headwork shifted to Andhra Pradesh and the command area remained in Telangana. That has really created a very difficult situation. So Telangana has to re-engineer the project, shift the lifting point upstream in its region, then clubbed it with the 3 lifting points also, so that finally they augment the supply and finally take water to the region which was hitherto not having being the tail region not having water. So re-engineering was done to lift water from Domagudam Manigam by providing 3 lifts, one at a starting point, then at confluence point, and third at the proposed Mukhamadi. And due to redesign, a new ICID of 16,000 and 1.68 lakhs hectare was added, and stabilization of around 1.5 lakh hectare for Vaira, Laksasraf, Nagas left canal was irrigated. So the re-engineering brought not only more water, but also covered the leftover areas also. This is another part of PV Narasimha Rao Kantapalli Sujala Sub project. There the earlier proposal was there. Now all these re-engineering could not have been thought of because there was no lift irrigation. Now but with the technology of pumps and having the high capacity pumps, they gave the scope that we could re-engineer, and so this project also was done. The lifting of the location was shifted. The earlier submergence was 11,000, which reduced to only 163 acres. The forest land, 250 acres, reduced to 95, and R&R load was reduced. So the re-engineering was for the better project management, as I've said, it's more from the river basin management perspective. So this was done, and this facilitated stabilization of about 3 lakh hectare of command area under Sri Ram Sagar project in Warangal, Nalgonda and Khammam districts, besides facilitating lifting of water from Devdula for 170 days. Well, in summary, I have just cut, because of the time shortage, I have not taken all the 10 projects which the re-engineering has been done in Telangana. Only 3 representative projects have done it. The summary is that lift irrigation broke the barriers of topography and made available water to highland areas, which resulted into tremendous growth. The total area under paddy and cotton increased from 45 and 43 lakh acres to 97 and 46 lakh acres respectively from the year. Production under paddy and cotton increased from 25 and 18 lakh tons to 202 and 25 lakh tons respectively. 2014, the Telangana state formed, so re-engineering was done 1 year later, 2015 to 2021 to 22. The Telangana gross state domestic product GDP at current prices is 13.27 lakh, a growth of 15.6% over the 2021-22 value, as against the country's GDP growth rate of 15.4%. So a backward region, and I mean almost like a dry land state has risen so much that they surpassed even the national growth average also. And even in terms of per capita income, which is a measure of the economic benefit, the Telangana outperformed India at 3.17 lakh, which is 1.46 lakh higher than the national per capita income. So if we manage the water resources in the basin well, by using the available technology, may not be in the civil engineering, but from the pump technology and other side, we can grow the state in a very much better way, and that is what the Telangana case history presents it. Coming to the cost incurred, because re-engineering doesn't come, as I've said, nothing comes free. So the project name is there, the Parnita Chavela remodeled is Kaleswaram, required 92,000 crore, and around pumping is 8,400 megawatt. Indaramma flood flow canal 6,500. Total about 1,15,000 crore rupees was needed to be invested in all re-engineering projects, and which required around 9,764 megawatt of pumping. It's a huge cost involved. And here the main conclusion is there, which is very important, and I have been pursuing with the state government, that we should take care. Of course, the technology does provide the solution, but we have to be careful about the use and adoption of the technology. The irrigation engineering remained stagnant because there was no economic return. Lift irrigation and re-engineering of irrigation projects have brought tremendous progress in the field of irrigation, and consequently to the Telangana state. In fact, all states can and all countries can benefit from the development in water resources. But the enormous cost associated with it should not be lost sight of. In fact, Comptroller and Auditor General for India has already warned that it will bleed, these re-engineering of projects would bleed the state government, so we have to be careful about the management of the project. And that is my main purpose of having this paper on that re-engineering and lift irrigation has to be clubbed with the proper management of the project at the water resources management at the state level. And that's why the recommendation is that the state government should work concurrently on water efficient irrigation, incorporating pipe distribution network with macro irrigation techniques, so that economic returns are obtained on this costly water. The water is very costly because it is to pumped. So we have to take the maximum benefit of it. The people and the state should realize that there is no free lunch, and in order to sustain availability of power and or water irrigation, water must be utilized judiciously with high degree of efficiency. Water spread can also be utilized for floating solar panels, because these re-engineering involved a huge pumping. So some of this pumping energy could be compensated by having a floating solar panel with the reservoir generated, because the pressurized pipe distribution system coupled with macro irrigation techniques are inevitable to sustain these lafts. These are the basic things. Of course, these are, as Kaleswaram is called, lifting of the river. It's a major project I have just presented, but with a word of caution to the state government and the people that we should do it coupling with the water efficient irrigation management system in the basin. Thank you.
Thank you very much, sir. Thank you everybody for your patient hearing. And the session is concluded. Back to organizers.
Thank you.
Thank you.
We thank all our esteemed speakers for this session. We also thank our session chair, Dr. Podar. If I may request you to kindly stay on the stage for a few more minutes. We would like to present mementos to all our esteemed speakers, and I would request Dr. Rajendra Podar to kindly do the honors. I request Mr. Avdesh Kumar Sinha to receive the memento. I also request Mr. Rajesh Govardhane to line up, please. Mr. Rajesh Govardhane. I request Mr. Ravi Kumar to kindly come forward. Mr. Ravi Kumar also has a special felicitation for President ICID and Secretary General ICID. So may I request President and Secretary General to kindly come on the stage as well.
On behalf of this farmer, I request President Marco and Secretary General Gupta sir to kindly come out to stage. They want to honor them on this auspicious 75th anniversary of ICID.
May I request the Secretary General and President to kindly be there on the dais, because I request now Mr. Atul Mohan to kindly receive the honor. Mr. Atul Mohan. And I would request Mr. Dr. M.K. Sinha to kindly come forward, please. Now I request President Marco to kindly present a memento to our Honorable Session Chair, Dr. Podar. Yes. May I request Mr. Man Singh to come forward, please? Dr. Man Singh. Yes. Thank you. My apology for missing your name out. Now I request President Marco to kindly present memento to our session chair, Dr. Rajendra Prodar. Thank you, Session Chair. And I request President to kindly be on the dais, and I request Secretary General also to join us on the dais. Ladies and gentlemen, we would also like to felicitate our esteemed sponsor, Rubicon, and I request Mr. Kaushik to kindly receive the honors. Supporters. I request, we would like to felicitate our supporter, Rubicon. And I request Mr. Kaushik from Rubicon to kindly receive the felicitation. And we request all our supporters to kindly stay with us. We would be felicitating all of you after this technical session. They have to leave. Mr. Pandya. Somebody just came and said. Who? He's from Rubicon. Okay.
Representative.
May I also request the representative from Water Resources Department, Uttarakhand, Gujarat, to kindly. We would like to felicitate them as well. So may I request the representative to please grace the dais. Water Resources Department, Government of Gujarat. So this is another one. Thank you, President. Thank you, Secretary General. Ladies and gentlemen, we'll break for tea now. May I request all of you to gather back at 4:30. And we will begin with our concluding session, the technical session number 4. So please enjoy the tea break and see you all back at 4:30.
Ahora yo creo que hemos entrado ya.
José, ¿me puede escuchar?
¿Qué? Sí.
Ok, perfecto. Cristina. Hola, buenas tardes. ¿Me puede ver también? Sí.
Sí, te vemos, te escuchamos.
Ok, perfecto. Muchas gracias por estar con nosotros aquí en esta importante ceremonia, 75 años de la ICID, de la ICID. Es un placer, es un honor para nosotros de haber con nosotros. Entonces voy a preguntar a José o a Cristina, creo que Cristina, para anunciar el nuevo Comité Español del Riego y Drenaje de España. Muchas gracias. Cristina, si puede hablar o quieres hablar primero, no sé.
Yes, good afternoon, ladies and gentlemen, attending the Indo-Global Irrigation Summit 2025. My name is Cristina Clemente, Deputy Director for Irrigations at the Ministry of Agriculture, Fisheries and Food of Spain. I'm glad to be with you for the first time, even if only virtually. First of all, I would like to thank Dr. Marco Artieri, President of the International Commission on Irrigation and Drainage, for inviting me at this conference. As you know, Spain is one of the countries in the world with the largest area of irrigated land. Spain, with 3.73 million hectares of irrigated land, is one of the leaders in precision irrigation or micro-irrigation. We have 72% of the irrigated area modernized. Today, irrigated agriculture is an important pillar of Spain's agri-food sector, which is key for the Spanish economy. As I mentioned, irrigated agriculture covers 3.73 million hectares. It represents 22.3% of the 17.7 million hectares of cultivated land in Spain. However, it generates 71% of the total value of national crop production. Irrigation is fundamental of our agriculture, increases agricultural productivity 6 times, raises farmers' incomes 4 times, and creates 3 times more employment. Beyond economic figures, irrigation plays an essential role against rural depopulation. It helps to retain people in rural areas and improving their quality of life. The Spanish government is absolutely committed to modernizing water management in agriculture to ensure the optimal and efficient use of every drop of water. For this reason, it is making a significant investment with the economic participation for the irrigation community as well. At present, we are making an intensive modernization process using funds from the national budgets and also from the European Union, particularly from the European Union Recovery Instrument Fund established after the COVID-19 crisis. Between 2021 and 2026, more than 2.5 billion euros will be invested in irrigation transformation and modernization. These investments are aimed at reducing water and energy consumption in the Spanish irrigation communities. All of these projects fulfill strict European Union environmental standards. The Spanish government has priorities to choose the projects, like generate greater water savings or improved energy efficiency, replacing surface and or groundwater with non-conventional water sources such as reclaimed or desalinated water, not needing electrical energy to operate or make use of renewable energy sources, and employ new technologies and innovations to achieve more efficient irrigation. Because of the importance of irrigated agriculture in Spain in these moments, we are net contributors to the ICID. And I'm pleased to announce that we will approve soon the regulations of the Spanish ICID committee. This committee will be multidisciplinary with a great variety of members from all stakeholders of the Spanish irrigation system, and it will be led by the Ministry of Agriculture, Fisheries and Food. Spain fully shares ICID's vision and mission. We have the skills and professional needed to participate efficiently in all ICID activities. Today marks the beginning of a new journey, and we hope to contribute in order to achieve the organization's goal. Thank you very much.
Ladies and gentlemen, thank you so much, Ms. Cristina Clement Martinez. She had joined us through the video conference. She is DG Irrigation Department, Ministry of Agriculture, and she joined us from Spain. Thank you so much, Ms. Cristina, for joining us today. Thank you for giving your time.
So I will just, yes. Thank you very much, Dr. Cristina. You know you have a very, very busy and tight agenda, so we really appreciate, I'm talking on behalf of ICID, we have former President, Vice President, Secretary General. We are very, very grateful for you making some time for us, because we all know that Spain is one of the most important countries in the world for irrigation, not only for irrigation, but also for the use of alternative water resources, such as reuse and especially desalination. So we are really looking for, we are very grateful that the efforts that you, Immaculada, my friend Jose, have been doing in these past 2 years to really rejuvenate the National Committee of Spain, because Spain also has had a long tradition, always in ICID. We were all remembering the wonderful Congress that Spain hosted in Granada. So some years ago, everyone was is waiting and eager to come again to Spain and bring tourism and bring activities. And of course, we are looking forward to your support to ICID in terms of exchanging knowledge, because I am sure, I can surely affirm that Spain, not only because of the irrigated area, is country #1 in Europe and in the Mediterranean area, but also because, as you were saying, of the advanced level of skill, of management, of governance that your country has been bringing out and producing in the past 20 years. So we are very, very happy about your presence here. We thank you very much. And we are looking forward to foster collaboration and initiatives. Also, just one last thing, also Spain has a huge, impressive quantity and variety of historical heritage irrigation sites. So we are also looking forward to receiving contribution on that side. Once again, on behalf of the people who gathered here, of ICID, thank you very much for your presence and your collaboration. Thank you.
Thank you, Christina, once again, and thank you, President, once again. And can we also take this opportunity to present a memento to Water Resources Department, Government of Telangana. May I request the representative to kindly come forward, and I would request President ICID to present them with a memento. And can I also request Secretary General? ICID. For Government of Telangana.
Just maybe Secretary General wants to say a few words as well.
Yes. We want to felicitate the Government of Telangana representative for their continuous support to us. Thank you, Secretary General. Thank you, President. Legion, we will now move on to our final technical session of the day, focusing on climate-smart irrigation and agriculture practices, an area that is rapidly reshaping the future of farming. As climate change challenges traditional methods, this session will spotlight adaptive, data-driven and resilient approaches that help safeguard both productivity and sustainability. Please join me in welcoming on the dais as our session chair, Mr. Takeshi Ueda, the Director, Agriculture, Food, Nature and Rural Development, ADB, Asian Development Bank. And also joining us as the session co-chair is Ms. Alexa Michaels, Senior Water Resources Specialist, Agriculture, Food, Nature and Rural Development, ADB. Now I would request our session chair to kindly take the session forward, and I would request him for his opening remarks as well. Thank you.
Thank you very much. Good afternoon. First, I want to appreciate my I want to express my gratitude to President Dr. Marco Cherry and the Secretary General, Dr. Gupta, and also Vice Presidents, and also dignitaries and ladies and gentlemen. This is Takeshi Ueda, Director of Agriculture, Food, Nature, and the Rural Development Sector. I'm responsible for South Asia. I want to congratulate this 75th anniversary of ICID, and I believe so much effort was made to, have this great gathering, and I'm so honored that we are giving time to showcase and introduce the lessons that we learned through ADB projects in India. And I'm also pleased to welcome all the champions who led ADB projects in India, and many of them are here. ADB, we do investment in agriculture, natural resource, and rural development sector every year at the level of about 3.5 billion. That's a lot. And we are getting towards like a level of 5 billion per year. And 70% or over are actually water resource related. So you can see how water is important for ADB as well as our member countries. And last week, we had an opportunity to co-organize with MOJS and also the World Bank a workshop on creating framework for modernization of command area development and water management. What I pleased most at the workshop was I saw secretaries of Jal Shakti and Secretary of Ministry of Agriculture and Farmers Welfare. They sit together and hand in hand discussing importance of water for agriculture. At the same time, agriculture, water is for. So, this very good collaboration I see in India, and I'm seeing your presentation. We are really looking forward different way of irrigating, and we learned a lot about new technologies, new way of doing, and lots of digitals. So we are very happy to share our accumulated experiences in this session. And lastly, I just want to thank again for your invitation and working closely with us. So thank you.
Okay, thank you, Takeshi, and good evening, good afternoon, everyone. This is the last session, so I hope you are still awake and energized for this, this last session after 2 days of incredible workshop, very important, where very important topics were presented. And so I am Alexia Michels. I am Senior Water Resources Specialist for the Agriculture, Food, Nature and Rural Development here in India. ADB has been a key development partner for the country in India in the water sector, but also in the agriculture, and supporting both either infrastructure investment and policy reforms with a focus on climate adaptation, sustainability and inclusiveness, but also agricultures and farmer community in on-farm initiatives. So some of our main initiatives in the AFNR, Agriculture, Food, Nature and Rural Development sector, include climate smart irrigation and agriculture programs in Madhya Pradesh and Karnataka. They will be presented in today's session. We have also projects in integrated flood and erosion management in Assam and Tamil Nadu. Again, Tamil Nadu will be also part of the focus in today's session. We have also integrated water resources, high-value agriculture and horticulture development, river basin planning and modernization, for example, in the Brahmaputra, Krishna, and Cauvery basins, and water use efficiency and digital solutions in surface and groundwater systems. So without further ado, I will list the presenters who will come on stage and present their project that were supported by ADB in India. So first presentation will be by Mr. Rajesh Aminabavi from KNNL Government of Karnataka cannot come, so it will be this presentation will be done by Mr. Doraiswamy, who is team leader for the Karnataka Integrated Water Resources and Improvement, Water Resources Improvement and Management Program. I'll go through all the list of the presentation and I'll give you the floor. So second presentation will be on improving water use efficiency and water productivity in the Kundalia irrigation project in Madhya Pradesh, another of a very important ADB project, ADB supported project, and we will have the pleasure to have Mr. Vikash Rajoria and Mr. Shubhankar Viswas from Madhya Pradesh who will be presenting. And then third presentation will be on climate resilient integrated irrigation and horticulture development under the HP Shiva project by Mr. Rajeshwar Parmar, Project Director, Department of Horticulture, And finally, implementation of a decision support system in the Venar Sub-Basin Cauvery Delta project in Tamil Nadu by Mr. Tayala Kumar, Project Director and Chief Engineer WRD, and Srinivas Rao, DSS Expert in Canaries Limited. So, Mr. Doraiswamy, the floor is yours to present the Karnataka project. Thank you very much.
Thank you, Dr. Alexia. Thank you, ICID, and thank you, Asian Development Bank, for providing this opportunity for me to share. This experience, what I'm going to share, is straight from the field. That's the lab. And we will be talking about the modernization project in two ancient irrigation projects. One is about more than a century. The other one is 600 to 1,000-year-old irrigation projects, which is called Vijayanagar irrigation projects. So this, I'll be sharing experiences because this subject, if you see, it's a very vast subject. And since yesterday, eminent speakers spoke about the essentiality of this inclusive approach, that farmers' participation. I came to this farmers' participatory irrigation management as a researcher some 3 decades ago, when Andhra Pradesh came with the Big Bang approach. So then on, we saw how the graph moved up and down, up and down. And this particular project, Karnataka Integrated Sustainable Water Resources Investment, Modernization Investment Project, with the financial assistance from Asian Development Bank, came as an energizer for most of us who are almost in a exit stage of this PIM thing. And one more point which I always tell my team members is that whatever we are trying to do now is nothing but working on the formal participation of farmers. Because any irrigation project, if you take, whatever the water use efficiency we are talking about, This we could achieve because there is a farmer's participation. If you see the staff of any irrigation department, it's very, very minimal. And without farmers' participation, it's simply, we couldn't achieve this. And one positive thing which I should highlight here, otherwise I'll be blaming, I will be failing in my duty. This modernization project came with a lot of inputs. And one of the thing is that the project support consulting team, that is the experts from multidisciplinary thing, was made as an integral part of this modernization project. Secondly, before the launch of this project, there was this technical assistance report which looked into each and every aspect of this projects and the multi-dimensions of that and what needs to be done. And there was a kind of a wide range of support materials given to us. So that helped really in terms of the methodology, manuals, and then how to comply with the statutory compliances and all that. So because I said, well, been in this field for quite some time, worked in South India. I even started one farmers organization called Jalaspandana, which is a South India farmers organization for water management. Basically, it was a platform to negotiate with the policymakers. Because if you happen, some of you might be knowing, in Andhra Pradesh, this came as a big bang approach. After a few years, the same chief minister rolled back. And there were so many PhDs, so many agencies working on that, but then they all became cold. So then we thought, who are the right persons to go and ask what they want? So then we said, okay, well, let's provide a platform. And this Jalaspandana South India Farmers Organization, which worked in Tamil Nadu and all that, we didn't have any staff. It was the farmers who were actually taking a lead. We met ministers, and these farmers asked why this policy should be brought back and so on and so forth. And there's a long list of things. People can contact me. I can share you my experience in putting farmers in policy dialogue. So that's one of the success thing is that the same chief minister agreed and he brought back that PIM in Krishna Basin. He conducted elections after this negotiation. Similar thing happened after the change in the government. It was again, we had a discussion with the irrigation minister, and again it was brought back in Godavari Basin. So what I tell my team members first, when they come with the long list of modules, training modules, sir, we should do this, we should do all those things. I tell them, okay, you prepare it, just provide a platform, be a facilitator, don't do anything beyond, and let farmers keep talking, and then you will know that what actually is required. This is where one of my publication on the Striver policy is there. It's called Participatory Training Program, where the training program, if it has to become very successful, farmers have to ask actually what they want. So in this way, we took forward, and then now we have done a vast experience, trainings and all that, which you will see. And one of the outputs you all witnessed, that is our one Mr. Ravi Kumar from Gondi. That's one of the sub-projects where we did this project. So you see how the farmer, given a chance, that how could they present and how they have understood the whole modernization, and including the water tax and sustainability and convergence with the Panchayat Raj institution, so on and so forth. Now, without taking much time, I have a small video presentation. I would like to take you all to the sub-project which is called Vijayanagar Irrigation System, which is a 600-year to 1,000-year-old irrigation project. Video, please.
The Government of Karnataka amended the Karnataka Irrigation Act of 1965 on 14/6/2000 to empower and enable the active participation of water users in irrigation management, called the Water User Cooperative Societies, or WUCS. In Karnataka, as on date, 3,723 WUCS and 13 project-level federations have been formed. WUCS participation has resulted in a significant impact on the overall scenario of irrigation management, including executing the command area civil works. We can evidently find this impact in modernization of two irrigation projects in Karnataka, namely the 120-year-old Gondi Irrigation Project and the 700-year-old Vijayanagara Irrigation System executed by Karnataka Neeravari Nigama Limited and Command Area Development Authority of the Government of Karnataka. These projects decided to utilize the active and sustained role of water user cooperative in irrigation management to achieve the desired result and long-term management of the resource. This is a unique approach in the history of modernization of irrigation systems, wherein civil works of the field channels, including financial management, is totally entrusted to water users cooperative societies, and the results are encouraging and ongoing. Training emphasized identification of work, selection of construction materials like sand, cement, gravel, etc., and further how to execute and maintain proper gravel thickness, compaction, gradient, levels, mix design, and to maintain proper lining thickness as per drawings. In Gondi, WUCS undertook construction of 12 office buildings and the rehabilitation of 262.29 kilometers of FICs worth 38.97 crore rupees. In VNC, WUCS constructed 15 office buildings and 447 kilometers of FICs worth 109.25 crore rupees. Over 550 kilometers of field channels under the 16 Vijayanagara channels are being modernized by 29 water users cooperative societies. Few women groups undertook CAD package works on pilot basis and are successful in implementation. In addition to CAD works, WUCS made an immense contribution in smooth implementation of the modernization of irrigation structures, main channels, by monitoring the works. The WUCS were also active in safeguarding heritage sites and biodiversity conservation. Overall, the water user cooperative societies are showing great interest and confidence in the project as they are well aware of the benefits of this project post-completion and its impact on their lives. Water user cooperative societies are emerging as a sustainable and community-driven approach for irrigation modernization, setting a benchmark for future projects in Karnataka and beyond.
How much time do I have? A couple of minutes? Finished?
Since we are already behind schedule, so
right. Okay.
Yeah, we need to.
Okay. If any queries, please you can write to us mdknnl@gmail.com and doraiswamiram@gmail.com. We have a lot of materials, and you can also send your engineers and farmers to our project site. They can have a first-hand feel of what actually farmers are doing there. So there is a lot of things which has happened. Thanks.
Thank you very much. Yeah, very strong ownership of farmers. I mean, that's the key for the success of this project.
Yes, sir.
And also consultations I believe you went through. And thank you.
I will just add, thank you for showing a very good gender balance in your video. And this is also important, and it was highlighted by Mr. Podar in his previous presentation, and I think also, well, here we see that the gender balance is not yet achieved, so there are still a lot to do towards achieving gender balance in the project, and including women, empowering women in this project. Thank you.
Can I add one point? Actually, in this water users cooperative societies, as per this the statutory thing, 2 women posts are reserved in the board of directors. Actually, ADB and we discussed during the PPTA, and we set it for 30%. We increased more number. And we will also find that there are some water reserve societies which has got women presidents, and the chief executive officers, that is the secretaries, as women are functioning as the chief executive officers. In this project, we even gave the works to women. You have seen in the video. Thank you. Thank you.
So I will now request Mr. Vikas Rajoria from the Madhya Pradesh project in Kundalia to to come on stage. Yeah.
Good evening, everyone. We are from the Madhya Pradesh state of India, and we are here with a delegation of 10 people. Our secretary is also here, and we are going to present on how we have increased, the state has increased the water use efficiency by using the pressurized irrigation models from the reservoir to farm. And we are going to showcase the two projects which we have completed in a record time of 5 years. They are sizable projects. They are Mohanpura and Kundalia projects. In Kundalia project, ADB is supporting us, but these two projects makes a contiguous area, so we are presenting it in its totality. Okay. So this is here, it is the western part of the Madhya Pradesh, where we have this area in the Rajgarh district. So we have created a network of almost 25,000 kilometers, and we have benefited, it is impacting 1,300 villages and impacting more than 500,000 farmers. So it is perhaps the largest project which have increases the water use efficiency from 38% to 80%. And it is fully SCADA controlled enabled project, and this is delivering from reservoir to farm. So the background of the project, there is a Kalisin basin, the sub-basin of the Chambal, which is having a driest area of almost 400,000 hectares. There we created two reservoirs at Mohanpura and Kundalia of almost 600 MCM capacity, that is amounting to 1200 MCM water. We started the work in 2014 and completed the reservoirs in 2017-18. Then we started the work of this pressurized pipe irrigation from reservoir to farm. We don't have any kilometer of an open canal. It is a completely conduit system. So this is the background. Earlier, the Rajgarh district is the driest district prior to this project, the driest district in the state. Almost 8% of the area is only irrigated in that area. So out of 600,000 hectares of the district area, only 40 to 45,000 is under irrigation services. So after this project, we will show you what other changes happened. So this is the Mohanpura and Kundalia project, which is having a contiguous area of almost 290,000 plus hectares. And these two projects share a contiguous boundary. We have divided into the 7 sub-parts, 3 parts of the Kundalia project. In these 2 parts of the Kundalia project is almost 130,000. The ADB is supporting us. Mohanpura project is state funded. And this is almost the largest contiguous area, which is having the outlet at 1 hectare with this network. So when we talk about this pressurized irrigation thing, always PDN and pins. So people got confused that pin is the something which is the tertiary network is being pressurized. So lift irrigation projects where we lift it to the higher elevations and they take it to by the canals. And this pins and PDNs always what happened in the earlier stages that it is pressurizing the piping the tertiary part of the canal system. But our model is something different. We are from the reservoir to farm, we are pressurized irrigation. We are underground piped irrigation system with an outlet at each 1 hectare and with a residual pressure of 20 meter. This is how this is a schematic of our projects. Here we are taking the water from the reservoir. At the fringe of the reservoir, we are having 7 pumping stations. We have 130 megawatt of power. We are lifting almost 80 cubic of water and catering to almost 290,000 hectares of the land. So this is how we take the water to the higher elevations with using the filtrations and other surge arrangements. And then we're distributing it to the 300 hectares area. We have the control points at 300 hectare area. It is almost a village boundary in our area is almost 300 hectare. So we control the pressure and flow at 300 hectare. Then we take it up to the 30 hectare. 30 hectare also we have the controls at pressure and flows. And then we are rotating the water after 30 hectare. Up to 30 hectare, we are taking the water with the duty of 0.35 liter per second per hectare. And then we are rotating the water beyond 30 hectares. So because we don't have a luxury to have a demand-based system. This is almost 2 lakh rupees per hectare, almost 200,000 rupees per hectare we have done. Because all over the world we have seen there are demand-based systems, which is 4 times more costlier than that. And so we are distributing the water after this area. This is the way we operate. It is totally SCADA control. Almost everybody knows this SCADA of this pump stations, but ours is communicating and talking with the field-based systems also. So we have almost sensors installed in this side. We are controlling the pressure and flow and monitoring and controlling as well as. So this is, we have established a smart water network around this almost 300,000 hectare area. We have almost installed 150,000 sensors in the field, and we are 10,000 control points we have installed, and these all creates a DSS which communicates with this, and we have an internal LoRa system which is doing communication with all these sensors and helping us to control the system. This large system. This is the pictures of completed pictures of the image. We started this thing in 2018. And we have completed in 23-24 with the 2 years of COVID. So we have laid almost 26,000 kilometers of the pipelines and established this 20 pump stations of 130 megawatt. This is a schematic of one of the project, Kondalia Right Bank project, which is one of the largest one, having catering 66,000 hectares area. And there it is a schematic of it. Here we are taking the water to 3 different, we have zoned the area into the basis of the elevation bands, and we are taking the water to save the energy at different levels, and then we are distributing the water from that system. So this is the way we are doing. We have a dedicated power line, 132 kV power line dedicated to the pump stations. So there is no MP, the power surplus state. So we don't have any issue of the power itself. So it is consuming almost 35 megawatt of power. All of the projects totality consuming more than 100 megawatt of 130 megawatt power. So this is the scale of the project, which I have already shown you, that it is almost 26,000 kilometers of the underground pipelines starting from 3.2 meter to 63 mm dia. And these are the all project details, how did, and this the zonings up to 30 hectare, how much we done, 10,000 control points we have installed. So now when we talk about the project, that is not the project thing, what is its bearing on its water use efficiency actually. So when we implemented this project, because we are in the scarce desertified area, almost on the verge of desertification in the drought prone area, so we have less water and more area to irrigate. So we evolved into it. So it is our necessity to make this project. But when we constructed it and then we made it, then we gone through this water use efficiency measurements, how much we have increased the water use efficiency with it. So our claims are not on the basis of this something that is done, which we have measured it, documented it, and validated it. So I'm showing you the case study, what we have done. Yes, everybody know ICID has already given this product efficiency formula as the product of conveyance, application, and all those 5 products. Reservoir, conveyance, distribution, and water application and drainage. So we have almost addressed conveyance and distribution. And water application efficiency also in this ICID and CWC formula is they calculate from 40 hectares. But we have reached up to 1 hectare with the pipe thing. And after 1 hectare also farmer is taking up to 0.2 hectare with the pipe and with a very less discharge. So there is no wastage after that also. So that is also substantially checked. So our current average water use efficiency is 38%, and we are measuring it, and the maximum achievable efficiency which can in the open canal system is 64%. So, but we have achieved almost 80%. So this our state, the Madhya Pradesh is almost the state which is doing this pressurized irrigation systems only. We have stopped this canal-based system from 2014-15 in new projects, not in old projects. So this is the study which we conducted. We have measured the efficiencies in the newly constructed canal-based systems of the state, and which comes out that in 1 million cubic meter of water, it is coming out of 228 hectare and 217 hectare. The state average is almost 170 hectare. So in 1 billion cubic meter hectare, the average is almost 225 hectare. But what we have created a project of 350 for 350 hectare, but what we observed that we measured almost 490 hectare in 1 million cubic meter water. This is one of the validation which comes from the district collector, that it has a 4-fold increase in the crop production. So it was earlier 310 lakh hectare, it was almost 300,000 hectares, 300,000 metric ton, which raised to 1.6 million metric ton in this, after this project implementation. This is, I would like to invite my friend, Mr. Shubhankar, to take a take from further.
Yeah, so actually, when we see there's a sudden spurt in the crop production, we wanted to know whether it is ascribable to our project or these are external factors which have made this happen. So we studied year on year the irrigation expansion in this area, in our command area, right, starting from 2017 year on year up to 2025, that is the 24-25 irrigation season, which was the first time when we actually irrigated the entire command area. So where we find that we have considerably expanded the irrigation service to farmers, and this is actually because of our project interventions that this sudden spurt in irrigation, in agriculture production has come about. So this is just a depiction of the irrigated versus non-irrigated areas. We also have broken it down for each and every crop. So this is just another way of, an aggregate of the pixels. So this last one was actually an NDVI over a Sentinel-2 images. And this is the aggregate of all these 10 by 10 meter pixels. So in Mohanpura, we have achieved 141,000 hectares, and in Kundalia, 135,879 hectares. So aggregating to about 278,000 hectares in Mohanpura and Kundalia. Another way of looking at it is how we have transformed our projects which were initially designed as, originally designed as canal projects. So if you see, we have so in Mohanpura, which was originally designed for only 60,000 hectares, after transformation, we have now, these are the old figures, 145,000 hectares. We have now crossed 150,000 hectares in Mohanpura project. And similarly, there are other projects also where state has actually transformed these canal systems to a completely pressurized piped irrigation system. So we find this, we've done a study of only these 5 projects, where we find that we have saved about 1,200 million cubic meter of storage. So we have avoided creating all these dams and the related rehabilitation, land acquisition, and loss of productive land due to this transformation to pressurized piped irrigation. This is something which we are working on, still a work in progress, where we are actually looking at the future of actual ET measurements, actual soil moisture measurements, and we have a lot of data, and we want to have a very smart decision support system. We already have a flavor of it, but we want to take it further to our farmers so that he can decide, she or he can decide whether irrigation is required or not, what is the kind of quantities that is needed, when it is needed, and for the managers to have a crop planning based on water availability, to have maximum yields and productivity, and ultimately have stronger market linkages to support timely produce sale and value chain integration. So this is still work in progress, and I suppose in another couple of years we'll have completed this. Thank you.
Thank you very much. So we will now invite the next session, but unfortunately, Takeshi and I will have to leave the stage right now, but I will invite the third presenter for the climate resilient integrated irrigation and horticulture development under the HP Shiva project, Mr. Rajeshwar Parma, Deputy Project Director, Department of Agriculture.
And we would also take this opportunity to thank our session chair, Mr. Takeshi Ueda, and our session co-chair, Ms. Alexa Michaels. Thank you for chairing and co-chairing with us, and we wish you a very pleasant evening ahead. Now I would request Dr. Rajeshwar Parma to kindly continue his presentation.
Somebody is coming? No? Good evening, audience. I am Rajeshwar Parmar from Department of Horticulture. For the last 2 days, we have been talking on irrigation, but since I am man of horticulture, I will discuss Himachal Pradesh Subtropical Horticulture Irrigation and Value Addition Project, which is funded by Asian Development Bank. Before I start my presentation, I would like to thank ICID for giving this opportunity to me to present before you. As we all know, Himachal Pradesh is a very small state. It's 17th in terms of size and 21 in terms of population, and 50% of its area is in mountains and less than 10% is under cultivation. If we talk of agriculture, horticulture, the contribution to the state gross GDP is less than 15%, and it's followed by the highest industry 45% and service sector 40%. More than 90% of the population reside in rural areas, and 62 to 65% of the population is engaged in agriculture sector. Himachal Pradesh has got a very varied agroclimatic conditions for growing of different fruits, but when the name of Himachal comes, when we see apple, then everybody knows that it may be from Himachal, because we are pioneer in apple cultivation and production. We are growing fruit crops in more than 240,000 hectare area, but out of this, 50% of the area is under apple cultivation. And you will be surprised to know that out of the total production, approximately 6 lakh metric ton of fruit crops, 80% of production is of apple. So Himachal horticulture is dominated by apple. I was telling that we have got varied agroclimatic conditions. Himachal can grow fruit crops right from subtropical horticulture to dry temperate where there is no vegetation. But broadly speaking, we can divide Himachal into two parts. Below 5,000 feet and above 5,000 feet. Above 5,000 feet, we experience snowfall. And there we can go apple, pear, peach, plum, cherries, and that we are doing. And below 5,000, we go for subtropical and subtemperate type of fruit crops. So before 2018, we were implementing a World Bank funded project, horticulture development project for apples and other crops, and we have successfully concluded with that. But when we compare the income of the apple farmers and the other farmers, although we are growing on very small scale, but the income, those farmers who are growing, they had very subtropical fruits, they have very small income. I can say that the apple farmers getting more than 1 lakh per unit area, and the subtropical farmers getting only 5,000. So this type of disparity, abandoned agriculture, and less use of irrigation water, income disparity, all these factors forced us to think of some developing subtropical horticulture. And all these factors in mind, we approached Government of India for some good project, and we are thankful to Asian Development Bank. They agreed to fund us with this subtropical horticulture irrigation and value addition project in the year 2019-20. Lack of irrigation water, high percentage crop loss, climate change, all these factors we thought these are the project rationales behind this, conceiving this new project. And the major objective of this HP Shiva project was to improve the income opportunities of the subtropical horticulture farmers by expanding irrigation coverage, fencing, providing quality planting material, increasing production under high density plantations, improving profitability of the farmer groups, to provide alternative to the youth, which we could experience in the last 10 to 15 years. They were migrating from rural areas to urban areas for small petty jobs. And last but not the least, we envisage Himachal as a fruit wall of the India. So these were main objectives of taking up this project. I'll not go into details of these areas where we are growing, but before Asian Development Bank financing the project, they wanted to assure themselves whether we have got the capacity to implement such type of project in Himachal or not. Frankly speaking, even we in the Department of Horticulture, before 2019, we didn't have a single demonstration of high density plantation of subtropical fruit crops to show to the farmers or to show to the funding agencies. Before financing the full-fledged project, ADB agreed to give us around 75 crore of financing, and that 75 crore, with that 75 crores, we developed 17 clusters with 16 irrigation schemes. And this HP Shiva project implementing agencies are Jal Shakti Vibhag and Department of Horticulture, and executive agency is Department of Horticulture. Under 17 clusters with high density plantation of 4 crops with modern facilities like drip, solar fencing, mulching, etc. were provided. Intercropping and beekeeping were introduced, and side-by-side preparedness for the main project was also carried out with the investment plan, package of practices development, and designing of the schemes, irrigation scheme, horticulture schemes. The pilot was completed within 2 years, 2022 to 22. With the successful implementation of the pilot, the ADB fact-finding mission in April 2022 validated, and they were ready to finance this main project. The 7 steps under HP Shiva, which we have tested in PRF, the survey and field preparation, animal proof fencing, water harvesting structures, micro irrigation and mulching, quality planting material, value chain development and marketing linkage. The same steps are being implemented in the main project. While implementing this pilot, we had so many learnings, and all these learnings helped us to design for the main project. I'll not go into the details, keeping the constraints of the time. The main project at present is implemented in 7 districts, lower districts, and the major crops earlier were citrus, guava, lychee and pomegranate, but we have expanded now to 4-5 more crops. We have included mango, persimmons for the first 4,000 hectare area, and for the rest 2,000 hectare area, very high value crops like blueberries and avocados we are shortly going to introduce. These are some of the important dates for the main HP Shiva project. The loan approval was in February 23, loan signing was June 23, loan effectiveness was July 23, and the loan closing would be in June 28. The major outputs of this project would be the rehabilitate and construct around 162 to 165 irrigation schemes. And in horticulture, the horticulture plantation, new innovative technology adoption, capacity building and sustainable practices, a study on climate resilient crop varieties, carbon credit financing, nursery development, building of incubation and training center, etc. would be taken care of. And the third major output would be the post-harvest facilities, building institutional capacities, marketing and promotion. These are the blocks where we are implementing this main project. The major expected outcomes of this project would be a total 60 lakh plants will be planted in under 6,000 hectare area, and total production we are expecting around 1.3 lakh metric ton. And we are going to give direct employment of more than 1.35 crore man days. And under this project, Himachal has become the first state to draft its own horticulture policy in the state. This is the very good outcome of the project. Last but not the least, you can see the activities we have taken where the agriculture was totally abandoned and irrigation sources were available. We have developed the orchards like this, and we expecting, I told you in the pilot, we have tested 3-4 crops, so you can see the produce. Last but not the least, I once again thank you, the organizer, for giving me the opportunity. Thank you very much, sir.
Very, very informative presentation. Thank you so much, Dr. Rajeshwar Parmar. Ladies and gentlemen, now I invite to speak on the dais Mr. R. Thayala Kumar, PD cum Chief Engineer, Water Resources Department, Trichy and Srinivas Trichy. and he would be speaking on the topic implementation of a decision support system in the Venar Sub-Basin Kaveri Delta project. I also invite the co-speaker, Mr. Srinivas Rao, DSS expert, Kanuri Limited.
Thank you. And very good evening to ladies and gentlemen. I congratulate ICID for its Platinum Jubilee celebration, and I feel more proud to be here and for the presentation. I thank ADB experts, Dr. Takishi and Dr. Alexia, for their support through ADB. We are presenting the subject implementation of decision support system, DSS. Me and Mr. Srinivas Rao jointly presenting this subject. We are mainly concentrating in Kaveri River Basin because we are from Tamil Nadu, the heart of Tamil Nadu. And the river Kaveri, we all know it is originating from Thalai Kaveri, from Brahmavuri Hills of Kodagu district of Karnataka state. And it travels to a length of 800 kilometers, 320 kilometers in Karnataka, and 60 kilometers of common border, and 420 kilometers in Tamil Nadu. The Venar Basin and the Grand Aniket Canal branch from Kaveri River at Grand Aniket. The network is about 27,300 kilometers of natural rivers, canals, which function both as distributors to irrigation water carriage drainage. Here, the Kaveri Basin consists of three sub-basins. One is Kaveri and Venar, and another one is canal, Grand Aniket Canal, we called J Canal. The irrigation system of delta has evolved over centuries. The Grand Aniket was built by Emperor Karigat Cholan during the 200 AD, and the rivers are formed naturally, and the canal drains systems requires upgradation to adapt the climatic change. The irrigation and drainage system is now in disrepair condition and then ineffective at conveying irrigation and flood waters. And another thing, malfunctioning of tail end requires regulators allowing seawater intrusions to the channels. And finally, communities in the lower coastal reaches are disadvantaged as they lack access to both fresh groundwater and fresh surface water. These are all the existing conditions of our basin. By adopting climatic conditions in Venar sub-basins of Kaveri Delta, with the assistance of ADB, we have proposed 3 phases in Venar sub-basin. One phase consists of 6 rivers, costing about 1,052 crores, which we have completed during 2021-22. And another phase consists of 6 rivers. PPR in approval stage. Today also we have consulted with the CWC and it is attaining its final stage. It's for approval. And third phase consists of 8 rivers, and this PPR preparation is under progress and is to be implemented with the assistance of ADB. The project components completed in the first phase is resection of rivers, drains, embankments, repairs and reconstruction of structures like sluices, drops, retaining walls, and etc. The construction of tail end regulators, as I told you already, to avoid seawater intrusions, upgrading of pumping systems, which is in existing, and an improved water and flood risk management system with DSS component. The necessity of DSS, the natural rivers have been adapted to function both irrigation canals and drainage carriers. These are all the existing conditions. Complex network, natural and built canals, rivers and drains. Very flat terrain makes the drain system more vulnerable to flooding and requires comprehensive flood management tools. The distance between the reservoir and the distribution heads demand effective real-time decisions-making tools, effective operation of tail-end regulators to avoid seawater intrusion. These are all the main points I would like to emphasize regarding DSS aspects. I would like to invite Mr. Srinivasa Rao, DSS expert, to continue his presentation. Continues. Thank you.
Thank you, Chief Engineer, sir. I think there is a limitation in the time. I'll finish it as quick as possible. I want to tell you, the audience, that what a well-thought project can do wonders in the state of Tamil Nadu. The major achievement here is construction of new tail-end regulators, which is almost 8 kilometers from the existing tail-end regulators, where we are losing nearly 50% of one district's cultivable land, right? By having this new tail-end regulators, now the fresh water is reaching near to the seashore. And we are also monitoring the groundwater levels, salinity levels in those areas near to the tail-end regulator, and we are noticing there is a remarkable change in recharging the fresh groundwater. This is an achievement, I could say, and the farmers are recognizing the importance of these tail-end regulators. And they are, now they are seeing the fresh water which is available in the river channels. The project key outcomes are conveyance efficiency, where we have installed water level recorders upstream and downstream of the regulators, and flow measurement system. And we also provide flood alerts to district disaster management authorities based on the rainfall as well as the levels in the river. There is a coordination between Joint Director Agriculture of that particular district, District Commissionerate, as well as irrigation. So hence, there is a proper coordination in mitigating a flood and to address the disaster which is being induced by the cyclone and other effects. So since the first session in the morning, we are all talking about irrigation management and all the stuff, but this DSS is being set up since almost 3 years, and we are successfully running. And apart from that, there is a manpower, there is a scheme operation center. I don't want to get into the details of this. There is a workflow management in place where every AE will generate a crop, whatever demand, irrigation demand, and then it has been forwarded to the respective AWEs, and it goes up to SC for the approval for that particular season's irrigation requirement. So based on the approval only, the water is allocated to that particular section. And this is a central monitoring station where almost every fortnightly and weekly there will be a review from executive engineers and AWEs, where they will take a review of the current status of the crops as well as the water requirement. The final slide, the DSS system is designed to create a crop water table. There is a coordination from Agriculture Department. They give us the water requirement for every cropping pattern, cropping season, and we do an estimate of irrigation need per hectare, and then there are execution stages. So, thank you team.
Thank you, Engineer Arthayala Kumar and Engineer Srinivas Rao for your very informative presentation. Ladies and gentlemen, the last technical session of the day, and I request Mr. Milind Murudkar, Managing Director, Sai Sanket, to kindly come forward to present on climate smart irrigation management solutions. So may I request you to kindly conclude in 8 minutes? Thank you.
Good evening, everybody. This is my final, I think looks like I'm the last one in here. This is actually regarding climate smart irrigation management solutions. Where is the slide? Okay, this is typical irrigation, pressurized irrigation system, wherein there is a source, then pumping station, then online filtration system, surge system, surge protection system, air wall system, and then at every, let's say, branch, there is a control we call zonal system, zonal management system. Then it goes to 30 hectare. 30 hectare, there is a rotation management system. And typically this Madhya Pradesh jobs, at 30 hectare, there is rotation at 30 hectare for every 5 hectare unit, and the water get utilized and rotated by farmers at every 1 hectare. So any given time, water comes to 30 hectare continuously, and then there is rotated for every 3 units, and then other 3 units rotate next time, next irrigation cycle. So typically this project is designed, let's say, for 0.35 LPS per hectare. Flow rate available at 30 hectare is 0.35 LPS into 30 is around 10.5 LPS. To meet water demand, we have to supply around 3.5 LPS per hectare. To achieve this rotation is the must, and any 3 sub-units of 5 hectare will work any given time. Let's say it will work for 12 hours, 3 units, 12 hours, other units, or we can change this schedule every day or every 2 days or every 3 days. For that, as per cropping pattern, as per farmer demand, we can do that. So every 5 hectare sub-unit will, I'm audible, please? Yeah. So below 5 hectare, there will be manual rotation by 1 hectare by farmers. To make sure this project works, and rotation is the part of the project. Rotation training is must for the farmers. For that, crop water, there are a lot of trainings required. So I will go. So going further, up to here, any standard project can work, but below that we have to do optimization of water utilization. For that, climate smart irrigation management system, as like that, when there is no rain, no water to be given. Crop water requirement will vary as per crop growth. More water will lead to over irrigation, less water will lead to under irrigation. So precise monitoring of water requirement is need of the project. Going further, actually this topic must have covered by Mr. Abhim Bashyan and many other people, but let's say this is advancement in further precision irrigation management. You are using satellite as a virtual soil moisture sensor and virtual water management tool. So the data, okay, going back.
satellite actually, right now the free satellite available is around 10 by 10 units, 10 by 10 meter. We can monitor this thermal image and process to get the water utilization data. So various parameters can be taken from this satellite data, that net irrigation area, vegetation cover, precipitation, precision, irrigation water requirement, ET, transportation, soil moisture root zone, applied water, ET from applied water, runoff from applied water, percolation from root zone, and dry matter production. So we have done one demonstration at Kundalia project. The previous presentation by Mr. Rajoria sir and Shubhankar sir. We have done this unit in the Kundalia project, where we have taken few samples of 30 hectare units, and we have taken a demonstration how this technology can be employed for our project. So this slide shows that every 10 by 10 meter area we can get ET. Then this actually, let's say when you want to irrigate, next date of irrigation, what is the requirement of advised water for that day, that is also can be seen here. And then what is the accumulated cumulative volume we have applied, irrigation volume we have applied. And then whether irrigation is enough or not enough, and what is our productivity kg per hectare. So more efficiency and more and if distribution uniformity will increase yield and incentive to farmers. So this tool can improve the as Mr. Rajoria sir and Shubhankar sir said in his presentation. They have said for 60,000 hectare the project was planned by open irrigation, and now they are irrigating more than 180,000 hectare. So this tool can also help to optimize, and maybe more hectares can be increased with this tool. But going ahead to this depends on farmer, how to take this tool to farmer. There are some tools required. Let's say we are talking about one farmer management app, where farmer will get advisory, farmer will understand when to irrigate, what to irrigate, and automatically it will be integrated to decision support system at control center. So as I said, there is a gap. Whatever technology we are talking, it needs to be taken to the final end user, that is farmer, and to go that the current any project, it is talking about this structure. First is basic farmer, then there is a territorial constituency, generally around, let's say 1,000 hectare, and then water user association, then distributor committee, project committee, apex body. So there is a big gap to educate final end customer. WA is not enough. We need to create more farmer initiative to reach to this level. Technologies of climate smart irrigation depends on farmers' adaptability, and for that we are suggesting some tool that we are saying that now we have explained the projects are going on pressurized irrigation, wherein 20 or 30 hectare there is a unit where water is getting rotated, and for rotation is depend on this 30 hectare group, which will decide how to utilize this water in best efficient way, whatever the project is thought, whatever the technology is employed for the project. So we are suggesting here, so there is Jal Mitra for every sub-units of 5 hectare. Then at 30 hectare there is a Chak committee, and the in charge will be Jal Pradhan, and at village level there will be village Jal Sevak, and then it comes to this standard process, territorial constituency, WA, distributory committee. So this implementation, we are talking about, let's say there is a farmer, then there is Jal Mitra for every 5 hectare, 20-30 Chak committee, where this Chak committee is the most crucial element to make sure that the utilization of water happens in most efficient and happiness and success with successfully implemented. Then
I'm sorry. Village Jal Sevak at every 200 to 400 at the village level, and farmer relationship officer, FRO, for every 15,000 hectare, and then every 5 to 6 FROs will have farmer relationship manager and irrigation manager. So I would like to emphasize, actually the time was very short. Please sir, conclude. Okay. So I could have run up given more better insight of these details, but anyway. So to make the climate smart irrigation system farmer participative management, we need lot of things to do. The training is and teaching to farmer to end level requires lot of intervention, and Sai Sanket did more than almost 1 million hectares, 10 lakh hectares we have under implementation, and more than 600,000 under implementation. There are all these components are successfully implemented. So this is quickly, I will go through the pictures. And we have control room, then there was surge protection, primary filtration system, zonal management system, outlet management system, IoT web SCADA, OMS control system. This is ECM tools and farmer management tool. These are the applications for farmer management tools and pumping station solution. Then we have done lot of training, capacity building work. Okay, I thank you very much for this because time is short. Thank you very much.
Thank you, Mr. Milind Murudkar. Ladies and gentlemen, we are extremely thankful to all our esteemed speakers for their valuable participation in this session, and I would request our President ICID and Secretary General ICID to kindly come on the stage so that we can present them with a memento. And I would request Mr. Doraiswamy R to kindly receive the memento. I would request Mr. Vikas Rajoria and Mr. Shubhankar Biswas to kindly come forward next. Thank you, Mr. Doraiswamy. Now I would call upon the stage Mr. Vikas Rajoria and Mr. Shubhankar Biswas, and I would request Mr. Dr. Rajeshwar Parmar to kindly come forward, please. I request Dr. Rajeshwar Parmar to kindly receive the memento next, and I would request Engineer Thaila Kumar and Engineer Srinivas Rao to kindly come forward, please. And I would request Mr. Milind Murudkar to kindly come forward, please. Next. Engineer Thaila Kumar, Engineer Srinivas Rao. Now I would invite on the stage Mr. Milind Murudkar. Thank you, President. I would request you to kindly remain on the dais itself. Ladies and gentlemen, now we will express our heartfelt appreciation to all the organizations whose unwavering support has made this event possible. It is now time to felicitate our valued supporters who stood behind the vision and success of Indo-Global Irrigation Summit 2025, and I would also request our Secretary General to kindly grace the dais at this moment. I would request representative from Water Resources Department, Maharashtra, to kindly come forward and receive the felicitation. Water Resources Department, Maharashtra. Next, I would request Rungta Steel to kindly come forward. Can we all please appreciate them with a good round of applause, please? Their continued support has made this event a success. Water Resource Department, Maharashtra. Can I also request representatives from WRD Bihar to kindly come forward? So you are from Maharashtra? Thank you, WRD Maharashtra. Now I would request Rungta Steel, representatives from Rungta Steel to kindly come forward for felicitation. Rungta Steel. So are you all from Bihar? Are Bihar se? Yeah. Okay, okay. I think they misunderstood. No problem. जी जी जी. Next, WAPCOS to line up, please. This is the Water Resources Department, Bihar. Thank you so much for your support. I would request now Rungta Steel to come. This is Water Resource Department, Bihar. Thank you so much, WRD Bihar. I would now request Rungta Steel to kindly accept the felicitation. Rungta Steel. Next, I would invite WAPCOS. Post WAPCOS L&T to line up, please. This is Rungta Steel. Thank you so much for your support. We truly, truly appreciate you. Now we would like to felicitate WAPCOS, representatives from WAPCOS. Thank you so much for your support. We truly appreciate your contribution in making the summit a grand success. Next, I would request Jain Irrigation Systems to kindly line up. Now we would like to honor L&T team, please. Thank you, L&T, for your continued support. Next, I would request Electro Steel to line up, please. Thank you, L&T, once again for your continued support. We really appreciate it, and we look forward to all your support in our future endeavors as well. We would like to honor Jain Irrigation Systems Ltd now. Jain Irrigation Systems Ltd. Electro Steel to line up, please, and Aqua to line up after that, please. This is Jain Irrigation Systems Ltd. Thank you so much for your support. We really appreciate it. Next, we would like to honor, felicitate Electro Steel. Electro Steel. Thank you, Electro Steel, for your support. We would request team from Aqua and team from Jindal SAW Limited to kindly line up. This is Electro Steel. Thank you so much for your support. Thank you, Electro Steel. Now we would like to felicitate team from Aqua. Thank you so much, Aqua, for your continued support to us. I would request Vasar Labs and Sai Sankat to kindly line up now. This is Aqua. Thank you so much for your support. Now we would like to felicitate Jindal SAW Limited. Jindal SAW Limited. Thank you so much for your support, Jindal Saw Limited. We really, really appreciate your continued and unwavering support to us. Thank you. Next, we would like to felicitate Team Vasar Labs. Thank you so much, Vasar Labs. Ladies and gentlemen, can we put a bigger round of applause for all our supporters? Thank you. This is Vasar Labs. Thank you so much for your support. Next, I request Team Sai Sanket to kindly come forward. We would like to felicitate them. Next, I would request Photonics, Team Photonics to kindly come forward. This is Sai Sanket. Thank you so much for your support, Team Sai Sanket. Thank you so much, Sai Sanket. Next is Photonics. Thank you so much, Team Photonics. I would request Agrocast and Jai Balaji Group to line up, please. This is Photonics. Thank you so much for your support, Photonics. Next, we would like to honor Thank you so much, Photonics. Next, we would like to felicitate Agrocast. Thank you so much for your support, Agrocast. May I request Jai Balaji Group also to kindly come forward. This is Agrocast. Thank you so much, Agrocast. Last but not the least, Jai Balaji Group, please. This is Jai Balaji Group. Thank you so much for your continued support, Jai Balaji team. Thank you so much. This is... Now I would request Dr. Marco Arceri, President ICID, for his concluding. It's done, it's done. It's only 14. May I request President ICID for his concluding remarks, please?
Yes, thank you very much. After this marathon, I will be very brief. Of course, I would have many things to say, many sensations, many impressions, but for the sake of time, I would just like to thank very, very heartfelt the central office of ICID for this amazing work, the amazing work that has been done by all of the people that are working for this organization in central office, excellently coordinated by Secretary General Dr. Gupta. I think it is an amazing result. I think this success of this summit, first Indo-Global Summit on irrigation, and hopefully from next year, irrigation and drainage, I think it's going to be one that will be remembered, of course, for several reasons. Also because this is the summit where we celebrated the 75th anniversary of our organization, which is something really, really amazing and a very prestigious achievement. But of course, also because we have announced here, and we will keep on working for further dissemination and achievement, the World Declaration on Best Practices of Irrigation for food and water security. I think this is also a very outstanding moment that we shared. Of course, the prestige of this event was also very much enlightened by the presence of many people who came from very far away, from thinking, for instance, of the governor, Her Excellency, the governor of Australia, South Australia, I'm thinking and the delegation, of course, I'm thinking of our esteemed and prestigious President Honoraire, who came from Canada, Professor Chandra Madhamutu. He came a long way to be here with us. Especially, I'm very grateful personally for your presence here. And of course, again, I'm very pleased and very honored of the presence of the other President Honoraire that has made us a gift coming here with us. And of course, Vice President Honoraire, Mohamed Bartali from Morocco. And of course, I really would like to express my sincere gratitude to all of you who participated in these 2 days, the presenters, participants, the expositors, and especially those who supported us with their help and their financial support. Without your help and your support, this could not have been happening. I really hope that this is only the beginning of a journey that we will be taking together, starting from this year. And I hope that these first 75 years will introduce us into another 75 years of success and activity for our organization. So again, thank you very much for your participation, for being here, to all of us, to the people who have helped us on the stage, for the ladies who have helped us in coordinating all the tokens, not anyone excluded. So thank you very much and see you next year. Thank you.
Thank you, President ICID, for your concluding remarks. And I request now Dr. R.K. Gupta, Secretary General ICID, to propose vote of thanks.
Good evening, everybody. When we decided to organize this conference in March 2025, because our foundation day is on 24th of June, we were a little bit hesitant because time was too short and a lot of activities had to be done. And if we are celebrating a platinum jubilee, then it has to be something, and we have to do some activities, and we have to invite many guests, and we have to be prepared technically also. So we were a little bit hesitant. I talked to my staff first in central office, and I took a meeting, and I asked my staff, what is your decision? I will implement that. I will go with that. I will go with you. And they all said, okay, let's go ahead. We will celebrate. We will do it. We will make this conference a success. Then I talked to my president, and he was very happy, and he supported me, and he guided me what to do. And then we planned few activities, and time was very short. But somehow, my staff worked very hard, day and night. And today, I can say that this conference, this summit, is a success, not only because of my staff, but because of all you have arrived here from different parts of the country and from different parts of the world. And I'm especially grateful to our President Honorary, Professor Dr. Chandra Madhamutu, who has accepted our invitation to come here to join this event. And he's directly from Canada. It was a long flight for him, but he arrived. We are very thankful and grateful to you, sir. We are grateful to our President Honorary, Mr. Felix. He accepted our invitation, and he arrived directly from South Africa, and he is with us. We are very thankful for accepting our invitation, and it's more than a pleasure to meet you personally. Professor Bartali is not here, but yes. I met Professor Bartali 2 months ago in April in Nigeria, in Abuja, in African Regional Conference. And first time I met him, and I was sitting talking to him, and I asked him, we are planning to, I was also a little bit afraid whether I will be able to do this conference in June or not. So in April, I was talking, we are planning this conference. Would you like to join us? He said, yes, I will come. And I will see the Taj Mahal also. So that was the encouragement for us. And today he is here, and he is visiting Agra tomorrow. And it is very nice to see you, Professor Bartali, here. We are thankful to you for arriving here. And we are thankful to all our supporters. They are here. And it's not this conference only. We talked to you that it's now a collaboration, and we have to move together. We have to do together many activities, and we have to plan few things so that we can go ahead in the direction of sustainable agricultural water management. In ICID, we don't say goodbye or bye-bye. We say see you again. So this time I will say that see you again somewhere in India in the next Indo-Global Irrigation and Drainage Summit 2026. Thank you. Yes, but before that, we have a very, very important event of ICID. It's one of the most important event, World Irrigation Forum. World Irrigation Forum, 4th Irrigation Forum, is being held in Kuala Lumpur, Malaysia, from 7th September to 13th September this year. And I invite on behalf of ICID all of you, please join this event and make this event success. Thank you.
Thank you, Dr. Gupta, for your kind words of thanks. Ladies and gentlemen, as we draw the curtain on the Indo-Global Irrigation Summit 2025, we leave with a renewed commitment to water-secure, climate-resilient future. Over the past 2 days, we had witnessed inspiring dialogues, cutting-edge innovations, and a shared determination to collaborate across borders and discipline. On behalf of ICID, I thank all of you once again and look forward to your active participation in all our future endeavors. Thank you. Namaste, Jai Hind, and have a great evening ahead. May I also request all our ICID staff to kindly come forward for a group picture. Thank you once again. Namaskar. Jai Hind. Once again, request all ICID staff to come forward for a group picture. Thank you.